Hi, and welcome to this course. My name is Maximilian Schwarzmuller, and I will be your instructor in this course where I will teach you React from the ground up, step by step, and in great depth. In this first course section here, I'll get you started with this course and get some organizational things out of the way which you should know about React and this course. And thereafter, after an optional JavaScript refresher section, which you can take if it's been some time since you last worked with JavaScript, we're going to dive right in and explore React in great detail. And speaking of that, let's start with the most important question. What exactly is React? So what is React and why exactly would you use it? Well, if we visit the official webpage, react.dev, we get an answer. It's a library for web and native user interfaces. So put in other words, React is a library for building user interfaces. That's what React is all about. And as it turns out, it's a JavaScript library for building user interfaces. But that, of course, still doesn't answer the other question. Why would you use it? And the answer can be found if you visit a webpage that uses React, like for example Netflix. As you navigate around on such a website, you'll see that all these transitions are super smooth, pretty much instant, and you never have this effect where you seem to load a new page, so where you seem to wait for a new page to be sent back by the server. To some extent, it therefore feels like a mobile app. Because in mobile apps, getting instant feedback and having smooth transitions is pretty much the standard. And it's libraries like React that help us build such user experiences, such user interfaces for the web as well. Because React, since it's a JavaScript library, uses JavaScript in the browser to update the page and the user interface we see on that page without reloading the page. JavaScript can do that because JavaScript in the end runs kind of in the background of a website, and JavaScript is able to read and manipulate the web page after it was loaded. So JavaScript can, for example, make sure that as I click on the Movies tab, it fetches the movies data behind the scenes in the background without reloading or leaving the page, and it then updates what I see on the screen with that movies data, leading to that smooth transition between those pages. But wait a second, since this is all JavaScript in the end, why do we need this React library for JavaScript? Because, as you will see in the next lecture, where I'll compare using just JavaScript to using libraries like React, working with just JavaScript, of course, is an option, but it isn't a great one. It's cumbersome, it means more work for you, it can be more error-prone, and especially if you're building more complex user interfaces and more complex applications like this Netflix web app, then using just vanilla JavaScript, so without any library like React, would just be a huge pain and wouldn't be a very realistic option, to be honest. So I told you that often using just JavaScript isn't a great option and that instead using libraries like React is better, because React offers a simpler mental model and provides an easier way of building complex web applications and web user interfaces. But of course, you don't have to believe me. That's why I prepared two basic web applications, two basic demo websites, which essentially have the same content, some tabs you can click to change the content below these tabs, but I built this application with React and also with just JavaScript so that we can compare these web applications. Now, I built these web applications here with help of Code Sandbox, which is an in-browser, cloud-based code editor and development environment, which allows you to, for example, work on React projects without installing any software or tools or anything at all on your local system, and which therefore provides you with an easy way of getting started with React. And therefore, attached to this lecture, you find links to these 2 demo websites, and you can therefore use your browser to play around with them, explore them, and change the code in any way you want. In case the vanilla JavaScript version shouldn't load correctly and the content below the first tab might be missing, simply click this refresh icon here and it should reload and display this content. Now in the vanilla JavaScript version, we got 2 important files. We got the index.html file, which in the end contains the HTML elements that are responsible for displaying the majority of this page. And we got the index.js file, which is responsible for getting hold of these buttons, for adding click listeners to these buttons, and for then updating the UI as these buttons are clicked and these click listeners are triggered. Now for this course, I do assume that you do have basic JavaScript knowledge, and therefore I won't explain this JavaScript code in depth here. Instead, you can simply pause the video and go through the code on your own with help of those links that are attached to this lecture. And if you're struggling to understand this code, I strongly recommend that you do pick up some basic JavaScript resource in addition to this course, and that you take a look at the next course section where I give you a JavaScript refresher. In the end, in this code, as mentioned, I'm setting up these click listeners, and we're executing this function here whenever a button is clicked. And then in this function, I'm in the end ensuring that the clicked button receives the active CSS class by clearing that class from all buttons and then adding it to the button that was clicked, which is this event target of that click event. And I'm displaying the content below the button by loading the content from this content array, which is an array that contains more arrays inside of it. And that selected content is then passed to a display content function where I in the end create a string that contains a bunch of li elements as text. I create an unordered list element. I clear the tab content element below the buttons so that then to that list I can add that list content string as inner HTML, and I then append that list that contains that list content to that tab content. And that's how this content ends up on the screen as I switch tabs. That's what I'm doing here in JavaScript. And this, of course, is a fairly trivial app here, as you can tell, but still, nonetheless, it does take quite some code to make this app work this way. And of course, there would be alternative ways of writing this code, but I chose an approach that hopefully is also pretty easy to understand and follow along. Now, if we take a look at the React app, we have the same behavior, but the code is very different. If we take a look at this folder, we also find an index.html file in the public folder, but this index.html file is pretty empty in the end. Its body section only contains one div in the end with an ID of root, but this div has no content, because indeed here in the React app, React is responsible for rendering the entire user interface. And it's this index.js file where the React journey starts, so to say. Now you will of course learn all about React and how it works and what this index.js file does later in the course. So at the moment, you absolutely will not understand everything here, and that's totally fine because this is just a first demo to show you the difference between React and JavaScript, not to teach you all about React in this one single lecture. Now, nonetheless, you should know that in that index.js file, we in the end select this div with an ID root. So this div here is selected, and React takes over that div and starts controlling the div and its content. It's then the app.js file that contains the important code, so to say. In there, we have a function called app, and in this function, there is something strange, because we got a bunch of HTML code in there, and that is definitely not a default JavaScript feature, because by default, if you start adding HTML code to a JavaScript file, you'll get an error. This, by default, is not supported. Now, it does work in the React project because of how this overall project is set up behind the scenes. And later in the course, you will also learn how to set up such a React project locally on your system. Here in Code Sandbox, it's already set up such that it works. But then once it is set up correctly, it's one of the key features of React that you can blend HTML and JavaScript code. And if you then take a look at this HTML code, you'll see that in here, in this app.js file, we in the end got all the HTML code with this header and these buttons and this unordered list that we before found in this index.html file when working with vanilla JavaScript. Now it's all in that one single JavaScript file, but what you'll also notice is that all these JavaScript instructions that we had in the vanilla version are missing in the React version. Instead, in that app.js file, we just got that HTML code, and then in that HTML code, we got some dynamic elements, some dynamic pieces of code blended into the HTML code. Now again, you'll learn all about writing such React code later, but what this code here in the end does is it defines different states, you could say, of the different HTML elements. For example, that this button here should have an active CSS class added to it if this active content index thing here, to which I'll get back in a second, is equal to 0. So if this condition is met. Otherwise, an empty class, so no CSS class, will be added. And we have similar conditions for the other buttons. Down here, where I'm outputting the actual tab content, I have my unordered list here as HTML in JavaScript. And then there we got more dynamic content, where in the end we're loading such a nested array from that content array, depending on which button was clicked. So depending on this active content index thing here. And then all these items in that nested array, so all these string items here, are in the end converted to list items, something that also doesn't work in vanilla JavaScript but works in React. And this is how all these list items are in the end added to this unordered list here. Now this active content index thing is kind of like a variable. It's created and controlled with a React feature called useState. And this in the end creates a dynamic React managed variable, you could say, that can be updated with help of this setActiveContentIndex function here, which for example gets used for these click listeners, which are also directly added to the buttons right inside that HTML code here. And then it's this ActiveContentIndex variable that changes and influences how the current UI looks like. Because React basically watches this variable, and whenever it does change, it takes a look at your HTML code here, checks all these conditions and executes all that code, and sees if that code now should lead to a different UI than what was rendered before. And if a different UI is needed, React goes ahead and updates the UI. It does all these things automatically for you. Because when working with React, you in the end write declarative code, which means you define the target UI state or states, not the steps needed to get there, and React will figure out how to get there and perform the necessary steps. So when writing React code, you're writing code in a declarative way. And that's a key thing to understand and keep in mind, because that's how React works in the end. On the other hand, when writing vanilla JavaScript code, you're writing imperative code, not declarative code, which simply means you're not defining the goal, but instead the steps needed to get there. And as you can see in this example, that's of course way more cumbersome and difficult. Because even though this here is a very basic and simple example, we do have to find a lot of steps to get the desired behavior. And it's easy to forget a step or introduce some error along the way. Updating this code and handling a fourth button also could become unnecessarily complex. So here we got these step-by-step instructions and therefore this imperative approach. In React instead, it's all pretty lean, it's less code that needs to be written, and React takes care of updating the UI. React uses JavaScript under the hood to update the UI, and we instead just define our conditions, our target states, and when these states should change, and React will take care of the rest. So now that we know why we might want to use React instead of just JavaScript, and before we start diving deeply into React and we'll learn it from the ground up, I already want to make sure that we get our hands dirty and that we actually start working on our first React app, even though we don't really know a lot about React yet. But from what we've seen thus far, we might be able to solve the following tasks. And it all starts with a new, updated demo app. And for that, attached to this lecture, you find another link leading to another React web app on Code Sandbox. And of course, it's pretty much the same app as before, but I actually updated this content array here, and I added a new fourth nested array in that content array, and that fourth array inside of this content array will become important for this exercise, which is why you should follow that link you find attached to this lecture. Because in this updated app, the goal now is to add a fourth button with any text of your choice, doesn't really matter. But when this fourth button is clicked, the content for this button, so this fourth entry in this content array, should be loaded and displayed on the screen. Now implementing this, of course, will be challenging because you don't really know React yet, despite the last lecture, but definitely feel free to pause the video at this point and try solving these tasks on your own, before then after a short pause, we'll solve it together. If you can't solve it, by the way, no worries, we're just getting started and you haven't learned React yet, so that's absolutely fine. But still, you might want to give it a try. So, did you succeed? Let's try it together. For this, of course, it's important that you're using this updated version, which you find attached, where you do have this extra entry in this array. And then with that, we can go down to the buttons and add another button here to this menu. And for that, I'll just copy one of the existing buttons and paste it in here, maybe at the end of the menu, but the exact position doesn't matter. And I'll give it a text of React versus JS, though that text, of course, is up to you. Now we get this button here. If I now click this button, I actually get a strange behavior though, because now the third and the fourth buttons seem to be active simultaneously, and I do load the content of this third button. Now we do get this behavior here, because of course I copied this third button and I kept all the logic that was on this button. But now we need to adjust this logic on this new fourth button. For example, here, for this click listener in this function that's executed when that click occurs, we should set the active content index to 3 to select the fourth item in this content array. Because as you know, in JavaScript, arrays start with the index 0, so that in the end will make sure that we, for example, down here, will use the fourth item in this array by using the index 3. Here in this condition, we also should compare the active content index to 3, therefore, to make sure that this button here only receives the active class if the content index is 3. And that actually is all then. If you save that, maybe reload here, though it shouldn't be required, you should be able to now select this button and see the content for this button and have only that button being active. So now all the buttons work as intended, this fourth button included, and therefore we got our hands dirty, we wrote our first lines of React code, and we solved these tasks here. And of course, as mentioned before, if you were not able to do this on your own, that is absolutely fine and absolutely to be expected, because you haven't even learned React yet. I haven't taught you React yet. I just showed you one basic first example, and we're going to learn React from the ground up in this course, of course. So no worries if you were not able to do this on your own yet. So with all that, you now got started with React and you learned why you might want to use React and what its core philosophy is in the end, this declarative approach. Now I want to briefly introduce you to this course and explain what you can expect from this course. And as you can tell by taking a look at the course curriculum, it's of course a huge course, packed with content. And you can think of the content in this course as two main packages, you could say. Because we'll start by setting a solid foundation And the next course sections, the first couple of course sections, will all be about introducing you to these fundamental React concepts you must know, like components, JSX, props, state, events, styling components, hooks, debugging, and much more. You will learn all these things over the next sections, and you will therefore have a solid React foundation once you've finished those sections. Thereafter, we'll dive into many advanced concepts, which you also must know as a React developer. We'll dive into concepts called refs, portals, how to handle side effects and what side effects are, into advanced hooks and what hooks are, custom hooks, HTTP, Redux, routing, Next.js, authentication, and much more. This course is huge. And the course curriculum, of course, allows you to dive into the content you're most interested in, though I will say that the different course sections, of course, build up on each other. So I do recommend that you simply complete the course lecture by lecture, section by section. Now, in addition to all the video lectures in this course, you'll also find plenty of quizzes, coding exercises, assignments, and demo projects in this course, allowing you to practice what you learned. And I of course recommend that you do use these practice opportunities because only practice makes perfect. And therefore, if you do go through the video lectures and all the course sections, and you do dive into all the quizzes and exercises and so on, you'll be a React developer by the end of this course. Now, this course is packed with content, but this course also comes with two optional paths you can take. The main path you can take is the standard path, which is the path I recommend for most students. For this path, you simply continue. You start in lecture 1 in section 1, and you go through the entire course, lecture by lecture, section by section, in the order you find in the curriculum. This way, you'll learn all about React in great detail, step by step, in the right order. But if you're in a hurry, or if you already know React and you just want a refresher, you could also consider finishing section 1 and then jumping right ahead to section 30. Attached to this lecture, you also find a link that will directly take you to that section if you want to follow that fast track path. Because this course section will then give you just the React essentials. Less deep dives, less advanced concepts, less examples, but you'll get those essentials, and therefore, if you don't have that much time or you don't want to go through the entire course, this fast track path and this dedicated section is for you. By the way, this React summary section will also be interesting for you if you did complete the standard path. Because if you completed that path and you then want to revisit the core React concepts, you can also use this React summary section. Now, obviously, this course has a lot of content, but I want to make sure that you also get the most out of this content. And of course, since this is a video-based course, this all starts with watching the videos. But watch them at your pace. Use the video player controls to slow me down if I'm going too fast or speed me up if I'm going too slow. Also, take advantage of the fact that this is an on-demand video course. Watch the videos whenever you have time for them. There is no time pressure on you. In addition, feel free to repeat videos or even entire sections if certain concepts aren't clear immediately. Pause the videos from time to time and try out things on your own, because that is how you will get the most of this video-based course. And that's in general a recommendation I have for you. Code along and practice what you learned. Also, practice what you learned in your own projects. There are plenty of demo projects and examples in this course, but you of course absolutely should also come up with your own basic example projects and try building those with React, with the React knowledge you gain in this course, because only practice makes perfect. Now, this course also comes with some course resources, namely the slides which you can download and various code snapshots which you can use to compare your code to mine in case you're getting stuck at some point. And attached to this lecture, you'll find a link to GitHub, which I'm using as a code repository for those code snapshots and materials. And you'll find instructions on how to use this repository and how to get to the code snapshots on that page. In the end, it comes down to selecting different branches for different course sections, and then in the different branches, once you selected them, you'll find the slides for that branch and also the code snapshots for that branch. That's how this works. In addition, as you complete this course, at the end of every course section, you'll find a module resources lecture, which will provide a direct link to the resources of the section you just completed. Now, last but not least, you're also not alone. This course comes with a Q&A section where you can ask questions, but where you should also try answering the questions of other students. Because by helping others with their problems, you will learn even more, because you're forced to think about a certain problem and come up with a solution. And even if your solution should turn out to be wrong, you'll learn even more from the feedback you'll get there. So asking and answering in the Q&A section is a great way of sharing knowledge and finding help. In addition, this course also comes with access to our Discord community, to which you find a link in the lecture after this lecture. And you can then also join this community totally for free to find fellow developers and learn and grow together. A couple of lectures ago, we saw a first React project in action, and we actually already worked on that first project. Now, as you might imagine, we're going to work on many React projects throughout this course, and of course, those projects, in order to work on them, first must be created. Now, I will say that whenever we're starting a new project in this course, I will provide a starting snapshot to you. You'll find it attached to the lecture where the project is created, and I will also let you know that attached you find such a starting snapshot. So you will be able to use these starting snapshots to get working React projects. Nonetheless, as a React developer, you should of course also know how you can create React projects on your own. And when it comes to that, you basically have two main options. You can either create projects locally on your system so that all the project files are created on your hard drive and any software needed to run that project is installed on your system. And therefore, of course, you also must install any tools or packages that are required to run a project, and you must have all these project files on your system. Or alternatively, you can go for a browser-based, a remote React project solution in the end, for example, with help of services like Code Sandbox, which is the service I also used earlier in this section for this first React project I showed you. When using such a remote solution, such a browser-based React project, you don't need to install anything on your local system, and you don't need to create any files on your local system. Instead, all the React project files, as well as any extra tools that might be required behind the scenes, will be provided and hosted by that remote project provider, so by Code Sandbox, for example. And when it comes to these project snapshots you find attached to the course, I will also always offer you both options. A zip file, which you can download as a local React project, or a Code Sandbox link that will take you directly to a React project running on Code Sandbox, so running in the browser, with which you can get started without installing anything on your system. Therefore, the great advantage of such a browser-based React project is of course that it's super fast to get started with it. The advantage of a local setup is that you have more configuration options. You can use exactly the code editor you want to use with exactly the settings and extensions you might want to use. And I, for example, prefer local React projects because I want that full control over them. In addition, when it comes to recording a course like this, recording those videos simply is easier with a local setup where I can arrange everything exactly as I want it to be arranged. But for following along, such a browser-based setup can definitely be a great alternative. There, though, you have to live with the general layout and configuration options that are given to you, and you have less control over the project setup and configuration. Now, in the next lecture, I will show you how you can create a brand new React project locally on your system, and therefore you can of course skip this lecture if you don't want to do that. In the lecture thereafter, I will do the same for the browser-based alternative, so for creating a project with Code Sandbox. Now, using a browser-based React project has certain advantages. For example, it's instantly available, but it also has disadvantages. For example, you only have limited control over the general layout of that browser editor, and you can also only configure the things this browser-based editor allows you to configure. If you want full control, you need a local React project. And as mentioned before already, whenever we start a new React project in this course, you'll find a starting snapshot attached to the lecture where we create that project. It'll typically be such a zip file which you can simply download onto your system and extract. And then in there you'll find a React project with which you can work. Now, in order to run this React project and, for example, start a development server, which allows you to preview the React app whilst you're working on it, you will need to install Node.js though. So you need to install this extra software onto your system, and you can simply visit nodejs.org to download Node.js from there. You can either use the latest or the LTS version, that shouldn't matter. You can download it from there. It is available for all operating systems, and it will automatically pick the right installer for your operating system. And once you did download and install Node.js, by simply walking through the installer this page gives you, you'll be able to start such an attached project snapshot. For that, you should open the downloaded project snapshot in your favorite code editor. For example, in Visual Studio Code, which is an amazing free-to-use code editor that is available for all operating systems. You can simply download and install it on your system to open React projects with it. And inside of Visual Studio Code, you can then browse these code files, and you can also tweak Visual Studio Code exactly to your liking by going to the settings there and, for example, choosing a color theme, by tweaking the keyboard shortcuts and the general settings. You can also change the appearance of Visual Studio Code under View and, for example, make sure that you have a status bar at the bottom or you maybe don't have it. So that's what I mean. You have full control over how it looks and behaves. And definitely take some time to play around with Visual Studio Code to configure it in exactly the way you want it to configure. Now, two things I would recommend that you tweak about Visual Studio Code locally on your system is, for one, that you go to the keyboard shortcuts, and then there you should search for the Format Document shortcut. And make sure you bind this command to a convenient shortcut, because whenever you press that shortcut, then it will automatically format your code, making it more readable, which is super convenient. In addition, and kind of related to that, you should also go to the extensions area of Visual Studio Code, because this code editor allows you to install third-party extensions. And there you can of course install any extensions you want, but I do recommend that you install the Prettier extension, which helps this code formatting command in the end. Because this extension and this command will make your life as a React developer a bit easier. Now, if you want to run such a downloaded project snapshot, you'll have to open a new terminal in Visual Studio Code, which simply opens your default system terminal or command prompt, just integrated into Visual Studio Code here and already navigated into this project folder. And then as a first step, you'll have to run npm install, a command which will only work if you did install Node.js, because this npm command is part of Node.js. Now, when you run npm install, it will go ahead and install any extra dependencies and packages that are required by this project in order to run correctly. For example, it will download and install the React library into this project. Those dependencies are not part of the attachment because they are pretty big and they would unnecessarily bloat the zip files. Now you only need to run npm install once after you downloaded such a project. Thereafter, you just need to run npm start to start this development server, which allows you to preview the React application. For that, you then just have to visit the address that is shown here, and there you should then see the sections starting project. Now, what's really nice about this development server is that as long as it's up and running, whenever you change anything in your code and you save that file, it will automatically update the website and reflect your changes there. So you should keep this process up and running as long as you're working on your code, and whenever you're done for the day, you can simply quit it by pressing Ctrl+C. You can then of course always restart it with npm start if you want to continue working. So that's how you can use those project snapshots, which you find attached to the course. But of course, sometimes you also want to create a brand new React project. And for that, you can, for example, use a tool called Create React App, which you should find if you search for Create React Project. On the official website of that tool, you get instructions on which command to run to create a new React project. And as you can see, it's just one simple command you have to run. This command must be executed in your system terminal or command prompt. And there you should first navigate into the folder where you want to create your React project with help of the cd command. And once you are in the place where your project should be created, you can paste in this command and then give this project any name of your choice, like for example React Complete Guide. And once you hit enter, it will go ahead and create a new folder with that name and create a React project inside of that folder. Now, important, for this command to succeed, you also must have Node.js installed on your system. Now, you can then also open such a project with Visual Studio Code, and you'll find basically the same folder structure as I have it in the code snapshots I'm providing to you. Now, in this project here, you don't need to run npm install because that was already done as part of this npx create react app process. Instead, you can right away run npm start to start the development server. And then once you visit this address, you should see a React project that looks something like this. Now, to conclude this lecture, I also want to note that you could alternatively also use a tool called Vite to create React projects. And if you search for Vite create React project, you'll find the official documentation, which then also lets you know which steps to follow to create a React project with Vite. In the end, it's up to you which tool you want to use. They all give you React projects, and the React code you'll write will be the same either way. But with that, you now also know how you can create a React project locally on your system, and you therefore can go with whichever approach you personally prefer. Now, as mentioned in the last lecture, throughout this course, I will typically provide starting snapshots to you. So if you want to follow along with Code Sandbox, you would simply use the Code Sandbox starting project link, and you get a pre-configured React project with which you can get started right away. But of course, you should also know how you can create a brand new project with Code Sandbox. And it is actually super simple. You just have to type react.new in your browser address bar and hit enter. And it will immediately take you to Code Sandbox and open up a new React project for you there. So with that, you then therefore also got an almost instantly available React project in which you can work. Now in this Code Sandbox editor, you'll find the files area here to the left with all your code files. And you can also create new files and folders with help of these buttons here, including nested files and folders if you use these buttons on existing folders. You can install dependencies down there, something you won't have to do initially in the first couple of course sections, but later in the course you will, for example, have to install the React Router DOM package, and when using Code Sandbox you would do this here in this dependencies area by entering the package name and picking it from the dropdown. But again, that's not something you'll need in the first course sections. Then, of course, you got your code editor for the selected file in the middle here, and a live preview of your React application on the right here. So this is your React website based on your React code here running in this right area of the Code Sandbox editor. You can, of course, resize those windows, and you can also dive into the Code Sandbox settings by clicking on this menu icon here and then going to File, Preferences, and then you have some general code editor settings and some Code Sandbox specific settings. Simply take a look through these settings and make sure you configure them in exactly the way you want to configure things. You will have less options available than in a local setup, but you can tweak quite a lot of things. Now, in addition, when you are on Code Sandbox here, you also might want to consider creating an account, because that will then allow you to run more Code Sandboxes. And that's how you can follow along in your browser without installing anything on your system. This course will teach you React from the ground up and in great detail. But this course section here will actually not be about React, but instead about just JavaScript. It will allow you to refresh your JavaScript knowledge. And therefore, this course section here is optional. You can therefore skip it, and you can of course also always come back to it if later in the course you see that you need some extra JavaScript help. Because this course section here is recommended if you haven't used JavaScript in a while, or if you don't have a lot of JavaScript experience. But I'll also say right away that this section does not replace a JavaScript course. This section is not for you if you have absolutely no JavaScript experience, because if that's the case, you should definitely at least explore some JavaScript basics before continuing with this course. But this section here will revisit crucial JavaScript concepts, and it will especially take a closer look at the core JavaScript concepts you need for building React apps, so for writing React code, you could say. Because in this section here, we will revisit the core JavaScript syntax and rules you should follow when writing JavaScript code. We'll explore the essential modern JavaScript features you should know in general, and we'll of course also especially focus on the features you need to write React code, so the features you will use throughout this course. That's what you'll get out of this section. So let's dive right in, and for that I prepared a Code Sandbox project, a Code Sandbox environment, to which you of course find a link attached to this lecture, which gives you a very basic web project with an HTML file and some assets, no JavaScript code yet though. And this is the project we'll use for playing around with JavaScript and for exploring some basic features. I will also say right away that we'll mostly write code that will output content in the console, which in Code Sandbox can be accessed by clicking on console here. Because this section is not about building some super fancy JavaScript-based project. Instead, as mentioned, it is about refreshing your JavaScript knowledge and making sure that you have all the essentials you need for building React apps. So let's start by revisiting certain crucial core concepts and things you should know about JavaScript. For example, that JavaScript can be executed in many different environments. For example, of course, the browser. That's where JavaScript originated. In the end, that's what it was built for back in the 90s. But nowadays, thanks to Node.js and Dino, for example, you can also execute JavaScript code outside of the browser. This will not be the focus of this course, because this is a React course, and React is a client-side, front-end, browser-based library in its core that allows you to build user interfaces with React and JavaScript. But it is of course worth knowing that JavaScript is not limited to the browser. You can even build mobile apps with JavaScript thanks to extra technologies like Capacitor or React Native, which, by the way, would be a great next step after finishing this course. You can also use React in conjunction with another tool or another library, you could say, called React Native to build native mobile apps for Android and iOS. And I do have a dedicated course on React Native if you want to learn more about that after finishing this course. So JavaScript is really versatile, really powerful, but in this refresher section, we're going to focus on JavaScript in the browser, though the general syntax and rules, of course, are always the same, no matter for which environment you are writing your JavaScript code. So since we focus on JavaScript in the browser, let's explore how JavaScript code can be added to a website. And here you have two main options, and they both include the special script tag, the special script element which you can add to your HTML code. You can either put your JavaScript code between such script tags, or you can use those script tags to import JavaScript files which then contain your JavaScript code. Now, typically we don't use that inline approach on the left here, where the code is between those script tags, because this approach can quickly lead to unmaintainable and complex HTML files, and is therefore typically only used for very short scripts. Instead, typically you have your JavaScript code in dedicated JavaScript files, because such projects that use this approach are way easier to maintain. Therefore, here in this demo project which I prepared, we could start in this assets folder by adding a new subfolder that could be called scripts, though the name of course doesn't matter. And in there we can create a JavaScript code file that could be named app.js, though this name also is totally up to you. It just should end with .js, since that of course tells the browser and also the code editor that this file will contain JavaScript code. And the code editor can therefore, for example, make sure that the code is properly highlighted and formatted. Well, and with such a file added here, you can then import it in the HTML file by going there and adding your script tags, opening and closing script tags. And you always need both. You can't use a self-closing script tag or anything like this. Instead, you need opening and closing script tags. That's a must-have. Now, you can add them anywhere you want in that file, in the head section, in the body section, really anywhere you want. And then you would add the source attribute, the src attribute, to point at the file, in my case in the assets folder, and there in the scripts folder, that should be imported. And now that file would be loaded as part of this web page when the web page is loaded. Now, it is worth noting that you can then add extra attributes to the script tag, for example, the defer attribute, to make sure that the script that will be imported will only be executed after the rest of the HTML document has been read and parsed. This ensures that if your script code, for example, needs to work with some HTML elements, those HTML elements are available when the JavaScript code starts executing. Without defer, it would start executing right away, and if you then would try to reach out to this unordered list, for example, this unordered list might not be available yet if the script is loaded before the list is output here. That's why you might want to add defer. Now, in modern JavaScript projects, it's also quite common that you have another attribute on your script tags instead of having defer. And that would be the type attribute, which then is set to module, like this. Now, this type module attribute here on the script tag makes sure that this JavaScript file is treated as a JavaScript module. And if you are treating your JavaScript files as modules, this unlocks one very important new syntax, the import syntax, where you can import code from script A into script B. For example, here we could have a second script file, util.js, which might contain some utility functionality, And in that script file, we could export something with the export keyword and then import it in the app.js file. Now we'll explore this import-export syntax and this general module feature in greater detail soon. But before we get there, there's one other super important thing you should know about the script tag here in the HTML file. Because before we get there, there is one other super important thing you should know about these script tags and about importing script files in the context of building React apps. Because when you're working on a React project, you will almost never add these script tags to your HTML file on your own. Because React projects almost always use a build process, which, as part of that build process, injects these script tags into the HTML code for you. And in the next lecture, we'll explore why we use such a build process in React projects. Now, if you take a look at a React project, like this React demo I showed you in the first course section, to which you again find a link attached to this lecture, if you take a look at such a project, you'll note that in the index.html file that you find there, you won't find any script tags. There in this index.html file in the head section, I have some meta tags and I have link tags, but I have no script tags there. And in the body, I just have the no script tag that shows a fallback message if the user has disabled JavaScript in their browser, but I got no script tags in there. Absolutely no script tags. And we also never add script tags to that file. Nonetheless, as you can of course tell, if I reload this here, this app works and JavaScript code clearly is executing because the React app is executing. And React, of course, in the end is JavaScript code. A special JavaScript code, but it is JavaScript code. So why is this working? Well, because as mentioned at the end of the last lecture, React projects use a build process, which simply means the code you write is not the code that gets executed, like this at least, in the browser. Instead, the code you write is transformed behind the scenes before it's handed off to the browser. In this demo project on Code Sandbox, but also in the local projects I'll use throughout this course, this is done with help of a tool that's running in the background. And you can actually see that tool in the package.json file. This file simply lists all the dependencies of this project, all the libraries used by that project. And therefore, of course, for example, in there we find the React libraries, the two packages that make up the React library, to be precise. But here in this example, we also find the React scripts library in addition. And this is actually a library that's not going to be executed in the browser or that's used by React once it's running in the browser, but instead this React scripts package here provides a bunch of tools that take your code and transform it behind the scenes before it's then injected into the browser, or to be precise, before it's then injected with help of a script tag into the HTML file here. If you take a look at this running website, for example by opening it in a new window, and you then there inspect this page so that the browser developer tools open up, you will see that now there are some script tags in there, actually multiple script tags. And these script elements were generated and injected into this HTML file automatically behind the scenes by this build process that's running in the background. This preview website, which we see here, is being served by a development server that's also running in the background on Code Sandbox. In a local project, on the other hand, you had to explicitly start that development server. And it's this development server which is watching your source code behind the scenes, and which is then also kind of transforming that source code behind the scenes, and which is then adjusting the HTML file to contain these script elements that do then load that transformed source code, so that the transformed source code is executed on the page. And why do we use such a build process? Why does the code need to be transformed? Well, for two main reasons. The first reason is that raw, unprocessed React code won't execute in the browser. Mostly because React code uses this special JSX feature. Now, you will learn more about writing React code and about JSX later once we start diving into React. JSX code simply is this HTML code written in JavaScript files. Out of the box, this would not work because this is not a standard JavaScript feature. If you would try to use this kind of code in our default JavaScript project here, for example, in the app.js file, if you would try to add like a div in there, and you would open this website preview and try to reload this page, you would see that you would get an error. An error that in the end points at this div here. Because this indeed is not a standard JavaScript feature. It does not work out of the box. So for that reason, to enable this syntax, which is crucial in React apps, as you will learn, because React will be all about including this HTML-like code in your JavaScript files. To enable this feature, the code must be transformed so that you can use it whilst writing the code, but it's transformed to something JavaScript knows before the code gets executed in the browser. That's one reason for using a build process. Another reason is that the code you write would not be optimized for production. It would not be minified, for example. Minification simply means that, for example, names of variables or functions are shortened to reduce the amount of JavaScript code that's served to the user. If you take a look at the code that is served to the user here by, for example, visiting one of these imported code files that is served here in Code Sandbox, you'll see that it looks something like this. Pretty unreadable, not the kind of code we would like to work on as a developer, but valid JavaScript code in the end. Though it is code that's highly optimized to be as short and small as possible to reduce the amount of code that has to be downloaded by the website visitor. So that's another reason why React projects typically require a build process. And the good news are that if you create a React project on Code Sandbox or with help of tools like Create React App or Vite, so if you're using projects as we're using them in this course, those projects all come with such a build process. So you don't have to go through any custom setup or tweak anything on your own. But that's also the reason why you also need to install Node.js on your system in order to work on React projects. Because Node.js is not just used to install packages with the npm command or to create projects with the npx command, as you already learned it, but instead it's also used behind the scenes by these tools that are used by that build process that's running behind the scenes. So Node.js is also needed and used behind the scenes to make sure that your React code gets transformed. So that, of course, was a lot of talking about the build process, but it is important to understand that such a build process is used behind the scenes and why it's being used. Back in our vanilla JavaScript project here, which we'll use for this refresher, we should therefore get rid of this invalid JavaScript code, because this project here indeed does not come with a build process that would convert this JSX code to valid JavaScript code, and therefore here we can't use JSX code, but we also don't need it for this refresher. Now I want to start refreshing your JavaScript knowledge by first exploring this import-export syntax I mentioned before. Because in this course, we're going to import and export a lot of things. Because in React apps, like in most more advanced JavaScript projects, it is considered a best practice to split your code across multiple files to keep it maintainable and manageable. And that's exactly what you do with help of the import and export keywords. Now for that, let's say that in the util.js file, we have a certain value that should be usable in other files as well. For example, in the app.js file. Here we could have an API key variable And variables in JavaScript are created with the special let keyword, but I'll get back to variables and constants and some key things you should know about them a little bit later in this section. And in there we could store a string created with single or double quotes, doesn't matter. And that string could then contain some cryptic API key that maybe is required in order to send HTTP requests to a backend. This is just a dummy example here, but this overall section will just show you some dummy examples, because in the end it is just about refreshing your JavaScript knowledge. So if that API key, that value here, this string here, should also be available in other files, we need to export it by adding the export keyword in front of it. This makes this thing, this variable here in this case, available outside of this file as well. We can then import it in the file where it should be used, so in this app.js file, for example, by using the import keyword. And then here we need opening and closing curly braces. And between those braces, we then refer to the name of the thing that's exported. So in this case, the name of the variable. If we would be exporting a function, it would be the name of the function instead. But here it's the name of the variable. So API key written like this. And of course, the casing matters because JavaScript is a case-sensitive language. And then thereafter, we need the from keyword to let JavaScript know from which file we're importing this thing named API key. This path to the file then goes between quotes, single or double quotes, again doesn't matter. And here we then typically have a relative path starting with // if it's in the same folder, starting with // if we want to go up one folder. But here it is in the same folder, so I will use // and then the name of the file with the extension added, at least if you're using just JavaScript. Now, when working in React projects, you will actually see that the extension, the .js, typically is omitted there. That's the case, again, because of that build process that's running behind the scenes, which will add the extension behind the scenes. If you're writing just JavaScript code without such a build process, you do need to add it on your own. But throughout this course, where we do use React projects that come with such a build process that adds the extension for us, we will actually not add it on our own. But here we need to do it. And with that, this API key variable and the value it contains will be available in this app.js file, even though it's defined in another file. And here we could then, for example, console log API key to output it in the console. Now, very important, for these import and export keywords to work, you must be using this type module import here. That's really crucial. Though you will see that for the React projects, if you explore the automatically injected script tags there, you don't find this type module attribute on them. The reason for that simply is that this build process will actually take all your imports and exports and basically merge all these separate files that you have during development into one big file or a bunch of big files, which are then imported with the old school syntax in the right order. This is done to also make this code execute in browsers that don't natively support this import-export syntax, and also so that the browser doesn't have to download dozens of small JavaScript files, but instead just a couple of bigger files, which typically is more efficient. And I'm just letting you know about this here so that you don't wonder why this type module is missing on your React project's script tags. But if you have a vanilla JavaScript app without such a build process, you do need to add this type module attribute here. And with that here in this project, if you save that and reload the app, and you then open this console, you should see your API key being output there. And that's of course coming from the app.js file where we are importing it from the util.js file. Now that's not the only variation of this export-import syntax though. This is one way of exporting and importing things, but in this course you'll also see another way. Besides exporting with help of the export keyword in front of a variable or function, you can also create a so-called default export by adding the default keyword. Now in that case, you must not create a variable thereafter like this, and you also don't assign a name. Instead, you just export the value like this. So now I'm just exporting a value without a name. And when adding the default keyword here, I'm saying that this value here, should be the default thing that's exported by this file. And what's very important is that you must only have one default export per file. If I try to add a second one, I'm getting an error. On the other hand, with the syntax we had before, without default, you can export as many things as you want. Exporting another variable like this wouldn't have been any problem. With the default keyword, you directly export a value and you must only have one default export per file. So I'll also add the old code here, simply so that you see the difference. Like this. And in app.js, the import syntax now also changes if you have a default export. Instead of importing like this, you now import without curly braces. Instead, you just assign any name of your choice. Since the thing that's exported as a default doesn't have a name here, you can use any name you want in the file where you want to import it, but you do need to assign a name. And then you still define the path to the file from which you want to import, like this. With that, if you save this, and again you reload this file, you will see that this again gets logged to the console. Now with help of such a default export and the respective import syntax. And this is also a common way of exporting something and importing something, which is especially useful if you only have one thing, one function, or one value in the file where you want to export it. This is something you will see later in the course once we explore the concept of React components, because there it's quite common that we only have one component, one JavaScript function, as you will learn, per file, and therefore it's quite common to export this one component function as a default, since there are no other things that would be exported in that file. But it is totally up to you which approach you prefer. It's just important to keep in mind that the import syntax also changes if you use the default export syntax here. Now, one last thing you should know about the export and import syntax is that if you have named exports, as this syntax here is called, like this, and let's say you have multiple named exports, for example, you also have another special import syntax you can use. Of course, you can import those named things like this, import API key, for example. I'm just going to comment out this import so that we don't have a name clash. And you could then import all the named things by separating them with a comma here. That's how you would import multiple things from the same file if those things are exported as named exports, so without the default keyword. And as you see here, you can also mix the default keyword with named exports. You just must not have more than one default export. But having a default export in addition to some named exports is absolutely fine. But what you could now do here is that instead of listing all the things you want to import like this as a comma-separated list between the curly braces, you can also import them by grouping them together into a JavaScript object. And that would be done by then using a star, then the as keyword, and then any name of your choice. For example, utils or util, whatever you want. And then again, the path to the file from which you want to import, like this. With that, all the things provided by util.js would be grouped into this object, and therefore you could use it with the default JavaScript object notation, using its name and then the dot notation to access the thing that was named ABC, or the thing that was named API key, or the default export, which is available under a key named default. So that's how you could then output the API key, And therefore here, if I reload, I again see that API key here in the console. Now, by grouping multiple exported things together into one object. As a last side note, this as keyword can also be used to assign aliases. So for example here, if I go back to this named export import thing and I'm not happy with the name ABC here, I could assign an alias by using the as keyword after the thing that I want to rename in this file here. And I could rename it to content or whatever I want. And now if I would console log content here, I would be logging the value that is stored in that ABC variable in the util.js file. But I'm renaming it here in the file where I'm importing it with help of that special as keyword, which allows us to assign an alias to the thing that's being imported. So as you can see, there are a couple of things you can do with this import-export concept. In the end, it is pretty straightforward, but you should know about these keywords and how to use them, because we are going to use them a lot throughout this course. So with the import and export keywords and the related concepts, we already explored a bunch of crucial JavaScript concepts and features which we'll use heavily throughout this course. But of course, for this refresher, I now also want to take a step back and also explore some other foundational JavaScript features and concepts, like working with variables, values, functions, objects, and much more. And it definitely makes sense to start with variables, values, and operators. For that, in this app.js file, I'll comment out all this code we wrote before, because we don't need it here. And instead, I now do want to revisit some foundational concepts related to variables, values, and operators. Because in the end, when you're building an app with JavaScript, or with React, which uses JavaScript, of course, it's in the end all about data and therefore in the end values you're working with in your code. If you take a look at applications like Twitter or Google Maps, those apps, like all apps, of course, in the end are about data. The tweets you write and read are data. Your location is data. The location you want to go to is data. All these things are data that must be handled in your code. And in your JavaScript code, you can therefore handle a broad variety of values. Most importantly, strings, numbers, booleans, the special null and undefined values, which simply mean that a certain data container, a certain variable, doesn't contain any values yet, and also the special object value, to which I'll get back later. Now, a value in JavaScript can be created in the place where you need it. For example, if I want to output hello world here, I can simply create the string hello world with double or single quotes, doesn't matter, but quotes are of course needed. And if I then save this and reload my app, I would see hello world in the console. So I can create values when I need them. For example, here, when I need a value as an input for this console log command that's built into the browser in the end. But it's also quite common that values should be stored, and for that you're using variables. Variables are simply data containers where you store a value in a variable, which carries any name of your choice, so you assign a name to a variable, and you can then use this variable name as an identifier in your code to refer to that value that's stored in this variable whenever you need to use that value. And you typically use variables because they allow you to reuse a value and because they can help with code readability. Because often it makes sense to not define the value in the place where it's needed, but maybe instead ahead of time so that your overall code stays a bit cleaner and more readable. Now in JavaScript, variables can be created with the let keyword. Here I could create a variable named user message, though the name is up to you. It just should follow certain rules. For example, it should be written using this camel case notation, where you start with a lowercase character, and if your variable name then consists of multiple words, every word inside of the word, like message here, starts with a capital case character. And it must not contain any dashes or white space. So this variable name would be invalid, just as this name would be. Underscores would be allowed, but are not common in JavaScript. Instead, as mentioned, the convention is to use this notation. Variable names also may contain numbers, but not at the beginning. In addition, they also may not contain any special characters like an exclamation mark or a question mark. The only exception is the $sign and the underscore, which I already mentioned. But other than that, the name is up to you. And then I could store this hello world text in user message. If I then want to use this value, for example here for logging it to the console, I would simply use the name of the variable and thereby refer to this value. And that's how I use a variable. And if I now want to log this multiple times, for example, I gain this reusability advantage by using a variable, because instead of having to copy and paste that value, I just define it once and then use that variable as often as I want to use that value. That has the advantage that if that value ever needs to change, I only need to change it in one place instead of multiple places, and all the places in my code where I use that variable will automatically use that changed value. With that, if I reload this, I of course see hello world being output in the console twice. So that's how we create variables. Now, related to variables, we also have constants, which are created with the const keyword. If I save this and reload, I again see hello world being output twice here. So constants work like variables. They are data containers, but the key difference is that constants must not be reassigned. If I try to assign a new value, a new string, for example, like this, I'm getting an error that it's read only because it's a constant. If I were using let here instead of const, everything would work instead. Now I would again see my log here in the console. So that's the key difference. With let, I can use this single equal sign operator to assign a new value. With const, I can't. Now, there are different philosophies out there in the JavaScript world. Certain developers like to use const as often as possible, and I'm one of those developers. Other developers want to use let all the time because it has less characters and therefore requires less code to type. But I prefer to be clear about my intentions, and if I have a value that never should be reassigned, I personally prefer to use const. You can use whatever you want, but you should know about the difference. So let and const are super important. Another very important concept related to values are operators. For example, in JavaScript, we can perform math. We can use the plus, minus, times, and division operator to perform math, and to, for example, divide 10 by 5. And what's important to know about JavaScript is that the plus operator for adding things cannot just be used for numbers, as I'm doing it here, and the difference between numbers and strings is that they don't have quotes around them, but instead it can also be used with text. For example, hello plus world for concatenating two strings into one longer string. With that code, we would get hello world like this, as one word, because I have no blank anywhere in these strings. But as you can see, the plus operator works absolutely fine here, so you can also use it for concatenating strings. Now, besides plus, minus, times, and division, you also have some other crucial operators. For example, the triple equal sign operator, which is used for checking for equality. And this operator therefore yields a Boolean value. In this case here, false, because 10 isn't equal to 5. If I would be checking 10 equals 10, I instead would be getting true. Now, besides checking for equality, you can also check for things being greater or smaller than other things, or greater or equal, or smaller or equal. And these comparison operators are also very commonly used in JavaScript and will be used a lot in this course, typically in conjunction with the if keyword and if statements, which allows you to execute some code conditionally. For example, here I'm comparing 10 to 10, which is kind of redundant, of course. Typically, you would instead compare some dynamic user input, but for this demo here, I'm using two hard-coded values. And if this condition is met, which in this case here will of course always be the case, the code in the if statement will execute. But I'll get back to if statements a little bit later again. Here, if I reload this, I therefore get works, because of course this condition here is always met. Again, this is a redundant condition. In this course, in the apps we're going to build with React, you will see conditions that make more sense. Now, besides variables and constants, another crucial JavaScript concept are functions, which can either be created with help of the function keyword or with help of this arrow function syntax, to which I'll get back in a couple of seconds. Let's start with the function keyword. The idea behind functions, no matter how you're creating them, simply is that you're defining some code that's not executed immediately, but instead at some point in the future when you call the function, and that can be executed as often as you want because a function can be called multiple times. Now, to show you what I mean, let me finish this function. And this is how you write a basic function. You give it a name, which comes after the function keyword. Then you have a so-called parameter list, to which I'll get back in a second. You do create it with the opening and closing parentheses, and you need these parentheses here. And then you have opening and closing curly braces, and between those curly braces, you put your function code. So the code that's not executed right now, but at some point in the future. So for example here, I could put a console log statement into this greet function, and if I would save this and reload this page, you would see nothing in the console. The reason for that is that this function is defined but never executed. Because as mentioned, with a function you're defining code that's not executed immediately, but at some point in the future when you call the function, when you invoke the function. And you do that by using the name of the function like this, and then adding another pair of parentheses after that name, but without the function keyword in front of it. With the function keyword in front of it, you're defining it. Like this, you're calling it. And now when this code is encountered in your code file, the code in the function will be executed. So now with this added, if I save this and if I reload this page, now I do see hello here, because now we're calling the function. And as mentioned, I can call the function as often as I want. You can literally add as many function invocations here as needed. And if you save that, you'll therefore see hello being output 5 times. Because I have 5 function invocations here. That's how you define and call a function. And this is a super important concept which we'll use all the time throughout this course. Also, especially in React, it turns out that we'll define a crucial React building block as a function. But you'll learn more about this later once we dive into React. Now, functions cannot just be defined and executed like this. Instead, they also take so-called parameters, input values. For example, username and message. You can add as many parameters as you want, you simply separate them with a comma. These parameters are then available inside of the function, and only there. So here I could then output username, with a capital N, and then thereafter also message. I can do this because I'm accepting these two parameters. And since it's your function, these parameter names are up to you, but they have to follow the same rules as these variable names did. The same, by the way, is also true for the function name. This should also be defined just as you learned it for the variable names. For example, if it's a word that consists of multiple words, you would also use this camel case notation here. So now this function takes two input parameters. Therefore, when you're calling this function, you also should provide values for these input parameters. Because in the end, the idea behind using parameters simply is that you can have one reusable function that can be reused with different input values. For example, here I could call it with max and hello the first time, and then call it again where I greet manual and say hello, what's up? Like this. Now I'm using the same function with different input values. That's possible thanks to parameters. And therefore, if I reload this, I see max and hello. And then I see manual and hello, what's up? Now, what's also worth noting here is that you can also assign default values to parameters by adding an equal sign here. For example, hello. This would allow me to call this function without providing a value for the second parameter, and if I don't provide one, the default value will be used. But I can of course also overwrite that default value by simply providing a value for that parameter here. With that, if we reload this, I get max and hello, thanks to this default here. And then I get manual and hello, what's up, where I do use this value for overriding the default. Now, functions cannot just take input values, but they can also return values by using the return keyword. So for example, in this function, instead of console logging username and message, I could return a string that combines both. I could return a string here where I say, hi, I am, a white space here, and then I add the username, and then another white space or dot maybe, and then the message. So now with that, I'm using this function here to in the end construct a string based on these input values. And we could also use return if we would not accept any parameters. In this case, I'm using the parameters for deriving the returned value, but if you have a function that doesn't need any input in order to work correctly, you of course also don't have to accept one. Parameters and the return keyword work totally independent from each other, but as in this example, they can also work together. So with that, this function here no longer greets a user, but instead creates a greeting. And therefore, we also might want to rename it. Because whenever you name things, functions, variables, whatever, you should describe what's stored inside of it in case of a variable or constant, or what it does in case of a function. So here, since it no longer greets a user, but instead creates a greeting string, we might want to rename it to create greeting. And then when we call it down there, we of course also no longer get any output in the console. Instead, now we should store the result in a constant or variable, because this function now returns a value which we can use. We could use it as an input for console log, for example. And therefore, in that case, we would see, hi, I'm Max, hello. Maybe we should add a white space after the dot here to improve the formatting. But since this here is not great from a readability perspective, we instead might want to store it in a constant or variable like this, and then use that constant or variable so that the overall code is more structured. So with that here, we could get our two greetings, and then of course also console log these two greetings. And therefore we would see those greetings again. So functions can also be used for producing and returning values. And they should be named such that it's very clear what a function does. Though in the end, of course, just as with the variable names, the function names are up to you. Now what you see here is one way of defining a function. But I'm going to comment out this approach here for the moment, because there also is an alternative. In JavaScript, you can also create so-called arrow functions, a syntax that's especially popular if you're dealing with anonymous functions, functions that don't need a name. For example, here in this React app I showed you in the first course section, you might remember that on the buttons we had this onClick attribute, and we used some React syntax to point at a function that should be executed when the button is clicked. And for that here, I used this arrow function syntax to define a function in the place where it's needed as a value for this click listener. And this is a so-called anonymous function because it doesn't carry any name. It's just the function code. Now, anonymous functions can also be defined with the function keyword. You can define functions like this, and for example, console log hello. And we could then, for example, export this as a default if we wanted to, and we would now be exporting a so-called anonymous function which doesn't carry any name. But if you are dealing with such anonymous functions, you can use the arrow function syntax as well, since this is a bit shorter. When using arrow functions, you omit the function keyword, you must not use it, and you instead just have your parameter list here, like for example username and message. This doesn't change. Then you have this arrow, and then you have the curly braces which contain the function body. You can also still use the return keyword here if you want to. And that's how you would define a function using this arrow function syntax. In this course, you'll see both kinds of functions, using the function keyword and using this arrow function notation. Ultimately, it is up to you which approach you prefer, but you should know about both. So now that we learned about functions, I want to come back to values. And specifically, I want to come back to objects. As you should already know, objects in JavaScript can be used to group multiple values together. So for example, if I have a user name, which could be Max, which typically of course would not be hard-coded, but might be fetched from a server or from some HTML input on the page. And I have a user age, let's say, of 34. I could group these values together in an object. So that instead of defining them like this, I could have a user object, which is created like this, by using opening and closing curly braces on the right side of this equal sign here, like this. And then there I could have a name property, as it's called, and an age property. So I have key value pairs where the keys are up to you, but should follow the naming rules you already learned about. They also should of course be descriptive. And then separated by a colon, I have the value that should be stored under that key. Now this object could be used to output it in the console, for example. If I refresh this page here, I would see my user. And in this JavaScript console, I can actually also explore it. But I can also access individual fields of that user object here, or of any object, by using the dot notation. And then, for example, I can just access and output, in this case, the name field. So therefore now, if I reload this to get rid of the error, I would see Max. And this dot here is the key to accessing values in an object. You use this dot notation to get access to a value in an object. Now, besides key value pairs like this, objects can also store functions, which we then typically call methods. For example, here I could create a greet function like this without the function keyword, just the name of the function you want to have, followed by the parentheses, which could accept parameters if you wanted to, and then your curly braces, and here you can return something, or for example, simply console log something. And then you could access this again with the dot notation and execute it like any other function by adding these parentheses here. With that, if I reload this, I would see hello here. Now, if you are in such a method, so in a function that belongs to an object, you can also access the properties of this object, so the other methods and fields that belong to this object, with help of the special this keyword. This would, for example, allow me to output the age here by using this, which refers to this object, dot age. And with that, if I reload this, I would output the age here. This keyword won't be too important for this course because we won't create too many methods here, but nonetheless, it is a JavaScript concept you should know. Now, when it comes to creating objects, you can either create them like this to group values together, or you can create blueprints by using the special class keyword. This is also an approach we won't use too much in this course, but I briefly want to mention it here. With the class keyword, you can create a blueprint that can then later be used to create the actual objects. Here we could create a blueprint called user, like this. And what's important here is that for class names, you should start with a capital case character. And then here you could, for example, add your methods that should be part of that blueprint, like this. In addition, you can add a so-called constructor function by using the special constructor keyword, which other than that is written like a normal function though. And you can use this constructor for accepting parameters, input values like name and age, for example, and then store them in properties of the object that will be created based on the class with help of the this keyword again. So that's how I would create properties named name and age, and store the parameter values name and age in these properties. Now, by doing that alone, we won't achieve anything yet. Instead, we can now use such a class blueprint by instantiating it with help of the special new keyword, which creates a new object based on that blueprint. And then here I could pass manual and 35 as values. And if I now console log user1 here, I would be getting an object, this object here, that is based on this blueprint. So this object here is based on this blueprint. And therefore it contains the values I passed as input parameters to this constructor here. That's how these things work together. In addition, this user1 object would now also have a greet method because I defined the greet method here. So that's where this hi is coming from. Again, we won't use this class keyword a lot in this course, but you should know about it. But with that, that's it for objects. I'm going to comment out this code here. And we can continue with the refresher for the next concept. Now, besides objects, another crucial JavaScript value type are arrays. Though technically arrays are objects, but they are special kinds of objects. Now, an array is created by using square brackets, opening and closing square brackets. And the idea behind an array simply is that you can create a list of values. So where objects allow you to group values together with key value pairs, the idea behind arrays is to have just values which are stored in a certain order and which can be accessed by their position in that list. So for example here, if I have an array of hobbies, let's say sports, cooking, and reading, if I have such an array, I can access the array values by using square brackets after the name of the variable or constant that stores my array. So by using these square brackets here. And then there I use the index, as it's called, of the element I want to output in this case. Now the index starts at 0. So sports here has an index of 0, cooking has an index of 1, reading has an index of 2. If I want to output sports here, I would therefore access hobbies, square brackets, 0. With that, if we reload this and take a look at the console, I would see sports. Now arrays are a super common value type in JavaScript because it turns out that you quite often need to store a list of values. For example, in this demo React application I showed you earlier in the course, there also was a content array which actually contained more arrays as values, because that's also important to know. Arrays can contain any kinds of values. They can contain other arrays, objects, numbers, strings, whatever you want. Here I have an array of more arrays, and those inner nested arrays then actually contain strings. Now, when defining an array, the individual values that make up the array are separated by commas, and then, as mentioned, you access values by their index. Now, since arrays are such a super important, very common value type in JavaScript, there actually also are a couple of built-in utility methods you can use on arrays to transform or read the values stored in the arrays. You can access these utility array methods by using the array name and then the dot notation, and then you should automatically get a suggestion of the methods that are available here. For example, there is the push method, which allows you to add a new item to an array, for example, working. If I add this here and I then console log hobbies, you will see that now hobbies here actually contains 4 elements, therefore ending with the index 3, since we start at the index 0. And the last element is this working string I just pushed onto the array. Now, there of course are way more methods, and I'm not going to explain them all here, but for example, another method which you should know, which can be quite useful sometimes, is the findIndex method. This is a method that allows you to find the index of a certain value. For this, findIndex actually takes a function as an input, and that's a great use case for using such an arrow function, since it's super short to write and not a lot of characters to type. This arrow function, which you pass to findIndex, should accept at least one input parameter, which could be called item, because findIndex behind the scenes will execute this function, which you're passing to findIndex, and will automatically provide a value for this input parameter. Therefore, of course, your function also must accept it in order to then use it in this function body. Now, in this function body, in case of findIndex, you then should return true if you have the item that you were looking for, and false otherwise. For that, we can return item equals sports, for example, if we were looking for the index of the item sports. So if we were looking for the index of this item. What this code here does is it executes this function automatically behind the scenes for every item in this array, including this working item, which was pushed onto the array. And then for every item, it compares that item, so that text here, to this text with help of this comparison operator, which I mentioned before. If the two are equal, this function here returns true, and therefore findIndex knows that I found the item I was looking for, and it will then give me the index of that item. Otherwise, this will return false, and findIndex will do nothing. So therefore here, I could store that index in a constant, and then console log it. If I save that here, I get 0, because indeed sports, which is the item I'm looking for here, has the index 0, since it's the first item in that array. Now, this code can definitely be a bit more challenging to understand, since we're passing a function to another function, and that's also something I'll get back to a little bit later in this section again. But in the end, all that's happening here is that findIndex needs a function which it can execute on our behalf, and it will execute this function for every item in this array. It will pass that item for every execution into that function, and therefore, of course, item will be different for every execution. It will be those items here. And then we compare the item we're getting to some value we're looking for. So this value we're looking for, of course, is defined by us, the developer. That's how this function here works. Now, as a side note, if you have code like this, an arrow function where all you do in the function body, so between these curly braces, is return something, you can even shorten this code and get rid of the return statement and get rid of these curly braces and write this code like this. Also get rid of this semicolon here. This is then the shortest possible way of writing this, and another advantage of using such an arrow function. because this is now a very short, concise piece of code for defining a function that takes an input called item and then compares that input to some other value to yield true if these are equal or false otherwise. Now, another very useful utility method you'll see a lot throughout this course is the map method. Map allows you to transform every item in an array to another item. For that, map, just like find index, takes a function as an input, typically such an arrow function, since this is such a short and concise way of writing this. And like this arrow function for find index, this arrow function here also will receive every item in the array as an input, because this function also will be executed automatically by map for every item in the array, and every item of the array will then be provided as an input value to this function when it's being executed. And then here you return the value this item should be transformed to. For example, item plus exclamation mark. So that I add an exclamation mark to every string here. This, of course, is just a dummy example, but when working with React, you'll use this map method a lot for outputting list content, for mapping data into such JSX elements. But that is something I'll get back to later again. Here I'm just mapping my items to strings with an exclamation mark at the end. And what map will do is it will not edit the original array. Instead, that array will stay unchanged. And instead, map will return a new array, which I'll name edited hobbies. If I then console log edited hobbies here, and I reload this page, I therefore get my edited hobbies here, with all these exclamation marks at the end. So that's what map does, and since we'll see map quite a bit throughout this course, I definitely wanted to mention it here. Now, what's important to note about map is that you can really use it to transform any item to any other kind of item. For example, here we don't have to convert our strings to new strings. Instead, I could also convert them to JavaScript objects. For that, I would create an object with opening and closing curly braces, which here, however, would have to be wrapped with parentheses, since otherwise they would be treated as the parentheses that wrap the function body. If I instead want to return a JavaScript object, I have to wrap the curly braces with parentheses, and this will tell JavaScript that these curly braces will not define the function body of this arrow function, but instead will define a new object returned by that arrow function. And then here, I could define any key of my choice and, for example, store the item, which in this case will be such a string, as a value for that key. Really, you can create any kinds of values here. Any objects of any shape, numbers, strings, booleans, whatever you want. Here, in this example, I'll in the end create a new array that's full of JavaScript objects, where every object has a text key, which value is the value from the old array. So if we save this code and reload this, I now have a bunch of objects in my array. And if I expand those, you see that I have this text key here. And the value then is the value I had before in my array. And that's of course the case for all these objects. Now, related to arrays and objects, there are two crucial, relatively new and modern JavaScript features you should know, because you will also see them quite a bit throughout the course. And the first feature is about destructuring arrays and objects. For that, let's take a look at this array. An array that contains some username data, the first name and the last name. Of course, it could be stored in an object, but here it's an array. Now let's say in our code we want to work with both the first and the last name. Now what we could do to make that a bit easier is we could create a new constant or variable called first name, where we extract the first element of this array, which is the first name, by using index 0. And then we could add a last name where we also use username data, and we use index1 to extract the last name. This could be done, and from now on we could use first name and last name, which is a bit more meaningful than always working with username data 0 and username data 1. But this code can be shortened. Instead of using this code here, we could create these two constants or variables in one single step by adding square brackets here on the left side of this equal sign. On the right side, they will create a new array. On the left side, they will destructure that array, which simply means that this syntax can be used to pull values out of this array. And now you can define new constants or variables with any name of your choice here, and the first constant or variable here will be mapped to the first array element, the second one to the second element, and so on. And this is a super useful syntax, since this of course is way shorter to write than what we had before. And from now on, I can also console log first name and console log last name and use these constants like this, even though the original data is in an array. But due to restructuring, we can pull out these values and store them in separate constants or variables. So if I reload this page here, I see Max and Schwarzmuller here in the console, because of these two constants that are created with help of this destructuring syntax. Now this destructuring syntax also exists for objects. We cannot just use it for arrays. For that, let's say we had a user object that looks like this. Now again, we might want to store these values in separate constants or variables. For that, of course, we could create a name constant and store user.name inside of it, and a age constant and store user.age inside of it. That would work. But again, this can be shortened here. Instead of writing this code, we can again use destructuring, in this case, since we're dealing with an object, by writing curly braces on the left side of the equal sign. On the right side, they will be used to create an object. On the left side, they are used for destructuring, just as we used square brackets on the left side for destructuring an array before. Now we're using curly braces to destructure an object. And then here we can pull out name and age, though these names here are now not up to us. Instead, we have to use the field names that are defined in the object. For array destructuring, these names were up to you because the elements were pulled out by position. For the object, they are pulled out by name, so by property name, and therefore you have to use the same property names here. Though you could assign an alias by using a colon here and then defining your alias name on the right side of that colon. When creating an object, so when using the curly braces on the right side of the equal sign, the colon is used to separate the key of a value, the property name you could say, from the value that's stored under that property. When using curly braces on the left side of this equal sign, so when using them for destructuring, the colon is instead used for separating the property that's pulled out of this object from the alias name that should be assigned to it. And with that here, we could output username and age. And we would be using these destructured values for that. So therefore, again, if we reload this, we would see these values here. And this destructuring syntax really is a crucial JavaScript feature, which we'll use a lot throughout this course, and therefore now you know about it. Now, the other crucial concept that's related to arrays and objects about which you should know is the special spread operator that exists in JavaScript. For that, let's for example say that we want to merge this hobbies list with another hobbies list. In this case, for example, another list that only contains one item. If I would want to create a merged list, I could do that by creating a new list with the square brackets, and then I could use the special spread operator, which looks like this. 3 dots. Yes, it looks weird, but this is JavaScript syntax using 3 dots. And then the name of the first array you want to merge into this new array. For example, hobbies. These 3 dots will pull out all the elements of this array, so sports and cooking in this case, and add them as separate, comma-separated values to this new list. If I would just add hobbies like this and new hobbies like this, I would get a new array which, when output to the console, will actually look like this. Now it's an array with 2 nested arrays inside. This might sometimes be what you want, but often it's not. If I instead use the 3 dots in front of the arrays to use this spread operator, I will pull out the values from these arrays and add them as standalone values to this array. And with that, if I reload, this new array I get now does not contain nested arrays, but instead the values from the merged arrays. And that's what the spread operator does. It pulls out values from an array and adds them as separate, comma-separated values to a new array here. And we will indeed use this spread operator from time to time in this course, and therefore you should also know about this. You can also not just use this spread operator on arrays, but also on objects. For example, if I have my extended user object here, where I also have the isAdmin flag, let's say, a property named isAdmin, which stores a Boolean value, and I now want to merge in the properties from the other user. Now for that, I can again use the spread operator, because it's also available in objects, and spread my user with help of these 3 dots into this extended user. Here, the spread operator will pull out all the key value pairs from this object and add them as key value pairs to that object here. Therefore, if I console log this extended user now, I'll get a new user which has this isAdmin key, but which also has these key value pairs from this user here. All thanks to this spread operator, to the 3 dots. So enough for hobbies and objects for now. Let's explore control structures. I already mentioned the if keyword, which is used to create so-called if statements before. The idea here is that you compare values, for example, and you then execute the code inside of the if statement only if this condition here is met. Now, the if statement also allows you to add an else statement to define the code that should be executed if this condition is not met, and also else if statements if you want to check for more conditions if the first condition wasn't met. And you can add as many else if statements here as you want, but only one else branch. Now, of course, checking for hard-coded values like this makes absolutely no sense. This will always be true, for example. Instead, typically, of course, you'll use if statements to check content you don't know in advance. For example, here, I could get some dummy password by using the built-in prompt function. This is a function provided by the browser which will prompt the user for input. You see here, I get this overlay that opens up. Here I could type your password, and now I would get this overlay which asks me for a password. Now here I'm getting this overlay whenever I type a couple of characters in my code here, and since this is a bit annoying, I'll indeed go to the preferences here, and then the Code Sandbox settings, and set the preview settings to disable preview on edit, so that it will not automatically re-execute the code after I typed a couple of characters. So with that, I'm now fetching this password, and I could now check if the password is equal, using the triple equal sign operator, to hello, let's say, written like this. And if that's the case, I'll console log hello works. Else, if this condition here should not be met, if the password entered by the user is not hello written like this, I could check if the password is maybe equal to hello starting with a lowercase l, in which case here I could console log hello works. But else, if that's also not the case, I might want to execute this fallback code here where I say access not granted. With this now, if I save this, the code does get executed again, but I'll still cancel this and manually refresh to clear the console. And now if I enter hello with a capital L and press OK, in my console I'll see hello works, because since I entered hello written like this condition here was met and this code here was executed. On the other hand, this code and this code was not executed. That's why the if statement is called a control structure, because it controls which code gets executed. If I reload this and I enter anything else, like this here, and I press OK, I get access not granted, because of course I did neither enter hello written like this, nor written like this. Therefore, this code got executed. So that's the if statement. Another crucial control structure you should know about is the for loop. Now, JavaScript knows different types of for loops. One very important kind of for loop we'll also see in this course is the for loop where we loop through an array. For that, I'll again create my hobbies dummy array here with sports and cooking, let's say. And now if I want to execute some code for every entry in this array, I could create a for loop where I create a constant that will be recreated for every iteration of that for loop, because for loops are about executing the same piece of code multiple times, as you will see. And I could name this constant hobby, because now with the special auth keyword, I tell JavaScript that it should create a new constant for every item in this array, and it should execute the code between these curly braces as often as needed to go through all these elements in this array. So for this array, 2 times. So if I then console log hobby here, for example, this code, this console log code, will get executed twice because I have 2 elements in this array. The first time for hobby being equal to sports, the second time for hobby being equal to cooking. If I save this and I reload here, enter anything here and open the console, I see sports and cooking being output here because of this line of code being executed multiple times. So this for off loop is also a kind of loop you should be aware of, because we'll also see this in this course. Now, something we'll not see a lot in this course is that we'll reach out to the DOM and select elements in the DOM manually in JavaScript code to then read or change them. Now, being able to reach out to the loaded website and read and manipulate it at runtime is of course a strength of JavaScript, but it is also something we won't do when using React, because React will do it for us, because we write React code in that declarative way, as you learned in the first course section. So selecting elements, for example, with query selector, to then remove them from the screen, for example, like this, is not something we'll do a lot or at all in this course. Instead, we'll use React for that. And with that, we're almost done for this section, but there are a couple of essential features that we'll use in this course and a couple of tricky features, which I also want to refresh here so that you know about these JavaScript concepts and features and you don't wonder about them when you encounter them later in the course. The first JavaScript feature you should be aware of is that you can pass functions as values to other functions. For example, we could set a timer with help of the built-in setTimeout function, a function that is provided by the browser. Now, setTimeout wants 2 input values. It accepts 2 parameters. The first input value it wants is a function itself, though. a function that can be defined with the function keyword or as an arrow function. Now, what's really important to understand here is that what we're doing here is we're creating a new function. An anonymous function here, since it has no name, but nonetheless a function. And we could absolutely create that function manually in a separate step. It could be named handle timeout or anything like this. And here we could console log timed out. So this would now be a regular function. And we could also alternatively define it as an arrow function. Could be named handle timeout2. And we store an arrow function in that constant, because arrow functions never accept a name in front of them. They always are created in an anonymous way, but we can make them non-anonymous by then storing them in a constant or a variable that has a certain name. And then here I could console log timed out again. Anything like this. So here I'm creating a function with the function keyword or as an arrow function stored in a constant. And we can now also pass this function or this constant that contains a function as a value to set timeout. So as a value for this first parameter that wants a function, instead of defining the function right here in place, which would be an alternative though. Now, what's really important to understand here when you're passing a function to another function though, is that when you're not defining it here in place, but instead you defined it in advance, you pass it by just using its name. So you don't add parentheses here. You omit those parentheses. Because by just using the name here, you're passing the function as a value to this function. If you would add parentheses here, you would instead make sure that this function, handle timeout here, gets executed immediately at the point of time when this timer is set, in this case here, and therefore it would be the return value of that function, if it would return any value, which this one does not, that would be passed as a value for this first argument, this first parameter, to set timeout. And that of course would be the wrong thing to do here, because here I don't want to pass the return value of that function to set timeout, but instead the function itself. So that internally set timeout can execute this function at some point in the future. And that's why you must omit the parentheses here, so that you don't execute this function right away, and you instead pass the function as a value to set timeout. Well, and then here, set timeout takes a second argument as well, which is now not a function, but instead a number, which defines the number of milliseconds JavaScript should wait until it executes this function, which you passed as a first argument to set timeout. And I can of course also do that with handle timeout too. Now, just to be clear, you can always create an anonymous function instead of defining a function in advance. And then you could of course also add any code you want to execute to that. But when you define such an anonymous function, you're also not executing it yet. Instead, you're also just defining it, and you're passing that defined function to set timeout. So you're in the end doing the same as you're doing here by defining it in advance and passing a handler to that function, the name of the function, to set timeout. You're essentially doing the same here when defining the function in the place where it's needed. You're still only defining it. You're not executing it immediately. Well, and therefore here, if you save that and you reload, you'll see nothing initially, but then once these timers expire, you will see the different messages they output. Now, knowing that you can pass functions as values to other functions is an important first step. But you should not think that this is only possible for built-in functions, like setTimeout. Instead, you can also build your own function, like greeter, for example, which accepts a greet function parameter, so a regular parameter in the end, but a parameter which expects to get a function as a value. And then inside of greeter, we could execute greet function like this, so calling it as a function by adding these parentheses. And now we could call greeter like this, and pass a function to greeter. Like for example here, an arrow function where I console log hi. If I do that and save everything and reload this page and open this console, you will see hi here. And this hi is of course coming from this console log message. So this function here is getting executed because we're passing it as a value for this greetFN parameter to the greeter function. And inside of that greeter function, I'm then executing this greetFN parameter. So the value that's received on that parameter, which is this function. So this function down here is passed as a value to greetFN. And then greetFN is executed here. Therefore, indirectly, this function is getting executed there. Because this function down there at the bottom is the value received here on greetFN. And I just wanted to mention this here because it really is important to be aware of the fact that passing functions as values is not limited to built-in functions like setTimeout, but can be done with all functions, including your own functions. Those can also accept functions as input. Now, another thing related to functions, which you'll see quite a bit in this course, is that you can define functions inside of functions. Now, when writing vanilla JavaScript code, this often might not make too much sense. But it will make more sense in the context of React, as you will see later. Nonetheless, you can define a function, for example called init, which then contains another function defined inside of it. For example, a function named greet, which console logs something. Then, inside of init, you can execute greet, but you can't execute greet outside of init, because greet is now defined inside of init, and therefore it's scoped to this init function, which means it's only available in there, just as a variable you would define in here would only be available inside of init and not outside of it. And therefore, inside of init, you can execute it, but outside of init, you can't. Here, though, we can execute init because init is scoped to the overall file, since init is not nested into another function. And therefore, with this code here, if you reload this, you will see that we do output hi, so that this code here does get executed, because in the end we're executing this function, which then internally calls greet, which is this function here that was defined inside of init. So you are able to define and execute functions inside of other functions. And again, whilst this is not something you might be doing too often in just JavaScript, it is something you'll do a lot, as you will see throughout this course, when writing React code. Now, the last crucial concept I want to cover here is related to reference versus primitive values. And what do I mean by that? Well, if we got a string, like user message here, that's a primitive value. Strings, numbers, booleans are all primitives. What's special about primitives in JavaScript is that we can't edit them. I can of course overwrite user message and store hello there, but that's a brand new string. The old string, which was stored in memory, will simply be thrown away. It's not edited to be this string. Even if I execute a method on user message, because just like arrays, strings do come with methods you can call on them, and I, for example, concat another string by using the concat method, this will produce a new string instead of editing the old string. So when dealing with strings and numbers and booleans, you always produce new values. You can't edit existing values. This changes when you're dealing with objects and arrays, which technically, as mentioned before, are objects. If I have a hobbies array here, with sports and cooking, let's say, and I then use, for example, the push method, which is a built-in method To also add working to that array, I edited the original array. If I console log hobbies here, I get this new array which contains working as a third item. Because push indeed edited the original array, it mutated the original array. Because arrays are objects, and objects in JavaScript are so-called reference values, which in the end, to simplify it a bit, simply means that in a variable you don't store the value, but instead the address of that value in memory. So that array is stored somewhere in memory, so in the memory of your computer, and it's the address of that place in memory that's stored in this constant. When you then call push, for example, JavaScript will reach out to that address, open the value in that address, so take a look at that array in this case, and add this new item to this existing array in memory. So the array in memory changes, the address does not. With primitive values, like this string here, you could instead say that the string itself is stored in the variable. This is technically not 100% correct, but you can think of it like this. So you don't have this address thing here. This instead only matters when you're dealing with objects. There it's this address that's being stored. And that's also the reason why I can edit this array despite using const here. Const means that the value can't be edited, right? And still I can do it here. Well, because const technically does not mean that the value can't be edited, but that the variable can't be overwritten. So when using const, I can't use the equal sign operator to assign a new value. That won't work. If I save this, I'm getting an error. But I can absolutely store objects in a constant and then take advantage of the fact that those objects are accessed by reference, by address, to manipulate those values in memory by using that address. And I'm just mentioning this here because it can sometimes be confusing that I can edit an array, for example with push, despite that array being stored in a constant. Well, as I just explained, I can do that because I'm storing the address in this constant, and the address doesn't change, so I'm not violating this idea of having a constant variable which is not overwritten. But I'm instead editing the value that is behind that address. And that in turn absolutely is allowed. So in the first course section, we learned what React is and what it's about. We had a first general overview of React and why we might want to use it. In this course section, we are now going to dive into all the basics you need to know to build any kind of React app. We're going to explore all the base features, and most importantly, we are going to learn how to build component-driven user interfaces. So how to build user interfaces by embracing a concept called components, which turns out is actually embraced by React. And of course, I will explain what exactly these components are and why React embraces them in this course section as well. Now, specifically for that, as I said, we're going to learn about all the base features that make up React, all the core syntax. We're specifically also going to learn about a feature called JSX, or a special syntax called JSX, what that is and why we use it. Then, as I also mentioned, we're also going to learn what these components are, but most importantly also how we can build our own components with React and how we can use them and how we can work with them. And we're going to learn how we can work with data in React apps. Because most web applications are not just about showing some static text, but about outputting some data or updating some data when things change on the screen. And that's therefore also what we're going to learn in this course section, but also in the next course sections in general. Now, of course, I don't want to teach these things by just using some boring theory or slides. We will have all the required theory, though hopefully it's not boring, but we will also build this first example project here, this example web application. This here is entirely built with React, and we are going to build it together throughout this and the next course sections. And I'm saying and the next course sections because it turns out that React has a bunch of core features, and we will need a lot of these features in this application. It might look fairly trivial, but it actually isn't. Once we finished this first application, which also is not the only one in the course, you will have learned about basically all important key concepts which you need over and over again in any React app you're going to build. Now, what is that though? It's an expense tracker. We can see our expenses also by year here. We can filter. And you see, as I filter, this user interface automatically updates. It updates and with a nice animation, and it shows us the expenses for a selected year. And of course, we can also add a new expense. For example, maybe I bought some books for $39 in 2020, let's say on December 16th. And if I add this expense here, you see it shows up here, the chart updates, and the data is also there if I switch to another year and then back to 2020. So this expense tracker is what we're going to get started with. And as we're going to build it step by step, we are going to learn about all the key concepts you gotta know when working with React. So let's now dive into all these important basics and fundamentals. And for that, keep in mind what you learned in the first course section. React is a JavaScript library for building user interfaces. And we also learned that, of course, in general, HTML, CSS, and JavaScript are about building user interfaces as well. But I also mentioned in the first course section that we use libraries like React because that simplifies building those user interfaces. We don't need it. You can build any website without React. But if you're having more complex user interfaces, like the one we have in this expense tracker, if you use something like React, it all of a sudden becomes much easier to build something like this. You won't have to focus on all the nitty-gritty details, and it will be less error-prone if you use something like React, because you will be able to focus on your core business logic that makes up your application instead of having to focus on the actual steps of updating the page when something happens somewhere. That's why we use libraries like React. And to make that job simpler for us, to make that work simpler for us, React embraces a concept called components. React is all about components. But of course, that brings up one important question. What exactly is a component? Well, let me come back to this question in a second. Instead, let me come back to this first sentence here. Even though we don't fully know yet what components are, why could React be about one concept in its core? Because all user interfaces in the end are made up of components. So what could be a component then, if it is something which is crucial in all user interfaces you see? Well, let's have a look at this finished application which we're going to build throughout this and the next course sections. If you have a look at this user interface, at this web application, you might be able to identify a couple of building blocks that make up this interface. For example, have a look at the expense items down there. This, in the end, is the same item being repeated twice here. It's the same item, just with different data. The same would be true, by the way, here for this chart. The individual bars in that chart That's the same item, just repeated with a different label and a different amount of filling. And that is exactly what components are: reusable building blocks in your user interface. Components are in the end just a combination of HTML code, CSS code for styling, and possibly JavaScript code for some logic. And you don't have to reuse a component to make it a component. It's just one of its traits that it is reusable. But on this user interface, which you see here, there would be more components than just these expense items and these chart bars. The item here at the top would be a component. If we expand it, this would then be more elements inside of that component. That filter here would be a component. The overall chart would be a component. The overall list of items would be a component. But inside of the items, we could say this date item here would be a separate component. The amount here would be a component. We can really split it up in a very granular way if we want to. We got all these individual building blocks which we combine together to build a user interface. And in the end, of course, all user interfaces can be split up into components like this, into containers and buttons and input elements and product items which are being output, something like that. All user interfaces on all kinds of web applications can be split up into components like this. And React is all about these components. You build these individual components, and then you tell React how to compose them together into a final user interface. And React embraces this concept of components because of that reusability aspect, and because it allows us to separate our concerns. Both concepts are important concepts in programming in general. Having reusable building blocks helps us avoid repetition. And in programming in general, it is good if we don't repeat ourselves. Having a separation of concerns helps us with keeping our code base small and manageable. Instead of having one large file which holds all the HTML code and all the JavaScript logic for the entire user interface, we have small separated units, these components, where every component has one clear concern, one focus, one specific task it focuses on. And if we split that code across multiple files, then, as we are going to do it throughout this course, then we'll have small pieces of code which are easy to manage and maintain. And these, of course, are not concepts or ideas React invented. Instead, if we take a step back from React and we think about programming in general, then, of course, in any programming language, and no matter what you're building, you tend to work with functions. And you split your code into multiple small functions, which then may call each other to outsource logic into a function, to separate concerns, and to be able to execute the same code multiple times if you need to. And React just picks up that concept of functions and of separating code across functions and translates it to the front-end web application world, where we build an entire user interface by splitting our code into multiple components, which we then can mix and match as we need to. So React is all about components. And I hope I could make it clear why it's all about components and what exactly a component is. So therefore, the next question is, how exactly is a component built? Now we'll dive into the concrete code in just a second. In general, it's just important to keep in mind what I mentioned earlier. In the end, user interfaces are about HTML, CSS, and JavaScript. And therefore, all these components are about combining HTML, CSS, and JavaScript. When we work with React and we build components, we in the end do just that. We combine HTML, CSS, and JavaScript in all these components, and then we combine all these components together to build the entire user interface. Though I will say, whilst CSS of course matters, and we're going to add CSS in this course, it's the least important part here. Mostly React components are about combining HTML and JavaScript. And then of course you also can add CSS, but that's not the focus of React. Nonetheless, I will teach you of course how you can make sure that your components look beautiful. So, long story short, React is all about components and about building these components which we combine together. React allows you to create these reusable and reactive components, and you are going to see what reactive means in detail later. React allows you to build these reusable and reactive components consisting of HTML and JavaScript, and as I mentioned, also a bit of CSS. Now here's the important part though. As you will learn throughout this course, React uses something which is called a declarative approach for building these components. And you will see what exactly that is, but it basically means that with React, you will not tell React that a certain HTML element should be created and inserted in a specific place on the user interface, as you would be doing it with vanilla JavaScript, so with just JavaScript, for example. Instead, with React, and that's really important, you will always define the desired end state, the target state, or possibly also different target states depending on different conditions. And it's then React's job to figure out which elements on the actual web page might need to be added or removed or updated. And you don't write these concrete DOM updating instructions on your own, as you would be doing it with just JavaScript. Instead, with React and React components, you just define these end states and under which conditions which state should be used, and then React will do all of the rest under the hood. It's a bit like magic. It's of course not actual magic, but it will make your life as a developer much easier. So you could say that in the end, we just build our own custom HTML elements and we combine them together for building a user interface. But that's enough of the theory for now. Let's now finally dive into some code and start building these components. So in order to finally get started with this course project and to finally write some React code, we of course need a React project. And you could create a new React project as shown in the first course section, either locally, for example with create React app by using this command, which I also showed you in the first course section, or you go for a browser-based solution by typing react.new into your browser address bar, which gives you a new React project running in Code Sandbox in your browser. But for this section, as for almost all sections in this course, I actually already created a starting project for you. And you find it attached to this lecture. You find a zip file if you want to follow along locally, and a Code Sandbox link if you want to follow along with Code Sandbox, so without installing anything on your system. Now, if you do go for the local project, you must have Node.js installed, as mentioned in the first course section, and you should in general take a look at this lecture in the first course section where I explain how to create and run React projects locally on your system. And inside of that downloaded starting snapshot, so inside of that unzipped zip file, you must run npm install as a first step to install all dependencies that are required by this project to run correctly. You don't need to do anything like that on Code Sandbox, but you do need to do that locally on your system. You can ignore any warnings you might be getting there, But after you ran this command, you can run npm start to start that development server, which allows you to preview this React project. And that's the React project with which we'll continue over the next lectures. And we'll start by taking a closer look at that src folder, this source folder here. So let's now have a look at this src folder, because that is where we will spend the majority of our time. That is where we will write our React code. And the first thing you'll notice here in this starting project, which I provided in the last lecture, that we have 2 JavaScript and 1 CSS file. And the most important takeaway here, which I really want to emphasize right away, is that React code is just JavaScript code. We are just going to write some JavaScript code throughout the entire course. We're going to use React features and some special syntax introduced by React, but ultimately, it'll all be just JavaScript. Now let's start with the index.js file. You don't see it anywhere, but I can tell you that this is actually the first code file which will be executed whenever this page is loaded. So whenever you visit localhost 3000 here at the moment, this index JavaScript file holds the code which is executed initially. Though I will also say right away that it's not exactly that code, but a transformed version of that code. Remember when I said that our project setup here involves some scripts which transform and optimize the code? Yeah, that is happening behind the scenes. Basically, we will write the code in a easy to read, developer friendly way with some syntactic sugar, which makes our life as a developer easier, but we'll write code which wouldn't run like this in the browser. And especially not in all supported browsers. Therefore, the npm start process which we started here, which started this development server, which is watching our code, this process will not just watch our code and then take it and deliver it to the browser, but before it delivers it, it will transform it so that certain extra features work in the browser, even though they wouldn't work if just this code would be taken. For example, this import here, where we import a CSS file into a JavaScript file. That's not something which would work in regular JavaScript. That would be an invalid syntax. You can't import CSS into JavaScript. Well, here in this project setup, it does work. Here, in the end, it tells this npm start process, we could say, that we simply want to include this index CSS file into our overall application. That the CSS code in there should be considered and should be injected into this page, which is shown here on the screen. And that's why the styles defined in there, like the font family, but also the background color of the body, are picked up here on the screen on the page that we see. Another example for a syntax, which is not regular JavaScript syntax, would be this here. It looks like some kind of HTML code inside of a JavaScript file. And normally this also wouldn't work. Well, again, here it does work, but only because this is transformed before it's delivered to the browser. And for the moment, you just need to be aware of that those transformations happen, and that the idea of that simply is that we can write code in a nice way, in an easy way, and then still we have code in the end which runs in all browsers. Now, the fact that the index.js file is the first file to be executed is just something you have to know. I'm telling you that this is the case, because indeed it is, and it's one of the few things you need to remember. Index.js here is the first file to execute. Now, what's that file doing though? What's happening here? Well, we are importing React DOM from React DOM, which in the end means we're importing something, some React DOM object, from the React DOM third-party library, which is one of our dependencies, which is downloaded and installed locally. Now, in the package.json file, you actually see two React dependencies. React just like that, and then this React DOM thing. And whilst this indeed technically are two separate packages, you can think of that as React, the library. It's split across two packages with different responsibilities, but in the end, React DOM and React, these two dependencies, together form the React library, which we're going to learn all about in this course. So whenever we import something from React or from React DOM, it's basically both all about React, and we're using React features, as we're doing it here in Next.js, where we are importing from React DOM. This simply makes a feature exposed by the library available inside of this index.js file, because that's how modern JavaScript works in general. If you define a feature, let's say a function, in file A, and you want to use it in file B, to split your code across multiple files, to keep every file small and manageable, then you have to export the feature which you want to use in file B in file A, and then import it in file B. And that's what we're doing here. React DOM, this package, is exporting some React DOM object, and we're importing it here into index.js. And we are importing React DOM into index.js to then call a method on it, the createRoot method. This creates basically the main entry point, the main hook of the overall user interface you are about to build with React. That's the idea behind createRoot. And what this does in the end is it tells React where this React application, this user interface which you build with React in the end, should be placed in the web page that is loaded. And that leads us to one other file, the index.html file in that public folder. This folder is a folder in which we will rarely work, but it holds one important file, this index.html file. This is the single HTML file which is in the end loaded by the browser here. This is basically the only HTML file that is being used by this overall React application, because it's a so-called single page application. It has a single HTML file, and all subsequent changes on the user interface on the web page will be handled by React. And it's this single HTML file that is the entry point, the place where the React-driven user interface should be rendered into, so to say. And in this index.html file, we got a regular HTML document structure. And if we have a look at the body, you will find a div like this in here. A div with the ID root in this case. That's a regular div which actually doesn't hold any content. But that's the div where we want to attach or inject our React-driven user interface. So the user interface which we will build with React. And you're going to learn how that works throughout this course, of course. So it's this div where the React-based user interface should be rendered into, and therefore in index.js, it's this div with the ID root, as you just saw. Remember, we have the ID root on that div, which we select here with some regular JavaScript code. And then we use a method from the React library, from the React DOM library to be precise, which is part of the React library though, to tell React that this should be the root of our React application, the main place where the React application gets rendered to, so to say. That's what createRoot does. Then we store this root object in a constant or variable, and then on that object, on that root object, we can call the render method to tell React what should be rendered in that div that we selected here. And you could, by the way, of course, also select other elements like spans or paragraphs, but a div is the most common root element that is selected. And we're in the end telling React DOM that we want to render something, we'll have a look at that in a second, in this place. So that basically the content of this div, and as you can tell, there is no content, so what's inside of this div should be replaced with that. So of course that brings up another question. What is that app thing here? Well, first of all, it's also something which we're importing. We're importing app from the app file. And that's this app.js file you just may omit, and you should omit .js as an extension in your imports here. If it's another file, like a CSS file, you have to add it. But if it's a third-party library or one of your JS files, you omit the .js. Now we can tell that it's one of our files because we have a relative import path here, starting with /, which means please look in the same folder as this index.js file is in, and then use the app.js file, so this file here. And from that file we import app. And then we do something with it, but that is definitely not regular JavaScript syntax here. Indeed, it isn't. This is a syntax called JSX, and I'll come back to it in a second. But before I come back to that, there's one key thing you gotta know about app. App, in the end, is a component. And you might remember, components are important. Here, we see our first component in action. It's this app component, which we in the end render in the place of that element with an ID of root. So in place of that div, or inside of that div to be precise. So therefore, let's now have a look at this app.js file. And this is a fairly trivial file. It holds a function named app, and we then export this function. Because, as I mentioned, in modern JavaScript, if you have something like a function or a class or an object defined in one file and you want to use it in another file, you have to export and import it. So here in app.js, where this function is defined, we export it and then we import it in index.js. And that's how these two files are connected and how we can use a feature, in this case a function defined in app.js, inside of index.js. Now what's this app.js function doing though? Not much, as you can tell. It's a function named app. Starting with a capital character might be a bit strange, but it's valid JavaScript syntax. And then all we do in here is we return something. But what we return again is strange. It's HTML code inside of a JavaScript file. And again, that's not something you regularly see. It's also not something we're used to. And it's also not valid JavaScript code, normally. Yet here, everything seems to work. And the reason for that is that this is a feature called JSX. It's a special syntax invented and introduced by the React team, and it works in these JavaScript files because of our overall project setup, and again, because of these transformation steps which are running behind the scenes. But let's take a closer look at JSX and what it is and how it works in the next lecture. So we got this JSX code here, which is basically HTML code inside of JavaScript. Indeed, JSX stands for JavaScript XML, because HTML in the end is XML, you could say. So we got this HTML code in JavaScript. And again, this is really important. This only works because there are transformation steps running behind the scenes because of this process, this npm start process which we started, which transformed this JavaScript code to more browser-friendly code before everything is being served here. And indeed, you can see that transformed code if you want to. Simply open up the developer tools. And here I'm using Chrome, which is the browser I do recommend for development. Simply open up the developer tools in Chrome by going to View, Developer, Developer Tools, or by using that shortcut. And in these developer tools here, go to the Sources tab. And this shows all the sources, all the script files, for example, which were downloaded as part of this page. Now, in here, you'll see a couple of folders, but you should see some static/JS folder or something like that, which should hold a couple of JavaScript files. Now, the exact number and names of these files might differ, but ultimately, if you click through these files, you should see some code which looks fairly cryptic, and which is definitely not the code we wrote here, or we have here in these two simple JavaScript files. Well, it turns out that this is this transformed code. And it's quite a complex code, as you can tell, because React supports many features, and this code does not just contain our source code, but the whole React library source code and the whole React DOM library source code. So the code in these files is not just our code, but the entire React package code. That's something to keep in mind. Now, in these files, in the main chunk.js file here, for example, you see a function named app. Somewhere in there, you might need to search for it with Control F, but somewhere in there, in these files, you should find your app function. But of course, this function looks quite different to the app function we have here. That's a very lean function. This function is not so lean. Well, in the end, that's this transformed code, you could say. That is that code which runs in the browser, which is not the code we wrote, but that's what this code is transformed to. And if you have a look at this transformed code, and even that look might change over time, but it will definitely not look like this. If you have a look at this transformed code, that probably is not code we would like to write. And that's why we have these transformation steps, because we can use this special JSX syntax, which is not normally supported in the browser, whilst we're writing our code, and still it'll automatically be transformed to code which does run in the browser. So that we have the best of both worlds. Code which works in the browser, which obviously is important, and code which is easy to write for us as a developer. And I'm just putting so much emphasis on this because that can be super confusing if you're new to React. You do know some basic JavaScript, at least you should, and all of a sudden you see code like this, which is not regular JavaScript. Well, this is just developer-friendly code which we can write, which is transformed behind the scenes. Okay, so enough about JSX and all of that. Let's now really get our hands dirty. We have this HTML-ish code here in this app function. And we have that code here because with React, we ultimately build our own custom HTML elements, as you learned. We build those components, and a component is basically just a custom HTML element. And we do that with this declarative approach, as I mentioned, which means with React, we define the desired target state, and React is then responsible for generating and running the actual DOM instructions which update what's visible on the screen. And we can see this here. This here is our desired target state. We want to, in the end, render a div with the h2 tag with this text inside of it on our screen. Because in index.js, we render this app component, this custom app HTML element, you could say. And inside of this custom element, which turns out just to be a function, more on that in a second, inside of that, we in the end just return this HTML code. So therefore, ultimately, it's this HTML code which is rendered on the screen. And that's indeed what we're seeing here. Now let's tweak this code a little bit. And here in app.js, in this function, in this returned HTML block here, let's add a paragraph where we maybe just say this is also visible. If you add this and save this file and you have this development server running, which you should, it'll automatically pick up this change, it'll notice when this file changes, and it will automatically update what you see on the page, and therefore we now also see this text here, this paragraph.
So that's how we can work with that. And we can just define that we want to have a paragraph here. Now keep in mind, in regular JavaScript, you would kind of select the element on the page, for example, with document get element by ID root, as we're doing it here. But then you would not be done. If you then want to add a paragraph, you either set the inner HTML content to something, or you first of all create a new element with document create element, creating a paragraph, and then you got your paragraph here like this, and you would set the text content to this is also visible, and then you would reach out to some place in the DOM and then simply call append or append child and add this created paragraph. That is how you would do it in regular JavaScript. And this is called imperative. This is following an imperative approach, because you are giving clear instructions, clear step-by-step instructions what JavaScript and the browser should be doing. Now, this works, but it can get cumbersome. For complex user interfaces with dozens or hundreds of elements, which also might be changing and appearing and disappearing all the time, having to write all these instructions is very cumbersome. With React instead, we just define the desired end state, that we want a div and a h2 tag and a paragraph, and React will then generate these instructions behind the scenes to bring that onto the screen. That's how this works behind the scenes. Now, I did mention, of course, that for all of that, React embraces this concept of components. And as I also already mentioned, we do have our first component here, app, so this function in the end, as it seems, in app.js is a component which is used like a custom HTML element here in index.js. Let's now build up on that and let's build our first custom component. And since we ultimately want to build that expense tracker, let's also build our first component in the context of this expense tracker. Now, to work towards this expense tracker, let's again think about the kind of components we got there. And you might remember that in the end, we were able to split up this simple looking application into a bunch of components. In the chart, we had the individual chart bars, we had the individual expense items, we had the form for adding a new expense, and therefore we get a bunch of components, and a bunch of components we could get started with. Now, why don't we get started with the expense item though? So this row where we have the title and the amount and the date of an expense. And therefore we now want to build our first own component. Now we could add it here in app.js, but it is considered a good and best practice to actually put new components into new files, so that you have one file per component. And that will mean that in React projects, you will end up with dozens or hundreds of files, because in React projects, you'll have dozens or hundreds of components in the end. And that's absolutely normal. Now, to organize our source code a little bit, here in the source folder, I'll add a components folder, which will hold all these component source files. Now, I will not move app.js in there, because this app component will be a special kind of component. Not regarding its code, that will be the same code as you see it in all the other components, but regarding its role in the application. It will be our so-called root component, which means it's the main component being rendered here in our starting file in index.js. And all other components will be either nested inside of app.js or nested inside of other components, which then in turn again are nested somewhere else. Because ultimately with React, we build a component tree, you could say. You have this main app component at the top, and then below that you could have any other kinds of custom HTML elements, so other kinds of components, which in the end hold other pieces of the user interface. And big applications, therefore, of course, can result in quite big component trees, where only the topmost component is rendered directly into the HTML page with help of that React DOM render instruction. All the other components will not be rendered with this instruction, but instead will be used as regular HTML elements inside of our HTML code, inside of our components. But you'll see that all in action in a second. So inside of the components folder, I'll add a new file. And I'm using shortcuts here. You can also use these buttons, of course, for adding folders and files. And I'll add a new file here, which I will name expense_item.js, because this will hold my expense item component. Now, one word about the file name. Here again, you are generally free to name this however you want, but it's a common convention in React applications to name it like this. Starting with a capital character, one word, where if you combine multiple words in one word, every sub-word, so to say, starts with a new capital character, like the I here in item. And then inside of this component, if the file is named like this, you of course should have a component that is dealing with rendering expense item data, so that the file name tells us which kind of logic and HTML code will live inside of that file. So now let's write the concrete component code in that new file. And of course, that means that we now finally have to understand what component code is. How is a component written in React? Well, we already saw it in app.js. It's just a function. And that is a key takeaway. That is super important. Definitely keep that in mind. A component in React is just a JavaScript function. A special kind of function, special regarding what it returns, that it does return this JSX code, but other than that, it's just a JavaScript function. Therefore, if we want to create an expense item component here, we add the function keyword, give it any name of our choice, though again, the convention is to repeat the file name here, just without the extension, so expense item. And then in here, we return the HTML code, the JSX code, which should be brought onto the screen by this component. So for the moment, I'll add a h2 tag here and say expense item in there. Now that's our first very basic custom-made component. And of course, it's quite similar to the app component, which I gave to you, because in the end, all components are similar. Components are just functions which then return HTML code. And of course, the HTML code you do return in a component depends on what that component should render on the screen. Of course, that's not our final HTML code for this kind of component. Now, to use this component, we need to export it. Otherwise, it's only usable inside of that file, and that's not helpful to us. So we add an export statement, which in JavaScript simply looks like this. We export this function as the default for this file. Now we can import it in another file. And as I mentioned, we're not going to import it in index.js, and we're not going to render it like this, because we only do this once for our root component. Instead, I now want to use my custom component here like a regular HTML element, so like a h2 element, inside of the HTML code written in the app component here. Hence, at the top of the app.js file, we should now import our custom component. So we simply import expense item from /components. We need to go into this components folder because that's where the file lives, /expense item, and then without the extension. This path in the end tells JavaScript that we're looking for an expense item file in a components folder which sits next to this app.js file in which we have this import statement. Now that this is imported, the cool thing is that we can just use this like a HTML element. So we can, for example, replace this paragraph with expense item, like this, opening and closing, written like this. The key difference to the built-in HTML elements just is that it's not starting with a lowercase character, but with an uppercase character. And indeed, your own custom components must start with an uppercase character when you're using them in JSX code like this, so that React is able to detect that this is a custom component. Because the simple rule which React applies is that lowercase elements are built-in HTML elements, so it will look for them as built-in elements, whereas elements starting with an uppercase character are elements defined by you or some other developer. So this is a custom-made component, and we have to use the name which we used here in the import as a name here, because that's how this connection is established. This tells React that we want to use this component which is imported under this name from the expense item file. If we now save everything, all the files, and we go back to the browser, we see expense item showing up here, which of course is the h2 tag rendered by our own custom component, because we now created and imported and used this custom component. And it's always these steps. You create a component, which is in the end just a function returning some HTML code. You then export it, and then ultimately you import it in the file where you want to use it, so that there in the JSX code you can use it like a HTML element, just starting with this uppercase character. Okay, so we created our first custom component. It's definitely not too exciting, but it is a custom component. And we're using it in app.js. Now let's make it a bit more exciting at least. And for that, in the expense item.js file, I want to tweak the HTML code which is being returned here. Let's say an expense item should not just be some title, but we also want to display the amount of this expense and then also the date. So therefore, we want to write HTML code which nicely displays and structures these three pieces of information. Hence here, we could say that we want to have a div HTML element which displays the date later. And for the moment, I'll just put date here as a placeholder. And then next to that div, I'll have, let's say, another div which actually should display the title, let's say inside of a h2 tag, title. And then also another div next to the title with the amount. Now you can see this is getting unreadable, but even worse, it seems to have an error. My IDE is complaining about this line of code. Now regarding the readability, we could try to split it across multiple lines, but that would be kind of invalid. But we have a bigger problem anyways. This code is not valid like this. In React components, there is one important rule regarding this HTML, this JSX code which you return inside of a component. You must only have one root element here per return statement, or per JSX code snippet, you could say. And here we have this div side by side with this div, which means we have two root elements here in this statement. And that's simply not allowed. Now, why is that not allowed? That's something I'll come back to in a deep dive lecture later in this section. For the moment, let's just accept that this is not allowed. And therefore, the question is how we may work around that. One of the easiest workarounds is to wrap this into another div, opening and closing. So an opening div and then a closing div. I will also show you another workaround later, but that is a simple workaround we can apply immediately. Now regarding the readability, we can improve that by also wrapping this all in brackets, simply to signal to JavaScript that this is one and the same statement, even if it should span multiple lines. And then we can restructure this as we want to. Though the quickest way of restructuring this really is to use the auto format shortcut, which I just did. You can find this if you go to your preferences, keyboard shortcuts, and there you search for format document. This shortcut, if you press this, it automatically formats your code and makes it easier to read. And I will use this shortcut a lot throughout this course because it keeps our code readable and manageable. And now we expanded this HTML code of this component, and we now have more than just one h2 tag. And very important is that rule of having only one root element. Inside of this one element, which we return here, so inside of this main div, which we return here, you may then have multiple elements, and these elements then also may be side by side, as you can tell. It's really just the root element in a JSX code snippet, like here when we return it, which must only be one element instead of multiple side-by-side elements. But with that, we now prepared our basic structure here. Now, of course, for title, we might now say car insurance. For amount, we maybe say $249.67, something like this. And for date, we might say something like March 28th, 2021. Something like this. And if we now save this, that's what we see here. Still not looking super nice, but we can see it, and we can see that we can have more complex HTML structures inside of our components as well. Nonetheless, of course, our applications also should look nice. They should not just have some HTML code which is ugly. So let's now have a look at how we can add some basic styling here. Now, regarding the styling of our components, we still use CSS, but there is nothing too React specific when it comes to that CSS code. In the end, we can just add a new CSS file, and typically, for the CSS code of a given component, you add that file next to the component JavaScript file, and that would be the expense item.css file here. Then you want to write your CSS code in there, but since this is no CSS course, I don't want to bore you with writing a lot of CSS code, and hence you attached find a finished expense item CSS file, which you can simply download and use, or simply download it, open it, and copy the code you find in there into your expense item CSS file. Now, back in expense item.js, we need to do one important thing. We need to make this overall build process aware of that CSS file and tell it that the CSS code in there should be considered and should be injected in the finished application. Because it's not by default browsing all your files and automatically including everything. You explicitly have to tell React, you could say, or that build process, that a certain file should be considered. For expense item.js, we did this with this import in app.js. For expense item CSS, we need to do that inside of expense item.js. There, we simply import /expense item.css, just like that. This simply tells the build process that the CSS file should be considered. Now, inside of that CSS file, I in the end just prepared a bunch of CSS classes which can be added to elements to apply a certain look. And therefore now on this HTML code in expense item, in our component, we need to add these classes. For example, on the wrapping div here. Now there's one special thing here. We don't type class here, as we would do in regular HTML, but instead class name. And this can be strange, but you have to keep in mind that this here is not really HTML. It looks like HTML, but it's this special JSX syntax invented by the React team. And in the end, under the hood, it's still JavaScript code. That's why most attributes are the same, but not all. And here, the class attribute was renamed to class name because class is a reserved word in JavaScript. Technically, it would still work if you would use class here, but you should use class name. Now here on this overall div, which wraps everything, we then add the expense-item class here. On this div, which holds our title and our amount, we add another class name, which is expense-item __. So here we got 2 underscores, description. And then here on that div with the amount, we simply add class name and then expense-item __, price. And if you now save everything, it should look like this, which is definitely nicer. Still not the final look we want, but definitely nicer. By the way, I'm super zoomed in here to make this easier to read, otherwise it would look something like this. And that's definitely also not great, but again, it's not the final look. Again, let me zoom in closer so that we can better see that though. Now that is how easy it is to add styling to your React components though. It's really not too fancy. You have to be aware of the fact that it's class name instead of class, but other than that, it's really just standard CSS code, which then is added to your elements. And in that CSS code, you can use all the selectors you might know. You're not limited to classes, but again, I don't want to turn that into a CSS course, so we'll keep that fairly simple. This import might be the strangest thing in the end, because that is needed to make this entire project aware of that CSS file. And that's how we can style our components. So now we know how to style our components. And again, we're definitely not done here. This is not the final look I want to have. But before we dig deeper into tweaking the final look and adding more UI elements, let's think about one maybe obvious problem. We will probably not just have one expense, and definitely not an expense where the data is just hard-coded into the component as it is here. The date is hard-coded here, the title is hard-coded, the amount is hard-coded, and it's the only expense we have. In our final tracker, we want to have an unlimited amount of expenses if we want to. We want to have multiple expense item components in action. And after all, that is one of the core ideas behind components. It's not just the separation of concerns, it's also the reusability. We want to define a component and its HTML code once, and then we want to be able to reuse it. And at the moment, we're not able to do that. Therefore, that will be the next problem we'll work on. But before we work on that, there's another problem which we have to solve first. And that's something I just mentioned, that all that data is hard-coded here in this JSX code. This is unrealistic. Some data may be hard-coded sometimes, but here for an expense item, something like the date and the title and the amount would typically be dynamic, which means it's not hard-coded in the HTML code. Instead, we receive that data from somewhere, for example, from the user who entered it into a form, and we then output it dynamically. Now, for the moment, we don't have the capabilities yet to receive it from the user, but we can fake dynamic data by at least adding more than just HTML code to this component. Because after all, we must not forget that a component in React is just a function. And that earlier I mentioned that components are the combination of HTML, to some extent CSS, and also JavaScript. Now we definitely see HTML in action. We also saw some CSS being added, but where's the JavaScript other than that being a function? Well, let's add some JavaScript code in that function before we return. For example, let's add a constant. so a variable which may never change. And in there, let's store a date by using the built-in date constructor, which comes with JavaScript. Let's give this constant a name. For example, expense date sounds like a fitting name. And then let's maybe set an initial date value here, which is the year 2021, March as a month, and since the month field here starts at 0, March has the number 2, and then there, the 28th. This is how we can create such a date object, and this, and that's really important to me, is just regular JavaScript. Has nothing to do with React. And we can, and we typically do, have JavaScript code like this in our components. Here, just to create some dummy data, later in the course and in your React applications, that could be any kind of code. For example, to send a HTTP request and fetch data from a database, to validate user input, or to do any other kind of task. So here we have our expense date. We can also have our expense title here, which is maybe car insurance. So a simple string stored in this constant. And then our expense amount, which is, let's say, a number, 294.67. So we have these three constants, regular JavaScript code, and we now want to output these values here in this HTML code. And that is a typical task. Typically, you don't have data hard-coded in HTML. Instead, to output dynamic data, you use a special syntax React gives you inside of these JSX code snippets. You can replace hard-coded data with opening and closing curly braces. Single curly braces, opening and closing. And the special thing about these curly braces inside of your JSX code snippets is that in these curly braces, between them, you can run basic JavaScript expressions. For example, 1 + 1. You can execute something like this there, and it's now the result of this expression, which will be output on the screen. So if I run 1 + 1 between curly braces here, we see 2. We can also do something like math random here and generate a random number with the built-in math object. And we see the number here. And every time I reload, I get a new number, of course. Now that's something we can do. Now here, I don't want to get a random number. I don't want to add 1 + 1. Instead, I want to refer to the value stored in this constant. And therefore, we can just repeat that constant name here. This is also a valid JavaScript expression, just pointing at a variable or constant, in this case a constant. And now JavaScript will extract the value stored in this constant and basically inject it here into this HTML code, so to say. So if I now save that, we again see car insurance here just like before, but now it's not hard-coded in the HTML code, but instead here it's output dynamically and the concrete value is taken from that constant. There, of course, it's still hard-coded, but it's just a first step. Now we can do the same for the amount. So here, after the $, which I will leave hard-coded for now, we can point at expense amount. And for the date, we can do something similar. Here, we can output expense date, though for the date, we have to keep in mind that it's a date object. And therefore, if we try to save it like this, it just breaks. Because this being a date object, it can't be output as text like this. However, we can call toISOstring, for example, a built-in method available on all date objects, to output it as a string, and now we see this at least. Not super readable, but a first step. Now we will refine and fine-tune the way this is being output later. For the moment, we just achieved one important thing. We now no longer work with hard-coded text in our HTML code, but instead we have these dynamic placeholders, you could say, where the concrete value can be the result of a calculation, of a HTTP request, or, as it is here at the moment, the value stored in a constant or variable. And now with that out of the way, we can move on and we can take a closer look at how we can make this expense item more reusable, so that it's not always the same data which we're outputting, and so that we can have multiple expense items based on one and the same component with different data. How can we make this component reusable? Well, the good news is we can already reuse it. In app.js, where I'm using it, we can simply copy that line and paste it in. And if we save everything, we got 2 expense items already. So that was easy. It's super easy to reuse a component. You can use it as often as you want. You can add it 2 more times and have 4 expense items overall. That will work. But of course, at the moment, it's not really reusable. Yes, it's technically more than once, but it's always displaying the same data. And the reason for that is that the data is baked into this component. Now, think about regular JavaScript without React for a second. There, I mentioned earlier already, we also use functions to split functionality across multiple smaller code bases, and also to have reusable functions which we can call multiple times. Now, when we write functions in JavaScript, then we make these functions reusable by accepting parameters. And that allows us to call one and the same function with different parameter values. And therefore, the function may and typically will produce different results for different input values, but it's still always the same function being called. And React basically has the same concept built in. We can make our components reusable by using parameters and a concept called props in React. Let's say in your app component, you have a goal item variable or constant defined, which holds a string of finish. And then let's say you have a custom component, the course goal item component, which has a list item inside of it, where this goal item should be output. That's just another example, not the code we've been working on, but it's another example. We can have a custom component which should output a list item, where the goal item should be output dynamically. The problem is that the goal item variable lives in the app component, not in the course goal item component. And to a certain extent that is good, because it makes the course goal item independent if it doesn't store the concrete value internally. But of course we want to define what's being output by a course goal item with help of the variable managed in app. And we don't have direct access to the HTML code output by some component in other components. We can't just send our stored data there, but instead we can utilize a concept called props. We can pass data to the custom component by adding an attribute. And inside of that component, we can then get access to all these attributes which might have been set on our custom component. Again, we're basically building our own custom HTML elements. And just as HTML elements can have attributes, it turns out that with React, our own custom components can also have attributes. There, this concept is just called props instead of attributes. And props simply stands for properties. We can set properties of our own custom components. Now, how does this props concept work though? In expense item, we have the date, the title, and the amount, and we'd like to output this here. But it shouldn't be stored in here, but instead in app.js. There, indeed, in this app component, we could have another constant or variable, expenses, which is an array, so multiple expense items. And let's say every expense here is a simple JavaScript object, which now has a title like car insurance, which also has an amount like the 294.67, and where we have a date like this new date we created here in expense item before. Now again, we don't just have one, but we have, let's say, 3 such expenses here, or maybe 4. Now, to make sure we don't have to type this all by hand, attached you find a simple text file which contains 4 dummy expense items, which you can just grab and copy into your expenses array. These objects also have an extra ID field, which we don't need at the moment though. Nonetheless, now you will have 4 objects inside of this expenses array. And now we want to pass the data of these different objects to these different expense items. That means we want to make these expense items configurable from outside, you could say. The data should not be stored inside of them, but instead received from outside. And that works with this props concept I just mentioned. In app.js, we can simply add attributes to these custom HTML elements, so to these components. I'm using these terms interchangeably here. And for example, we could add a title attribute here to expense item and set this to a value of toilet paper. So we can just type toilet paper here. But now I would in the end again be hard coding some data in this JSX code. Since we already have this expenses array here, I also can dynamically retrieve the title stored in this first expense item for this first expense item here. And we can do this by again using this single curly brace syntax. We can not just use this between opening and closing tags of elements, we can also use it for assigning values to attributes. And here I can then access expenses, which is this array, there the first item with index 0, and there this first item, like all items, is an object which has a title property, for example. So we can access dot title here. And now this title is being passed to this expense item. Now we can do the same for the amount. We set, let's say, an amount attribute, and these attribute names, by the way, are totally up to you. I'm going with title and amount here, but you could pick different names. And as a value for amount, I again access expenses and the first expense there, and then the amount field. And last but not least, we can add a date attribute and access expenses and there the first expense dot date. You just have to make sure that the part after the dot matches the property names here, because we are accessing these objects. Now I'll hit the auto format code to make this easier to read by splitting this across multiple lines. And we can now do the same for the other expense items. So I'll just repeat this, but then access the second expense here and the third expense with index 2 and the fourth expense with index 3. Now if we save that, we see no change though, because we only did the first half of the work we need to do. We added these attributes with any names of our choice here because these are our custom elements. Hence these attribute names are up to us. But inside of that component code, so inside of expense item.js, we also now need to do something with these received attribute values. And that's the half which is missing. Now the question is, how do we get access to the values defined in the place where we use our custom components? And the answer is parameters. I mentioned that in regular JavaScript, we use parameters for passing data into functions, and it's kind of similar for React. However, we're now not getting a title and an amount and a date parameter, as you might think, but instead we get one parameter. React will ensure that we get one parameter in every component which we use as a component, like we're doing it here for expense item. And that one parameter will be an object which holds all the received attributes as properties, hence the name props for the overall concept. Therefore, we get one parameter, and you can name this parameter whatever you want. It's your function. You could name it data. But typically it's named props to make it clear that this is this object which holds all the values we get for the attributes on our custom element. And to be precise, we get key value pairs in this props object here, which is passed in by React automatically. The keys will be the attribute names defined here, so title, amount, and date in my case. And the values, of course, will be the values set here. So if I now want to output the title received, here in this h2 tag, I can now access props.title, like this. Getting access to this props parameter, and then there to the title property, which will exist because we set a title attribute. Now, if you chose a different name than title here, like for example, name, if you chose that as a name, for example, then you have to access props.name here. So the key which you access on your props object has to be the name you picked for your attribute. Now here I'll go back to title and therefore adjust it here in both places again, but you have to make sure that this matches. Otherwise it'll not work. Now which names you choose, if that's title or name or text or whatever, that's up to you. It's your component. But of course you typically want to choose prop names and therefore attribute names which are self-explanatory and which makes sense. So since we're passing in the amount here, amount makes sense. Something like some number would be valid, but wouldn't make a lot of sense, I guess. So I'll revert that. Now, therefore, in expense item, we can not just output props title, but also props amount. And here for the date, props.date.toISOstring. And that means we can now get rid of these three constants here, since we now get all the data we need from outside this component. We're not defining it inside of the expense item component, inside of this function, but instead it's in the end defined in app.js and passed into expense item for the different usages of expense item through attributes. And that's how you share data between React components. You can make your components truly reusable and configurable by using this props concept, which is one of the key concepts React has to offer. You'll use props all the time, so keep it in mind. It's super important. Props is a super important concept because it allows you to make your components reusable and it allows you to pass data from another component to this component. And hence, if we now have a look, we see these different expenses are rendered with different titles, different dates, and different amounts.
So props are a crucial React concept. Components would not be very useful if they weren't configurable with help of props. And therefore, when working with React and when writing React code, you will often set props on components and accept props as input. Now, there are two things I want to mention here, two alternative ways of accepting or setting props you should be aware of. And I'll start with an alternative way of setting props. Because the use case we have here, where we have a component that needs almost all the data we're working with in this app, so that needs almost all fields of that raw data, that use case is quite common. And you can then absolutely set up multiple prop key value pairs. So define multiple props of different names and pass your different values through those props. But an alternative would be to instead create an expense item where you just pass one prop that could be titled expense, for example, though the name, as you learned, is up to you. And instead of passing the individual values through multiple props, you could then pass the entire data point, so the entire object in this array, in this case here, as one single prop. So as a value for one single prop, the expense prop in this case here, to expense item. You could do that as well, instead of passing those individual props. If you would use this approach here, where you pass one single prop instead of multiple props, you of course also would have to change the code inside of the component. Because now you no longer get the title as a prop, instead you only get the expense prop, or whichever name you chose for the prop. So then here in the receiving component, you would have to write props.expense.title, props.expense.date, and props.expense.amount. And of course, now we would have to migrate all expense items to this alternative way of passing data to the expense item. Now, I want to emphasize that both approaches are fine. You can pass a single prop, which contains the entire object, or multiple props, which contain the individual values. This is entirely up to you because it's your component, but I definitely wanted to mention this alternative. With that, I'll delete this example though, and switch back to the approach I showed you before, because I think it's a bit easier to understand and read, especially when you're just getting started with React, but you could also pass everything in one data object. When working with props, both approaches are fine. So with that, I'm of course also updating expense item again, and I'm moving back to the individual props. Another alternative syntax you could use when working with props is exclusive to the receiving component. There we're getting this props object where we're then accessing the different properties, in this case date, title, and amount. Instead of using this approach, we could also use a feature built into JavaScript and use object destructuring right here in the parameter list. This might look strange, but is regular JavaScript code. You can use the object destructuring syntax here, where you add opening and closing curly braces, and where you then refer to the different properties of the object you are receiving here, so of the props object in this case, to pull these values by those keys here out of that incoming object and store them in locally available variables of these titles, of these names here. With that, the date prop would be accessed with just date, since we're pulling it out here. Title would be accessed under just title, and amount would be accessed under just amount. So here we're using object destructuring. This is not some special React syntax or anything like that. Instead, it's standard JavaScript syntax for using object destructuring right in the function parameter list. Now again, I will actually switch back to the old approach, which we had before, where we instead use the dot notation for accessing the different properties, but I wanted to share this alternative since you'll also see that in many React projects and since you personally also might prefer it.
Now that we learn about props, we're basically done with our first custom component. This expense item component is now reusable, and we can use this props concept to configure it differently every time that we're using it. So that the 4 times we're using expense item here, we're also getting a different output 4 times. I also just want to emphasize again that here we are indeed setting the values for the props dynamically with this single curly brace syntax, but we could also just have a hard-coded value like this here, if that is what we needed. So props are not limited to dynamically set values. We can do that, but we don't have to. The main idea behind props is always the same though. We want to make sure that we can pass data into our components to make them configurable and reusable. Now let's continue working on that expense item component, and let's continue working on that date. Because at the moment, this is clearly not too pretty, not too human readable. And instead of showing it like this, I instead want to have this calendar-like look, which you see here in this preview. I want to have my date look like that. And therefore, of course, we need to change that HTML code, that JSX code, and I'm using these terms interchangeably as well. We need to change that, which is responsible for outputting that date. And here, to build such a calendar look, we could say that inside of that main div, which should hold the overall date element, we want to have 3 individual divs like this, where the topmost div is responsible for outputting the month, the middle div is responsible for outputting the year, and the bottom div then shows the day. That's something we could do. And of course, for that, we want to extract month, year, and day from the incoming date. So from that date prop which we're setting. For that here, for the month, we can output a value dynamically in access props.date. And now what? How can we now output the month here? Well, we can use a built-in method which is accessible on all date objects in JavaScript. We can call the toLocaleString method. Now, this is not a React-specific method. You can Google for JS toLocaleString to find an official article on this method. And this method simply helps you with outputting dates in human-readable formats. And you can simply call it and then pass in 2 arguments, where the first argument is basically the language. And here I'll use enus to go with English. And then the second argument is an object where you configure how specifically that date should be formatted. And here we got different options where you can find more details in that article which you can find. Here you can learn more about the various ways of configuring this and using this. And here we can set month to long, for example. That's one of the provided options, or one of the supported options. And if we do that and save this, we see that August and March and June are being output here, so that we got a human readable way of outputting that month. Now, doing that all in line here in that JSX code clearly works. As I mentioned earlier when I introduced this syntax, you can have expressions like this between the curly braces. But it is considered a better practice, and it leads to cleaner code, if you extract logic like that and don't put it into your JSX code, but instead you create a separate helper variable or constant. Something like month here, which simply holds that value. And then here, between your curly braces in the JSX code, you just point at that helper variable or constant. By doing it like this, you keep your JSX code lean, and you have your more complex logic in the rest of this function, so that this overall is easier to read. And now we can do something similar for the day and the year. For the day, we can access props.date toLocaleString enus. And then here, pass in a configuration where we say that we want to format just the day and output it in a 2-digit format. And we can add a year helper constant where we access props.date. And then actually just access getFullYear, which is another built-in method which just extracts the year as a 4-digit number. And now we can use these helper constants to output their values like this in our JSX code. And if we do that and save that file, now we see the month, the year, and also the day in the month. And that's the raw data which I want to have here. Now, of course, one crucial thing is missing, and that would be the styling. But before we add that, let's talk about splitting components. As you work on your React application and on your React components, you will notice in any project that your components eventually become bigger and bigger as you have more and more logic and JSX code in them. This is something which will naturally happen. That is why React has this component concept. This allows you to split your application into smaller building blocks, where every building block, every component, is focused on one core task, you could say. And then you build your overall user interface by combining these building blocks. By doing that, you keep every component on its own relatively small and manageable, and you keep its code base small and manageable, and you still can build a complex user interface. Now, there is no hard rule when to build a new component versus adding more to an existing component. But in this component here, in this expense item component, we could already argue that it's getting a little bit too big, though I will say that this is definitely still all right. Nonetheless, we could argue that this date object here, this calendar item which we want to show on the user interface, could be treated as a separate component. Of course, the same case could be made for the title or the amount, or title and amount combined. As I said, there is no hard rule. But since for this calendar, we'll have a couple of helper constants and we'll have extra styles, I personally like to split this expense item component here into two components. The expense item component, which we already have, and then a new component for rendering this date in this calendar item look. And therefore, we're now going to create our second custom component. And for that, I'll create a new file in the components folder, and I'll name it expensedate.js. Now, as always, the file name is up to you, but I recommend that you follow this convention of naming it like this, starting with a capital character, one word, with every extra word also starting with a capital character. And again, it should also express what's happening inside of that file, what that component will be about. And this component will be about rendering the date of an expense. Hence, this sounds like a fitting name to me. Now in there, we create a new component, and that still is a function. Components in React are just regular functions with the extra twist of returning this JSX code. Now I'll name it expense date, again following this convention that we repeat the file name here. And I'll then export it to make it reusable outside of this file, like this. Now in here, I wanna calculate month, day, and year. So I'll cut this logic from expense item and move it to expense date. And therefore, of course, I need to accept props as a parameter here. And I do now expect that this component will be used such that a date prop is set. Now in expense item, I want to use this new component. But before we do that, I will actually grab this div with the month, year, and day inside of it and cut it as well and return that as JSX code inside of expense date.js. And now in expense item, at the top, we can add an import and import expense state from /expense state, like this. /expense state because we're looking in the same folder as the expense item.js file lives in. And now here, where we previously had our JSX code for the date, we instead output this expense state component. And as a side note, if you have a component that has no content between the opening and closing tags, you can also write it a little bit differently. You can write it as a self-closing element like this. This is then also okay. And we could do the same here in app.js with the expense item, since this also has no content between opening and closing tag. This is totally optional, but it is quite common to do that if there is no content between the opening and closing tag. So now we're using expense state in the expense item component. And we're doing this to move some of the JSX code and JavaScript logic out of the expense item into a separate component. This component is now again also reusable, and we can use it anywhere in this React application, not just in expense item. We could use it elsewhere as well if we wanted to. And it now also helps us with keeping expense item lean. This is now again shorter and therefore maybe a bit easier to maintain and manage. And the bigger your application gets and your components become, the more you want to look into splitting them up. Though again, just to really emphasize this, there is no hard rule on when to split. This is something which will come with experience, and you'll also see plenty of examples throughout this course. Now we must not forget though that our new expense date component needs a prop. It needs the date prop, at least that's the name I'm referring to here inside of expense date, to, well, extract that date and format it and extract the month, day, and year. Hence, on expense item or in expense item, when we use expense date, we should set the date prop. And if you used a different name here in expense date, you of course want to use a different name here instead of date as well. Now the value which I pass here will just be props.date. And I know that this is now the point where it can get confusing. Because now we're basically funneling some data through multiple levels of components. In the end, we can see this component tree come to life now. Because now we don't just have the app component and then one other custom component, but we have multiple custom components and they are nested inside of each other. Just to make this really clear again, in the app component, we're using the expense item component, and inside of the expense item component, we're using the expense date component. And not just that, we're also forwarding our data with the help of props through multiple components. We're passing data from the app component into expense item, and in expense item, we're outputting some of that data, but other parts of the data, to be precise, the date, which we here also already received through props, is then forwarded even further into the expense date component, again by using props. Because props are our way of passing data from component A to B. And it's also totally fine to have a component which just passes data on. So in the end, you could say we pass data from app to expense state, the date to be precise is passed on, and we passed it on through expense item. Because that's how props work. We pass data from a component to a direct child component, so to a component which is used in that other component's JSX code, and we can't skip such a component. So if the date should be passed to expense date in the end, here in this case, since we use expense date instead of expense item, we first of all have to pass that data to expense item and then forward it to expense date. I hope this is clear. If it's not entirely clear yet, that's also something you're going to see in great detail and in many examples throughout the course. Okay, but with that we are forwarding the date and we get this separate component now. If we now save that all, we again see our date data being output here. Now we also want to have some styling, and therefore I'll add a new file, the expense date.css file. And you again find that file attached. You can just replace yours with it, or open it and copy everything you find in the attached file into your expense_state.css file. And once you did that, you can go to the expense_state.js file, and at the very top of that file, import ./expense_state.css to make the entire project setup aware of that CSS file, and then add a couple of CSS classes here. On the surrounding div, we add a class name of expense-state, for example. On that month div, we add expense-state__month. For the year div, we add expense-state__year. And for the day, we add expense-state__day. And here I imported the wrong file. This should of course be expense-state CSS. And with all of that done, if we save this, now we got this nice look here for our dates. And this looks much nicer, and we also practiced how we can add yet another component. And adding this component was optional. We could have put everything into expense item, the entire JSX code, which we have in a separate component now, the helper constants, we could have added this all into one component. We could have also added the CSS code here in the expense item CSS code. But then this expense item component would become bigger and bigger. And whilst in this case it would have still been fine, it is generally a good practice to keep your components small and focused, and that is why we did extract this extra component here. So by now we got components everywhere. We got the expenses component, expense item, expense date, app, yeah, a lot of components. But that really is what React is all about. Now obviously throughout this course we're going to learn about more features which we can add to these components to make them more interactive, to improve their performance, to send HTTP requests, and much more. But in a nutshell, and that's really important, it's all about components. And it's about props for configuring these components, for passing data into them. And components really just are these custom HTML elements where you combine HTML code, JSX code to be precise, and styling, and if you want to, also extra JavaScript logic, as we're doing it in expense state. That is really what components are about. Now, I did mention it multiple times already. We build all these components to then build a user interface. And we are already doing that. In app.js, we're using expenses. In there, we are using expense item. In there, we're using expense state. Generally, this approach of building a user interface from smaller building blocks is called composition. Now, there's one specifically interesting aspect of composition which we haven't seen thus far though. What if we wanted to create a component which actually just serves as a shell around any kind of other content? At the moment, we have highly specific components. The expense date component is about outputting a date in exactly that format and in exactly that look. The expense item component is just about outputting an expense item. And in your React application, you will always have a lot of these very specific components. All these components are also just configured through props, through the date prop, the title prop, the amount prop, in the case of expense item, for example. And again, that is fairly standard. You'll have a lot of these components in your React applications. Sometimes, however, you want to have a component where you don't configure everything through props, but where instead you're able to pass content between the opening and closing tags of that component. And here's an example where this would make sense. If we have a look at our current output, then we see two kind of boxes or containers. We got a container around all the expense items. It has a light gray background and rounded corners, and a slight drop shadow, which might be hard to see. And we have a container around the overall expenses list with a darker gray background, but also rounded corners and a slight drop shadow. Now, the idea behind all these components is to have reusable building blocks, also to avoid code duplication. And here at the moment, we at least have some style duplication, also maybe some HTML structure duplication. Expenses has a div which surrounds our expenses, which applies certain styles thanks to this class. And the same is true for expense item. Now, of course, not all divs have the same look though. Inside of our expense items, we also got divs like this one, which have a totally different look. Nonetheless, we could extract this surrounding container div, which we have both in expense item and expenses.js, and extract the styles they have in common, like rounded corners and a drop shadow, into a separate component. And we could name such a component card, because this is a specific card look. And this is not a term I came up with. Instead, in general, in web development, when you hear the term card, it typically means some kind of container look with rounded corners, drop shadows, and elements like this. So that's why I'm picking card as a name here. Now, such a card component is still a regular component here. So let's create it as such. But such a card component could now do one main thing. It could return a div or any other kind of container HTML element with a class name of, let's say, card. And then we could add a card CSS file and import that into that card component. So import card.css. And now in the card CSS file, we could have, let's say, the box shadow and the border radius from expenses CSS. Maybe we would be able to extract more styles, but I'll go with these two. I'll cut them from expenses CSS and add them to card CSS inside of a card CSS class selector, which I added there. I will also go to expense item CSS, and here in expense item in this class selector, we also find a box shadow and a border radius. So I will remove these styles from there as well. Now, why am I doing that? Just to show this kind of component. Now we got this card container component, you could say, which should act as a shell around either our expense item content or our expenses content. And that's the key. This card component will now not be configured through some attributes. Instead, my idea would be that, let's say, an expense item, we can simply replace this built-in div with our custom card component. And then we get these predefined styles for the card automatically. Maybe we then just want to make them extensible, but we get these predefined styles automatically. And for that, of course, we want to import card from ./card inside of expense item. The thing just is, if I save that, you will see that all the expense items are lost. And the reason for that is that out of the box, just like that, you can't use your custom components as wrappers around other kind of content. Having content between opening and closing tags doesn't work just like that. But of course it does work for built-in HTML elements like the div or the h2 tag. So it would be nice if we could also make it work for our custom components to build such reusable wrapper components like this, for example. And of course, React has a solution here. We can build such wrapper components. In card.js, we again want to accept props. But now, as I mentioned, we'll not work with some attributes, but instead we will use one special prop which is built into React, which every component receives, even if you're never setting it explicitly. And that's a prop which value I want to output between the opening and closing tag of this div inside of the card component function. It's the props children prop. Children is a reserved name. We don't set a children prop on this card. I'm setting a class name prop, and actually at the moment this won't do anything. But I'm not setting a children prop. Children, as I said, is a reserved name, and the value of this special children prop will always be the content between the opening and closing tags of your custom component. So in this case, this content between the opening and closing card tag, that is what will be available on props children inside of that card. And therefore, if I now save this, we got some content back. However, it's also a bit broken. And the reason for that is that I extracted some styles, which expense item and expenses had in common, but I had more styles defined for expense items, and these styles are important. But they are missing now. I am setting a class name prop on card here, but you must not forget that card is now a custom component defined by you. All the default HTML components out of the box support class name for adding CSS classes to the rendered HTML elements. But your custom components only support what you tell them to support. So if you want to make sure that a class name can be set on your card component and then has an effect, we have to tweak the code in the card component. And here we would probably want to tweak it such that we add whatever is set as a class name on card to this class name string we're setting as a class name on that div. So here we could add a classes constant, which is card as a default class, which is always applied, whitespace plus props class name. So now anything we receive as a class name from outside is added to that string. And here we can then dynamically point at this class's constant. So with that, we're now making sure that any value set on the class name prop is added to this long string of class names, which is then finally set on this div inside of the card. And with that, all if we save that, we got the same look as before, not yet for expenses, but for the expense items. But now we have this reusable wrapper component. Now we can also use that in expenses now. Here, instead of using a div, we can also use our card component. We can import card from ./card and replace this div here with that card. Still setting an extra class name here as well, and also replace the closing tag. And if we do that, now we get the rounded corners back on that expenses container as well. Now, why would we do that? What did we gain by doing that? Well, in this case, of course, not a whole lot, but we were able to extract some code duplication from inside our CSS files into this separate wrapper component. And it's not just a duplicate CSS code. We also were able to extract this HTML code, this JSX code, this div here. In this case, it's just one div. But throughout the course, you will also see more complex wrapper components, which might have a more complex JSX structure. Things like modals and alerts. And in such cases, being able to extract that often allows you to save a lot of code duplication, and it often allows you to keep your other components clean. And this is another aspect of composition. We compose our expense item component by using card as a wrapper, by using some built-in HTML elements, and by then also putting in the expense state. And all these components and elements are composed together to form the overall expense item component, which then again is used in other components to in the end overall build the overall user interface. So composition is important. You use it all the time when working with React. Whenever you combine components, you are using composition. And an especially important part of composition is this props children feature, which allows you to also create wrapper components, which is a special type of component, you could say, which you also sometimes need. Now again, as with all these things, you are of course going to see many more examples throughout the course. Remember, this section was about components. It was about understanding the most important concept of React, that you build user interfaces by building and combining components. And for that, we had a look at the React core syntax and JSX. We of course had a very detailed look at building and using and working with components and props, and that already leads to the last part, data. We learned how to share data across components through that props concept. Now maybe you already noticed one important thing. With all these components which we are building, in the end we're just splitting up our code across multiple files and building blocks. So that if we want to have more than one expense item, we can just use our custom expense item component multiple times, instead of repeating all that code multiple times. That's the idea behind components. In the end, what ends up on the screen are just default HTML elements though. If you inspect your page with the developer tools, here in the Chrome developer tools with the Elements tab, you will notice that you don't see your custom components here. There is no card or expense item component, you just see divs and h2 elements and so on. And that is how the web works and how React works. These custom components are not really HTML elements which end up on the screen. You just use them in your code, in your React code, in your JSX code. What ends up on the screen are just the HTML elements, because ultimately every custom component you build either uses these built-in HTML elements, or it uses another component which at some point, if you drill into your components deeply enough, will end up using these built-in elements. And that's an important takeaway and something important to keep in mind. Now, the application we built thus far is great because we had the chance of learning about components and props with it. And these are two of the most important concepts you gotta know when working with React. I'm not sure if I mentioned it already. But of course, this application, as we built it thus far, also has a downside. In the end, it's still static. Yes, we have reusable components which can be configured with props, but ultimately we have this expenses array in the app.js file, and this array never changes. The data here is set in stone. It's still a static application in the end. Nothing is changing here. As a user, we have no chance of interacting with this application. And that's therefore what we're going to change in the next course section, when we're going to bring this to life and when we're going to learn about another concept called state. Now, before we go there though, I just got 3 other things which I want to cover here. The first thing, the first concept is JSX. I mentioned that we'll take a closer look at that, and we're going to do that in the next lecture. You could skip that lecture, but at some point you should have a look at it so that you understand what JSX really is under the hood and how it works. So I recommend that you don't skip it, even though you could do that if you're in a hurry. Now, the other 2 things I want to have a look at is how we organize our files and how we write our functions here. And therefore, let's dive into these concepts before we finish this module and move on to the next course section. Let's have a closer look at JSX. Now, I mentioned before, earlier in this module, You can open up your developer tools, and there you'll find the JavaScript code which is responsible for what you're seeing on the page. And in there, you will also find all your component functions, like this app function here. Now, it will look totally different in the end, because there you have no JSX code, because JSX code isn't supported by the browser. This in the end is just syntactic sugar, which works here thanks to the behind-the-scenes transformations. Now, we can see that the code to which it is transformed in the end looks like this here, right? This here is the code to which it is transformed. Now, this is code which still is fairly cryptic, because this actually is the final step of the transformation. We could also write code instead of this JSX code, which is a bit more readable to us humans than this, but not as readable as the JSX code. I still want to show it to you because this shows you what this JSX code actually represents behind the scenes. So here we go. Maybe you already wondered about one other thing. In package.js, we got a bunch of dependencies, and most of them are just dealing with the behind-the-scenes transformations. But we got two dependencies which are related to React. React and React DOM. Now, we are using React DOM in the index.js file, but we are never using React anywhere. We're never importing React anywhere. And this actually just works in this kind of project setup and in all modern React project setups which are created by Create React App. In a lot of other React projects which you'll find out there in the wild, you will actually see React imports, even though we don't have them here. Because in the past, in older React projects, you actually needed to import React from React in all your React component files. To be precise, in all files where you used JSX. You needed to always import React from React in the past. And you'll still see a lot of React projects out there which have these imports therefore. Now that we can omit this import now is really just some magic being done by modern React project setups. We needed this import in the past because this JSX code, as I mentioned, is just syntactic sugar. And under the hood, it is actually transformed to methods called on this React object, which is why we needed to import React in the past. Now let me show you what this code would look like if we wouldn't use this JSX syntax. And therefore I'll comment this out and return this alternative. Because on this imported React object, there is a create element method which we can call. And when you use JSX, it's in the end this method which is called. Create element takes 3 arguments. The first argument is the element which should be created. For example, a div. And if it's a built-in HTML element, you just pass in a string with the name of that element, like div. The second argument is an object that configures this element. Specifically, an object which sets all the attributes of this element. This div has no attributes, so here we can pass in an empty object. The third argument now is the content between the opening and closing div tags. And actually, it's not just a third argument. You can now have an infinitely long list of arguments, which are the different content pieces between the opening and closing tags. So here we have 2 elements, so we would have 2 extra arguments. The third argument would be our h2 element, so the first child in that div. And therefore here, again, we would call React create element and create a h2 element here. And that h2 element again has no attributes, so the second argument of this second create element call would be an empty object. And the third argument of this create element call would be the content in this h2 tag. So this string in this case. So we would pass this string here and escape this single quote. And if we now format it, it would look like this. Now, next to this second create element call, we could have a third create element call, which is the neighbor element to this h2 element, so this expenses component. Again, we create an element here, but now we're working with a custom component instead of a built-in one. In such cases, you don't use a string here, but you just point at your imported function, which it in the end is, because your components are just functions, right? So here we set expenses. We point at expensive as an element here. The second argument is an object of properties that should be set, of attributes that should be set. And here we have the items prop, the items attribute. So we would add an items key here. Keep in mind, this is just a JavaScript object. So we have the property name and then a colon and then the value, which here would be expenses. And then as a third argument, we have the content between the opening and closing tags. And in this case, there is no such content, so we omit it. And this here would be the alternative to this JSX code using this React object. And therefore, if I save that and we go back to the screen, we see exactly the same as before. Now, you could write your entire React app like this. It just turns out that this is a bit harder to read and a bit more cumbersome than using this JSX code. But that's why you needed to import React from React in all your component files in the past, because this is the under-the-hood code which kind of gets created automatically when you use JSX. Now, in more modern project setups, you can omit this React import because the project setup is able to make that transformation without the import being added. But if you see component functions where this import is there, it is there because in the past you always did need to add it. And therefore, because of that reason, I will now also import it and add it to all components where I use some JSX code. Like here, index.js, expenses.js, expense item.js, expense state.js, and card.js. Again, you technically don't need to do that, but I'm doing it to really emphasize that React is still being used under the hood here when you use JSX code, because that code under the hood is transformed to something like this before it's then transformed even more to what we saw in the browser earlier. That's important. And if you have a look at this code, it should also be clear why you need some wrapping element as a root JSX element, why you can't have just these two side-by-side elements being returned. Because how would you write this in the React create element world? You, in the end, would be trying to return this, and that doesn't work. You can't return more than one thing. You could return an array, sure, but this is not an array of elements. This is two separate elements side by side. That's why you always need such a wrapper, because in the create element world, you always create one element, which then may have more child elements. So that's why we have this one wrapper root JSX element, which we always need. This is why we need that. That's the under the hood, behind the scenes stuff that is going on. Now, I will comment this out and go back to the JSX solution, because of course we're going to write JSX code in the course. After all, this is way more convenient. But it is important to understand what is happening under the hood and how React works. So now in the last lecture, we learned about JSX and how it looks like under the hood, and why we therefore could add all these React imports to all these files which hold JSX code. Speaking of the files, let's talk about organizing them. Here, we only got a couple of components, and therefore we can store them like this. But as your project grows, and as you have more and more components, you might want to organize them into subfolders, and not just throw them all into one components folder. And indeed, that is something we can already get started with. Here we could argue that we have some general UI components, some general user interface elements which are not tied to a specific feature of the app. And then we get some feature-specific components, like these components which are dealing with rendering expenses and expense data. And therefore in the components subfolder, we could create an expenses subfolder and next to that, a UI subfolder for general user interface elements. And we could move the card files into the UI folder and the expenses, expense item, and expense date files into the expenses folder. Now you just want to make sure that you update all your imports. Like in expenses.js, where we import card, we now first of all need to go up one level with 2 dots and then a slash, and then dive into the UI folder and import card, the card file. We need to go up one level because expenses is now in the expenses folder. We need to get out of that folder into the next folder above it to then dive into the UI folder, which is a sibling folder to expenses, to the expenses folder, I mean. We don't need to update the other imports because these files are still in the same folder as expenses.js. For expense item, we also need to update the card import though. Go up one level, dive into the UI folder, and then import card. And in app.js, we no longer import expenses from components expenses. Instead, we dive into components, then into the expenses folder, and there it's the expenses file which we want to import from. So now we can adjust these imports, and if you did that, this again all works if you load it. And we're really just doing this to organize our files and to keep our components organized and to make sure that they're not all in one big folder. Ultimately, it's up to you how you want to organize them. And of course, you should just organize them such that you and any team members you might be working with are comfortable working with these files. That's the most important thing which matters. Now, to really conclude this module, I just want to show you an alternative syntax for writing these functions, any kinds of functions in JavaScript. A syntax which is not exclusive to React, by the way, but which can be used in any modern JavaScript application. Instead of writing a function like this with the function keyword, you can also write a so-called arrow function. And attached you find a link with more details on these arrow functions. Again, it's not a React specific thing. To use that arrow function syntax, you replace function with const to create a new constant with a given name, app in this case. And then the value which you assign to this constant is an arrow function written like this. A list of parameters, then an equal sign and a greater sign, forming such an arrow, and then the function body between curly braces. And again, that's really just standard JavaScript code. You can absolutely stick to the function keyword. This is just a syntax which I personally prefer because it's a bit shorter, or yeah, I just prefer it. And therefore I will migrate all my functions to this syntax, like this here in the case of card. But you don't have to do that if you prefer the other syntax. It's really 100% optional. And in this case here, it doesn't offer any benefits or anything like that. It's really just personal preference. And I want to show this syntax here, since you also see that in a lot of React projects, and you therefore should be aware of it, that you can write your functions like this. Any functions, by the way, not just component functions. And with that, we're really done for this module. It was a huge module, and yet we're still only scratching the surface. There's way more we can explore about React, and in the next section, you'll get a practice project, which will allow you to practice what you learned in this section, but thereafter, we'll dive way deeper into React, and we're going to explore more crucial React features, most importantly there, after this
exercise section, we'll explore the important concept of managing state in React apps and of building truly interactive user interfaces. So now that we got started with components and props and how we can build basic React applications, it's time to practice what we learned. And it's of course specifically time to practice working with those components because, as you learned, components are a crucial React concept and the core building block of all those user interfaces you're going to build with React. Therefore, in this course section here, we're going to build this demo application, this very basic website, which will utilize this component concept, or which code will utilize this component concept. And the idea behind this section here is that you can practice what you learned. For that, in this section, you're going to split an existing component, an existing React application, you could say, into smaller components, and you're therefore going to create and use multiple custom components. And you're also going to need to pass data to some of those components. So that's also something you're going to do in this course section. In the next lecture, I'll provide you with a starting project and your main tasks, and thereafter, you should try to complete those tasks on your own. So as mentioned, this is the project, the website we're going to build in this section. And when I say we're going to build it, I basically mean you're going to build it. Or at least you should try building it first. Because I got a couple of tasks for you that allow you to practice what you learned. Though, of course, throughout the rest of this section here, I'm going to build this website here together with you, and you can follow along with me to see how I'm tackling those tasks and how I'm building this project. But that being said, let's now take a look at this starting project I prepared for you and the tasks you should complete with this project. So here's the starting project, and you of course find it attached. You also find a link to Code Sandbox attached, which you can use alternatively if you don't want to install anything locally. But I'm of course going to use a local environment, as I always do in this course. And in this starting project I am providing to you, you'll find a source folder with a couple of JavaScript files and an assets folder with a nested images folder. Now, the only really relevant file for us is the app.js file. In that file here, you'll already find some code, and you'll also already find a React component in there. Now, this component and this overall app is not finished though. Instead, here in this component, I got a header where I output an image, and the image is actually imported like this from the assets folder. This is an import syntax you can use in React projects. It is supported by the underlying development server and build process. And this is how you can use images, which are stored in this assets images folder here, in your component files. You simply import them, assign any name of your choice to them, and then you use them as a dynamic source value. But that's already in this file, of course. What's not in this file, or what's at least not finished right now, is information about some of those React key concepts you should be aware of, though I will say that this is just a demo website, just an exercise, and this is not an exhaustive list of all key React concepts. Instead, you're going to learn about more React concepts throughout this course. But anyways, here we got an array full of objects, and down here the goal is to output the information that's contained in those objects in this array, but at the moment that's not happening. And that's where your tasks start. The first task is to output those key concepts, so that key concepts data. This data, which you find in this array, should be output here on the screen. And of course, with that, I don't mean that you should copy and paste the text. Instead, you should find a different way of outputting that data. But that's only the first task. The second task then is to identify possible components you could create, possible JSX code snippets you could outsource into a separate component. For that, you should analyze this JSX code in the app component and come up with possible components this code could be split up into. Now, of course, identifying possible components isn't everything, though. Instead, then, as a last task in this section here, you should then also create and use those custom components. So you should create new components, also use props if you need to use them. And of course, once you went through all these steps and once you have a working solution, definitely also take a look at the remaining lectures in this section, because there I will walk you through my solution, repeat some core component and React concepts you must know, and of course also let you know why I chose this solution and why I perform certain steps. Now, in case you're getting stuck whilst trying this on your own, also take a look at the next lecture, so the lecture after this one here, because that will be a hints lecture where I give you some hints on how to tackle this and where I therefore can hopefully help you come up with a solution. And with that, good luck, and I'll see you in my solution. So let's now solve these tasks. And for that, of course, we're going to start with the first task, where we output the key concepts data. Now, the data is already here in app.js in this concepts array. And now the goal is to output that data down there. And if you take a look at this unordered list here, where the concept data should be output, you can see that I already got one list item there. But at the moment, it only contains dummy content here, only dummy data. That now needs to be replaced with the actual data from these objects. And as I mentioned, the goal is now not to copy and paste that data, but instead to dynamically access the data in that concepts array. And in React, you can do that by using single curly braces, as you learned. Opening and closing single curly braces. Between those curly braces, you can put any JavaScript expression that yields a value. You could, for example, put 1 + 1 in here, but of course that's not the goal here. Instead, here for the image, I want to refer to this image, or precisely to the value stored under the image key in this first object in this array. So this value stored under this image key in the first object of this array. To output that image here, we can go to this source here, so between those curly braces, reference this concepts array by its name. And then, since it's an array and I want to access the first element in there, I can use square brackets 0, which does access the first element in that array. And that first element will be this object here. And in this object, I now want to get access to that value that's stored under the key image. So therefore, we can use the dot notation here and access image, like this. And this will output the image here. Now I also want to set the alt text dynamically, and I want to set this to the title of this concept. And therefore here, we again need curly braces to dynamically output some content here. And then we use concepts again, square bracket 0, because we're still working on the same concepts object. And then dot title gives us access to the title. And that's actually also exactly the code I need down here to output the title as text. So between those h2 tags. And then here for the paragraph where I want to output the description, I want to access concepts 0 description. With that, we should be outputting data about the first key concept in that concepts array. Now to see this in action, here on my local machine, I need to start this development server, which in Visual Studio Code can be done by opening a new terminal and running npm start, though for this to succeed, I first must run npm install to install all those extra dependencies, including that build process that's used behind the scenes. And you only need to do this once, as you learned when you initially set up a project. And thereafter we can run npm start, and this will now start that development server. And then once I visit localhost 3000, I can indeed see this key concept here on the screen. It's quite big for me here because I zoomed in quite a bit so that you can see it really well as well. And I got a light hover effect here, but clicking doesn't actually do anything here. It's just a visual effect. But this is now the first key concept being output here. It's not the only key concept we got though. Instead, if we take a look here at this concepts array, we of course got 2 more objects in there. And the goal of course is to also output those concepts. And therefore, what we can do for now, and what will change later, is that we copy and paste this list item and now access concepts1 image, concepts1 title, also here, and also concepts1 description. And this will access the second element in this concepts array and then access image, title, and description for that second element. And of course we can then also repeat this one last time here for the third element, where we therefore access concepts2 image, concepts2 title, also here, and concepts2 description. And with that we'll be outputting all 3 concepts for the moment simply by copy and pasting this code, but that of course will change soon. If you saved that though, and you got that development server up and running, you will now see these 3 key concepts on the screen. And that theoretically is of course already the final solution. It's the final website we want to build here. But it's not the final solution for those tasks I gave you. It's only the solution for the first task. Because whilst we got a working solution, we don't have the best possible working solution. Instead, the next task is to identify possible components before we then also build and use those components. So let's now take a look at our code and identify possible components into which we could split up the current code. For that, if you take a look at the current code, the current JSX code to be precise, I got at least 2 components into which this could be split up. And that would be the header component, that could be a separate component, and then one reusable component for those key concepts. So this list item could go into its own reusable component. We could also build a third component, this concepts component, but that is optional. You could definitely do it though, I will say that. Now before we go ahead and build those components, I want to briefly explain why we could split the app into those components I just mentioned. And for that, I first of all want to say that of course for a very simple website like this one here, leaving the code like this wouldn't be wrong, wouldn't be horrible. But of course this is just a basic demo app since we're just getting started with React. And of course we want to practice those key React concepts you already learned about, like components for example. And there actually also is a good reason for splitting this up into components. At least a separate component for these concepts makes a lot of sense, because right now, if I ever decide that I want to get rid of this description paragraph, for example, I have to delete this paragraph manually in 3 different places to get rid of it. And whilst this is of course certainly doable, it's unnecessary repetition. And that's something we can typically avoid by using and embracing React components. So therefore, let's now also dive into that last task here, and let's create and use some reusable custom components. Now for that, in that app here, I will start with the header. The header will actually not be reused, but still, putting it into its own component is definitely something we can do here. For that, in that src folder, I'll create a new subfolder named components, which is not a must-do as you learned, but a common convention. And in there, I'll add another subfolder called header. Because in that header file, I'll then add a header.js file, which should contain the component code. Now, as you learned, and as you can also see in app.js, a component in React is just a function. A standard JavaScript function, which does return JSX code though, and which typically is also named like this, starting with an uppercase character. Therefore, in header.js, we can create a new function, and we can name it header, which is a name that makes sense for a component that contains the header code. Then I also want to export this as a default so that we can use this component outside of this file. And then we can go to app.js and cut this header code here, move it to header.js and return it there. Like this. And if I press the auto formatting shortcut here on my system in Visual Studio Code, this automatically gets formatted like this. Now, of course, I'm using an image here, and therefore, since I cut this header code from the app component file and moved it to header.js, I also need to move this import. So we can also cut this there and move that to header.js, like this. So now we got that import moved over. We got the app.js file cleaned up, therefore. But of course, now the header component that we're defining in header.js should be used in app.js. And to use it there, we want to add a new import where we import header, though this name here is up to you since it's a default we're importing. But you should start with an uppercase character because, as you learned, those uppercase characters are needed on your own components to differentiate them from built-in components. And we import the header component from /components. So diving into that components folder, then there into the header folder, and then there header. And here in this React project, as you learned, you can and should omit the file extension for those JavaScript files. With that, the header component is being imported, and we can now use it here as a self-closing component like this in the JSX code returned by the app component. It doesn't take any props because it really doesn't need any props. We could make it configurable, but since we're not reusing it, we're not using it anywhere else, there really is no reason to do that, and therefore I'm not accepting any props, I'm not passing any props, and if I save this, it should work, but I am getting an error. I am getting an error that the image can't be found in the end. And this makes sense because since I moved this image import, I also need to check whether the path still is correct, and that's not the case here. Because the header component file is actually nested in the components and then there in the header folder. So therefore, this import path should be adjusted, and I should first go up one level so that I'm in the components folder, and then another level with .. so that I'm in the source folder, and then we can dive into the assets folder, and then there the images folder, and then select this image. So with this, the error now went away, and if I reload this, the header is still there as it was before, but now it was outsourced into a separate component. Next, let's work on these concept components here. So let's now outsource these concept items here into a separate component. And for that, of course, I want to outsource this list item code here in the end into a separate component. For that, in the components folder, we can add another subfolder called concept, though of course this name, as always, is up to you. And then in there, create a concept.js file where I also have my concept function for this concept component, which of course must be exported to make it available outside of this file. And then here, I want to return this list item JSX code. So I can cut it from here, from app.js, and move it here into concept.js. Now, one very important note here. In theory, we could now create 3 different concept components, one for every core concept that we're outputting here. But if we would do that, we would still be duplicating and replicating code. And if we ever wanted to delete the paragraph, we still would have to do that in 3 different components. That's why I'm not building 3 different components here, but instead one reusable component, which must be configurable though. It must be configurable so that one and the same component can output different data. Data that's always output in the same way, so that always has the same shape in the end, but the different data pieces, the image, the title, the description, the values stored under those keys, that will differ. And that's the idea here with this function component. So therefore it must be configurable in order to be reusable. And how do we make it configurable? With help of props. So here we can and should accept this props argument, this props parameter, which will be created and managed automatically by React, and which will be passed into this component function by React. And then with that, here we can, for example, output props.image. And here, props.title. And here it's also props.title, and the same is true here for description. It's props.description. And with that, we made this component configurable, and it does now accept an image, a title, and a description key, which can and should be set when that component is being used in JSX code. Therefore, now back in app.js, we can use this concept component here, and for it to be usable here, we also must import it. So here we should import concept from /components concept concept. And with that import here added, we can go down, use the concept component like this as a self-closing component here, because I'm not passing anything between its opening and closing tabs. And then here we can set the image prop like this, because in concept I'm extracting an image prop. So I'm looking for this key, hence we should provide it here on this component. And set this to concepts 0 image. So we're still accessing that concepts data from this array, but we're now passing it to our own custom component. And of course, we're now going to do the same for the title. Here we should access concepts 0.title. And last but not least, we also want to do that for the description, of course, and pass concepts 0.description as a value for the description prop. With that, if I formatted this, the code looks like this. And now we can easily replace those list items here with our own custom component and pass the correct data to the props. So here for concepts 1 on that second item, and on the third item for concepts 2, so for the third concepts item. And with that, we now got this reusable component, and we are reusing it, and we are configuring it with help of props. And the HTML structure is now only defined once inside of this component, but it can now easily be reused thanks to our custom component. And I make sure that here I'm accessing concepts 2, not concepts 3, which would be wrong. And I save this again. I now got the same website as before with those key concepts items, but now we're building it with help of custom components, custom reusable components, and therefore all 3 tasks that I gave you at the beginning of the section are now solved. So now that we got started with components and props and how we can build basic React applications, it's time to practice what we learned. And it's of course specifically time to practice working with those components, because as you learned, Components are a crucial React concept and the core building block of all those user interfaces you're going to build with React. Therefore, in this course section here, we're going to build this demo application, this very basic website, which will utilize this component concept, or which code will utilize this component concept. And the idea behind this section here is that you can practice what you learned. For that, in this section, you're going to split an existing component, an existing React application, you could say, into smaller components, and you're therefore going to create and use multiple custom components. And you're also going to need to pass data to some of those components. So that's also something you're going to do in this course section. In the next lecture, I'll provide you with a starting project and your main tasks, and thereafter, you should try to complete those tasks on your own. So as mentioned, this is the project, the website we're going to build in this section. And when I say we're going to build it, I basically mean you're going to build it. Or at least you should try building it first. Because I got a couple of tasks for you that allow you to practice what you learned. Though, of course, throughout the rest of this section here, I'm going to build this website here together with you, and you can follow along with me to see how I'm tackling those tasks and how I'm building this project. But that being said, let's now take a look at this starting project I prepared for you and the tasks you should complete with this project. So here's the starting project, and you of course find it attached. You also find a link to Code Sandbox attached, which you can use alternatively if you don't want to install anything locally. But I'm of course going to use a local environment, as I always do in this course. And in this starting project I'm providing to you, you'll find a source folder with a couple of JavaScript files and an assets folder with a nested images folder. Now, the only really relevant file for us is the app.js file. In that file here, you'll already find some code, and you'll also already find a React component in there. Now, this component and this overall app is not finished though. Instead, here in this component, I got a header where I output an image, and the image is actually imported like this from the assets folder. This is an import syntax you can use in React projects. It is supported by the underlying development server and build process. And this is how you can use images, which are stored in this assets images folder here, in your component files. You simply import them, assign any name of your choice to them, and then you use them as a dynamic source value. But that's already in this file, of course. What's not in this file, or what's at least not finished right now, is information about some of those React key concepts you should be aware of, though I will say that this is just a demo website, just an exercise, and this is not an exhaustive list of all key React concepts. Instead, you're going to learn about more React concepts throughout this course. But anyways, here we got an array full of objects, and down here the goal is to output the information that's contained in those objects in this array, but at the moment that's not happening. And that's where your tasks start. The first task is to output those key concepts, so that key concepts data. This data, which you find in this array, should be output here on the screen. And of course, with that, I don't mean that you should copy and paste the text. Instead, you should find a different way of outputting that data. But that's only the first task. The second task then is to identify possible components you could create, possible JSX code snippets you could outsource into a separate component. For that, you should analyze this JSX code in the app component and come up with possible components this code could be split up into. Now, of course, identifying possible components isn't everything, though. Instead, then, as a last task in this section here, you should then also create and use those custom components. So you should create new components, also use props if you need to use them. And of course, once you went through all these steps and once you have a working solution, definitely also take a look at the remaining lectures in this section, because there I will walk you through my solution, repeat some core component and React concepts you must know, and of course also let you know why I chose this solution and why I perform certain steps. Now, in case you're getting stuck whilst trying this on your own, also take a look at the next lecture, so the lecture after this one here, because that will be a hints lecture where I give you some hints on how to tackle this and where I therefore can hopefully help you come up with a solution. And with that, good luck, and I'll see you in my solution. So let's now solve these tasks. And for that, of course, we're going to start with the first task, where we output the key concepts data. Now, the data is already here in app.js in this concepts array. And now the goal is to output that data down there. And if you take a look at this unordered list here, where the concept data should be output, you can see that I already got one list item there. But at the moment, it only contains dummy content here, only dummy data. That now needs to be replaced with the actual data from these objects. And as I mentioned, the goal is now not to copy and paste that data, but instead to dynamically access the data in that concepts array. And in React, you can do that by using single curly braces, as you learned. Opening and closing single curly braces. Between those curly braces, you can put any JavaScript expression that yields a value. You could, for example, put 1 + 1 in here, but of course that's not the goal here. Instead, here for the image, I want to refer to this image, or precisely to the value stored under the image key in this first object in this array. So this value stored under this image key in the first object of this array. To output that image here, we can go to this source here, so between those curly braces, reference this concepts array by its name. And then, since it's an array and I want to access the first element in there, I can use square brackets 0, which does access the first element in that array. And that first element will be this object here. And in this object, I now want to get access to that value that's stored under the key image. So therefore, we can use the dot notation here and access image, like this. And this will output the image here. Now I also want to set the alt text dynamically, and I want to set this to the title of this concept. And therefore here, we again need curly braces to dynamically output some content here. And then we use concepts again, square bracket 0, because we're still working on the same concepts object. And then dot title gives us access to the title. And that's actually also exactly the code I need down here to output the title as text. So between those h2 tags. And then here for the paragraph where I want to output the description, I want to access concepts 0 description. With that, we should be outputting data about the first key concept in that concepts array. Now to see this in action, here on my local machine, I need to start this development server, which in Visual Studio Code can be done by opening a new terminal and running npm start, though for this to succeed, I first must run npm install to install all those extra dependencies, including that build process that's used behind the scenes. And you only need to do this once, as you learned when you initially set up a project. And thereafter we can run npm start, and this will now start that development server. And then once I visit localhost 3000, I can indeed see this key concept here on the screen. It's quite big for me here because I zoomed in quite a bit, so that you can see it really well as well. And I got a light hover effect here, but clicking doesn't actually do anything here. It's just a visual effect. But this is now the first key concept being output here. It's not the only key concept we got though. Instead, if we take a look here at this concepts array, we of course got 2 more objects in there. And the goal of course is to also output those concepts. And therefore, what we can do for now, and what will change later, is that we copy and paste this list item and now access concepts1 image, concepts1 title, also here, and also concepts1 description. And this will access the second element in this concepts array and then access image, title, and description for that second element. And of course, we can then also repeat this one last time here for the third element, where we therefore access concepts2 image, concepts2 title, also here, and concepts2 description. And with that, we'll be outputting all 3 concepts for the moment, simply by copy and pasting this code, but that of course will change soon. If you saved that though, and you got that development server up and running, you will now see these 3 key concepts on the screen. And that, theoretically, is of course already the final solution. It's the final website we want to build here. But it's not the final solution for those tasks I gave you. It's only the solution for the first task. Because whilst we got a working solution, we don't have the best possible working solution. Instead, the next task is to identify possible components before we then also build and use those components. So let's now take a look at our code and identify possible components into which we could split up the current code. For that, if you take a look at the current code, the current JSX code to be precise, I got at least 2 components into which this could be split up. And that would be the header component, that could be a separate component, and then one reusable component for those key concepts. So this list item could go into its own reusable component. We could also build a third component, this concepts component, but that is optional. You could definitely do it though, I will say that. Now before we go ahead and build those components, I want to briefly explain why we could split the app into those components I just mentioned. And for that, I first of all want to say that of course for a very simple website like this one here, leaving the code like this wouldn't be wrong, wouldn't be horrible. But of course, this is just a basic demo app since we're just getting started with React. And of course, we want to practice those key React concepts you already learned about, like components, for example. And there actually also is a good reason for splitting this up into components. At least a separate component for these concepts makes a lot of sense, because right now, if I ever decide that I want to get rid of this description paragraph, for example, I have to delete this paragraph manually in 3 different places to get rid of it. And whilst this is of course certainly doable, it's unnecessary repetition. And that's something we can typically avoid by using and embracing React components. So therefore, let's now also dive into that last task here, and let's create and use some reusable custom components. Now for that, in that app here, I will start with the header. The header will actually not be reused, but still, putting it into its own component is definitely something we can do here. For that, in that src folder, I'll create a new subfolder named components, which is not a must-do as you learned, but a common convention. And in there, I'll add another subfolder called header. Because in that header file, I'll then add a header.js file, which should contain the component code. Now, as you learned, and as you can also see in app.js, a component in React is just a function. a standard JavaScript function which does return JSX code though, and which typically is also named like this, starting with an uppercase character. Therefore, in header.js, we can create a new function and we can name it header, which is a name that makes sense for a component that contains the header code. Then I also want to export this as a default so that we can use this component outside of this file. And then we can go to app.js and cut this header code here, move it to header.js and return it there. Like this. And if I press the auto formatting shortcut here on my system in Visual Studio Code, this automatically gets formatted like this. Now, of course, I'm using an image here, and therefore, since I cut this header code from the app component file and moved it to header.js, I also need to move this import. So we can also cut this there and move that to header.js, like this. So now we got that import moved over. We got the app.js file cleaned up, therefore. But of course, now the header component that we're defining in header.js should be used in app.js. And to use it there, we want to add a new import where we import header, though this name here is up to you since it's a default we're importing. But you should start with an uppercase character because, as you learned, those uppercase characters are needed on your own components to differentiate them from built-in components. And we import the header component from /components, so diving into that components folder, then there into the header folder, and then there header. And here in this React project, as you learned, you can and should omit the file extension for those JavaScript files. With that, the header component is being imported, and we can now use it here as a self-closing component like this in the JSX code returned by the app component. It doesn't take any props because it really doesn't need any props. We could make it configurable, but since we're not reusing it, we're not using it anywhere else, there really is no reason to do that, and therefore I'm not accepting any props, I'm not passing any props, and if I save this, it should work, but I am getting an error. I am getting an error that the image can't be found in the end. And this makes sense because since I moved this image import, I also need to check whether the path still is correct, and that's not the case here, because the header component file is actually nested in the components and then there in the header folder. So therefore, this import path should be adjusted, and I should first go up one level so that I'm in the components folder, and then another level with .. so that I'm in the source folder, and then we can dive into the assets folder, and then there the images folder, and then select this image. So with this, the error now went away, and if I reload this, the header is still there as it was before, but now it was outsourced into a separate component. Next, let's work on these concept components here. So let's now outsource these concept items here into a separate component. And for that, of course, I want to outsource this list item code here in the end into a separate component. For that, in the components folder, we can add another subfolder called concept, though of course this name, as always, is up to you. And then in there, create a concept.js file where I also have my concept function for this concept component, which of course must be exported to make it available outside of this file. And then here, I want to return this list item JSX code. So I can cut it from here, from app.js, and move it here into concept.js. Now, one very important note here. In theory, we could now create 3 different concept components, one for every core concept that we're outputting here. But if we would do that, we would still be duplicating and replicating code. And if we ever wanted to delete the paragraph, we still would have to do that in 3 different components. That's why I'm not building 3 different components here, but instead one reusable component, which must be configurable though. It must be configurable so that one and the same component can output different data. Data that's always output in the same way, so that always has the same shape in the end, but the different data pieces, the image, the title, the description, the values stored under those keys, that will differ. And that's the idea here with this function component. So therefore it must be configurable in order to be reusable. And how do we make it configurable? With help of props. So here we can and should accept this props argument, this props parameter, which will be created and managed automatically by React, and which will be passed into this component function by React. And then with that, here we can, for example, output props.image. And here, props.title. And here it's also props.title, and the same is true here for description. It's props.description. And with that, we made this component configurable, and it does now accept an image, a title, and a description key, which can and should be set when that component is being used in JSX code. Therefore, now back in app.js, we can use this concept component here, and for it to be usable here, we also must import it. So here we should import concept from /components concept. And with that import here added, we can go down, use the concept component like this as a self-closing component here, because I'm not passing anything between its opening and closing tabs. And then here we can set the image prop like this, because in concept I'm extracting an image prop. So I'm looking for this key, hence we should provide it here on this component, and set this to concepts 0 image. So we're still accessing that concepts data from this array, but we're now passing it to our own custom component. And of course, we're now going to do the same for the title. Here we should access concepts 0.title. And last but not least, we also want to do that for the description, of course, and pass concepts 0.description as a value for the description prop. With that, if I formatted this, the code looks like this. And now we can easily replace those list items here with our own custom component and pass the correct data to the props. So here for concepts 1 on that second item, and on the third item for concepts 2, so for the third concepts item. And with that, we now got this reusable component, and we are reusing it, and we are configuring it with help of props. And the HTML structure is now only defined once inside of this component, but it can now easily be reused thanks to our custom component. And I make sure that here I'm accessing concepts 2, not concepts 3, which would be wrong. And I save this again. I now got the same website as before with those key concepts items, but now we're building it with help of custom components, custom reusable components, and therefore all 3 tasks that I gave you at the beginning of this section are now solved. By now, we know how to build components and work with multiple components, and we know how to work with state and how to handle user events. In this course section, we're now going to dive into rendering lists and rendering conditional content. So we'll have a look at how we can output arrays of data on our page and how we can show different content based on different conditions. And that's exactly what we're going to dive into in this module. We're going to continue working on the application we already started over the last course sections, but in this module, we're now going to finish it by adding these features.
So here's our project, and we already got a list of data there, but of course this list is static. It's not dynamic at all at the moment. So for example, if we filter here, this does not affect the list at all. And also if we would add a new item here, you would also see that as we pick this and add this, it's not added to the list because we haven't added the logic for this yet. So therefore, that's what we're going to do. And therefore, here in this application, we now want to continue working on that. In the expenses.js file, we currently render our list of expenses by individually adding these expense item elements here in our JSX code. And that's of course not dynamic at all. In most web applications, we don't know in advance how many items we want to render. I mean, here, for example, we don't know how many expenses the user is going to add and how many expenses should be displayed when a certain year is selected. So therefore, hard coding the number of expense items as we're currently doing it is definitely not the way to go. Instead, we want to render that list dynamically. And doing that is a standard case, which you'll face in a lot of projects and applications, and it's therefore also straightforward to do with React. So here is how it does work. We want to render our expenses, which are defined in app.js. Here we got this expenses array. And we want to render this in the expenses component. Therefore, the first step is to pass our expenses down via props, which we're already doing. We are passing the items prop, which points at this expenses array. So in the expenses component, we do get our list of expenses, but we're currently not using that. And that's what we want to change. On our props, we got this items prop, and the value of that will be that array, which we in the end want to render here. But we don't want to output the array as text or anything like that. Instead, we want to render one expense item per element in the array. And that's straightforward to do. For this, we first of all need single curly braces opening and closing because we want to execute a dynamic expression in our JSX code. And you learned that that's done with curly braces. Then we can execute JavaScript expressions here. Now the expression which I do want to execute here is that I reach out to my array of data, in this case the array of expenses, and that then for every element we want to create such a JSX element. For this we can access props items, that's our array of items, our array of expenses, and now we can use a built-in array method, which is built into standard JavaScript, and that's the map method. You can learn more about this method if you Google for JS array map. And what this method does is that it creates a new array based on another array, and it basically transforms every element in that original array. So here in this example, you for example see that we have an array of numbers, and with map, we multiply every number with 2 so that we get this new array as a result. And for applying this transformation, map, this method which we can call, takes a function which we pass as an argument, and that function is then executed for every item in the array on which we're calling map. And the result of this function is the element which will be added to the newly created array. That's how this works. And that's a built-in method, as I said, and we can utilize it here to transform our array of objects, which we have here, we got a bunch of objects in there, into an array of JSX elements. To be precise, into an array full of expense item JSX elements. Because if you do output an array of JSX elements here, like a couple of cards, then React is capable of simply rendering these elements. So if you had something like this, an array of JSX elements as part of your JSX code, React would simply render these elements side by side. And that's what we utilize here to transform our array of objects into such an array of expense items, which then are rendered by React. So map, as I just showed you, takes a function as an argument, and that function executes for every element in the array, and it gets that element for which it's currently executing as a parameter. So here we get our expense, for example, and then in the function body, so on the right side of this arrow, if we're using an arrow function, we then have to return the JSX element into which we want to map this expense. So in this case, I want to map every expense in my expenses array. I want to map every expense into an expense item JSX element. So I want to transform the expense object to this special kind of object, to this JSX element. And then we can just configure this as we did it here. We add a title prop, but the title is now expense.title. So this expense, which is passed as a parameter into this function, automatically, because that's how map works, that expense is used to extract the title. And we do the same for the amount with expense amount. And of course, we do the same for the date by setting the date prop to expense date. Let me reformat this. And this is now how that looks like. Now we can get rid of the hard-coded expense items here, and we're only left with this map expression here, where we transform our array to an array full of JSX items. Hence, if I now save this and I reload, we get a warning, which we can ignore for now, but we also see that we got all these items being rendered. Just as before, but now it's actually happening dynamically, which simply means that now it's based on the actual array. And that, of course, means that we can now also change that array, and such changes will be reflected in that list. And that's what we're going to do next, therefore. Of course, feel free to try it on your own first. We're going to do it together in the next lecture. So how could we now update this expenses array whenever a new expense is being added? Well, for this, we need to go to app.js because that is where we have this expenses array. There, we also have this addExpenseHandler function, which we added in the last course section, which is triggered whenever a new expense is added. And we even receive the expense as a parameter here. So all we gotta do is we have to add this expense to this expenses array. But of course, if we just add it like this, nothing would happen because you already learned that just because you change some variable, React won't update the component. Instead, to achieve that, you need to use state. And therefore here in app.js, where we manage our expenses, we now want to import use state from React so that we can register some state here. And I will actually grab this array here, this constant, and extract it out of this component function and instead store it here and name it initial expenses or dummy expenses, since that's what it is, so that this actually is just some dummy data which we can use to initialize our state with. But then inside of the app component function, we call useState, and I'll pass my dummy expenses, so this array full of dummy data, as an initial state value, so that we have some initial expenses to display. But then here we can again use destructuring, as I showed it to you in the last section, to get access to our expenses and to the setExpenses state updating function. And now that we got this here in the addExpenseHandler, where we want to add a new expense, we can call setExpenses to set our expenses array to a new array which includes this new expense. So how should we update this? Well, we could pass a new array here, and then let's say we want to add the new expense as the first item in the array. For that, we could add the expense which we're getting here as an item to this array, and then use the spread operator on the existing expenses to pull out all the existing array elements and populate the rest of this new array with those existing elements. We can use the spread operator not just on objects, but also on arrays. And again, that's not a React feature, that's a standard JavaScript feature. However, if we would update the state like this, it would not really be correct, as you learned in the last course section. Instead, if you update your state depending on the previous state or the previous snapshot of this state, you should use this special function form for this state updating function, so that we pass a function as an argument to this state updating function, and that function will automatically receive the latest state snapshot. So here we would then get our previous expenses automatically by React, and we would return our new array where we add this expense, which we're getting as a parameter here, and where we then add our previous expenses with that spread operator. And that's the clean way of updating our state when it's based on an older snapshot of that same state. Now with that, we add our new expense. And now, since we're using our expenses state here to pass it to expenses, we should automatically have a dynamic list which automatically updates when items are added. So if we now add a book for 29.99 and pick some date here, we see that being added here as a first item. So this is working, and now this is a truly dynamic list by using state and by outputting these items with this map method. And that's how you output lists of data dynamically with React. Now let's have a look at this key warning and what that is all about. So why are we getting this key warning? After all, it looks like everything works. Well, React has a special concept when it comes to rendering lists of data, a concept which exists to ensure that React is able to update and render such lists efficiently without performance losses or bugs which may occur. And I want to show you which problem we have with the current implementation. If you have a look at your developer tools and you go to the Elements tab there, you can inspect your list here, which is this list of divs. We could change this to a list with list items, but for the moment I'll stick to these divs here. And if we now have a look at this list here, then you should watch the part here on the right in the developer tools as I add a new item. A book 2, for example, for $39.99. If I add that, watch these divs on the right. Did you see what happened? This last item flashed. And if an item flashes here, it means that it was edited or added by the browser. Now it's strange that the last item flashed because actually the new item was added as the first item, the topmost item in this list. To understand what's going on, let me expand this first item, a book 2 which I just added, and let me add a third item here. Like this. Let's add this and click Add Expense. And you see, this also flashed. If not, rewind and go back a couple of seconds, and you'll see that this H2 tag of the first item also flashed when I added this new item. So what actually happens here when I add a new item is that React renders this new item as the last item in this list of divs and updates all items and replaces their content such that it again matches the order of the items in my array. And this is not great. This is happening because to React, all these items look similar, and it only sees that my array changed, that it's now longer than before, and hence it simply renders an additional div and it adds that at the end. And then it simply walks through all the items and updates the content inside of every item to match the array content again. The final result, therefore, is correct here, but from a performance perspective, this is not great because all items are visited and updated, and it can even lead to bugs. If the expense items would be stateful items, and we would have some state managed inside of that, then if, for example, our first item, if it has a certain state, if we add a new item, the old first item would be overwritten with the new first item. Hence, any state changes we might have had in there would be lost. So besides potential performance issues, we could also run into bugs. So that is a problem. And the question therefore is, why does React behave like this? The answer is because it has no other way. It currently simply checks the length of the array and then has a look at the number of items that were already rendered. The individual items all look similar to React though, so it can't know where a new item should be added or anything like that. That's why we get this warning, because we have a way of telling React where a new item should be added. And we do that by going to the place where we output our list of items, so this map method here, and we then add a special prop to this item here. And that's the key prop. This is not a prop we are using inside of expense item, but instead it's a prop you can add to any component, no matter if it's a custom component by you or if it's a built-in HTML element. You can always add this. And if you do add it, if you add the key to your component or HTML element, then you can help React identify the individual items. For that, you need to set a unique value per list item. And that, for example, in this case here, would be the expense ID. Because in our expenses array, every item has a unique ID. And if you wonder what you do if you have no unique ID, then you could use the second argument, which you get here for the function you pass to map, which is an automatically managed index. Though it's discouraged to use that, since with that you can still run into bugs because the index for a given item is always the same and not directly attached to the content of the item. For the ID that's different, every item with a certain content has a clear unique ID. And in reality, it turns out that in most scenarios, you do have some unique ID, because typically you are rendering some data which comes from a database or anything like that, and there you work with unique IDs anyways. So finding some unique identifier is no problem. And you can use any primitive value as a unique identifier. Any number or string, that can be unique identifiers. So here I add this key pointing at expense ID, and once we do that, if we reload, we no longer get that warning. And if I now inspect my list here again, and I inspect the title of the currently first item, if I now add a new item again, like this book, you will see that this h2 tag did now not flash. Instead, this div flashed, and this div was also now added at the beginning of the list correctly, this div here, I mean, as it should be. Because now React is able to uniquely identify all these items, and it's therefore aware not just how long the array is, but also where which item should be placed, and it's able to update this list in a more efficient way. So long story short, you should always add such a key when mapping out lists of items. And I hope I could explain why that matters. You don't need to know why, it's enough if you add it, but I think it's always important that you also do understand what's going on behind the scenes and why you're doing something. So our filter is now working, but we can actually select values where we have no data. And we might want to show an appropriate message in such cases. And that leads us to the second part of this module, conditional content, which is also important. Conditional content is about rendering different output under different conditions. So I'm not talking about lists, but about rendering either A or B or C, whatever you need. And that's something I want to do here. In expenses.js, we render our list of expense items. But if our filtered expenses array turns out to be empty, we render nothing. Now, we might wanna instead render a message telling the user that we have no items for the chosen filter. And for that, we wanna render content conditionally. How can we do that? Well, we can again add a dynamic expression here in our JSX code and simply use a condition here. I'm not talking about an if condition because long statements like this, the same is true for loops, are actually not allowed here between these curly braces, but we can use a ternary expression here. And we could check if our filtered expenses length is equal to 0, which means we have no items in that filtered expenses array. And if that's the case, after a question mark, which is the default JavaScript ternary expression syntax, we render a simple message in a paragraph where we say, no expenses found. Otherwise, after the colon, we render our list. So we grab this here, cut it, and remove this empty pair of curly braces now. And we render this mapping expression in the else case. And again, that's the default JavaScript ternary expression syntax. Condition, question mark, then what we want to do if the condition is met, colon, for the else case, what we want to do if it's not met. And if we save this, you see, I got no expenses found here for 2022, but for 2020, I do have my expense. Now, of course, that's a bit hard to read. We can fine-tune this in a second, but that's how we can render content conditionally. Of course, long ternary expressions like this can be a bit hard to read though. So we can also fine-tune this or restructure this and reuse this condition, but then abuse a little trick in JavaScript. We can add the AND operator and then use the content, the JSX content we want to render if this condition is met. JavaScript works such that if you use the AND operator, it basically will return the part after the AND operator as a result of this overall check here if the first condition is met. So if this first condition is met, it moves on to the part after the AND operator and it then returns that value. And that's what we're abusing here. And abusing sounds like a bad thing. This is actually something which is fine to use. You'll see it in a lot of React projects, and it simply allows you to write shorter expressions. Because now we can do the same here for our alternative. There we want to check if we got more than 0 items, and then we use and to output our list here. So now I basically split that long ternary expression into 2 standalone expressions which check different conditions. Using this AND trick here, where the part after AND is rendered if the part before AND returns true. And with that we got the same behavior as before, as you can tell. But even that might be too much logic in the JSX code, so we also got a totally alternative way of handling this. We can add a variable, maybe name it expenses content, but the name is up to you. And we assign a default value here. And the default value could be our message that no content was found. And we can store JSX content like this in variables. We can return it, and we can also use it anywhere else where we work with values. So we can store JSX content in variables, as I'm doing it here. This is absolutely fine. You are not limited to using JSX only if you return. You can also use it to create a value which is stored in a variable. Now, why am I doing that though? Because now we can add an if check here before we return, and we can check if filtered expenses length is greater than 0. So if we do have filtered expenses. And if that's the case, I want to overwrite expenses content. So I will change the value of this variable. And I will set this then to the result of this map call here, like this. So this list of expense items. That's my value stored in expenses content if we got a length greater than 0. And then down there in our returned JSX code, we can get rid of all that logic, and we just add a simple dynamic expression where we point at expenses content, so at this variable. And this variable holds either this JSX code or this array of JSX elements. Both is renderable, and therefore both can be used here. And now we get a lean JSX snippet which we return, and we got our logic in the component function itself. And we could argue that this is more readable. And again, if we save that, it works just as before. And it's up to you which approach you prefer. It also depends on the length of the conditions and the content which is rendered under different cases. But ultimately, this is probably the cleanest way. But again, it is up to you what you prefer. I want to show you all options so that you can go with the way which you personally like the most. I will go with this approach because I'm a fan of having a lean JSX snippet here. Now, with the conditional content covered here, before we continue, I want to restructure the expenses component a little bit. And I actually want to extract that list logic into a new component to again make that expenses component a little bit leaner. Therefore, I'll add a expenses list.js file and also a expenses list.css file, which you also find attached. And you can already download my CSS file and copy the styles into your expenses list CSS file. In the expenses list.js file, I will then add a constant expenses list, which receives props and returns something. And of course, we export this expenses list. And we can, if we want to, also import React from React, but again, that is optional. Now here in expenses list, I want to output my expenses list. I will not filter in there. I will keep the filtering logic in expenses, since that's also where I manage the filtered year. But I will take this fallback content, this if check, I will take all of that and move that into my expenses list component. That means that we also, of course, want to import the expense item from /expense item here, since I'm using that component here. And the filtered expenses no longer exist here. I just want to get, let's say, my items here, or expenses. It's up to you. I'll name it items as props, like this. Now in expenses.js, that of course means that here I now want to output my expenses list down there. And of course, we therefore also want to import expenses list from the expenses list file. And we can get rid of the expense item import. And the filtered expenses should now be passed to expenses list through the items prop, which I'm using inside of expenses list, like this. Now, inside of the expenses list.js file, I also want to make a couple of changes now. Of course, we need to return some JSX, but I want to return an unordered list here and actually give that list a class name of expenses-list. This is a class defined here in my CSS file, and therefore we also want to import this expenses list CSS file into the expenses list.js file. And inside of this unordered list, I now want to output my map here, my expense item array. So I will again grab that and render this dynamically here like this. And I will handle this if case a little bit differently now. I will add a if check, but I'll check if props items length is equal to 0. So if we have no items, and if that's the case, I will simply return a totally different JSX snippet. Because that's yet another way of handling conditional content. If what your component returns changes entirely based on different conditions, you can use this approach. It would have not been appropriate here in expenses.js before because only a part of the JSX snippet which we returned changed. So there, the approach I showed in the last lecture was better. But if your entire JSX content changes when data is missing, you can also add a if check where you return a different JSX block if some condition is met. And here I simply want to return an h2 tag with a class name of expenses-list __ fallback with a text of found no expenses. So that's what this component, expenses list, will render if we got no expenses. Hence, we can also get rid of that variable here. And with that, we see this found no expenses text or the filtered list if we switch. But now with help of this extra component, which uses a different logic for rendering or for returning different JSX code, and we now also got a little bit of a leaner expenses.js file again. Now one additional tweak which I want to make here, which I almost forgot, is that since I'm using an unordered list here now, for semantic reasons in the expense item component, I actually want to switch away from having a div being rendered to a list item instead. So I will just wrap this entire card here with a list item. And visually, this doesn't change anything, but semantically, this is a little bit better. So that's just another tiny tweak which I wanted to make here. So this expense tracker has taken some shape, and it's basically finished from the core functionality, at least. We got all the core features implemented. We can add expenses, we can filter our expenses. But if you remember the original state, which I showed you a couple of hours ago, then there is one crucial element and feature which is missing. The chart, where we can actually see a graphical representation of our expenses per month. And that is therefore what we're now going to dive into to then conclude this module and this first course project. Now, for this chart, I will start by adding a new components folder, which I'll name chart, because it will hold all the components that are related to the chart. And I will split up the chart into two main components. For one, that's the chart itself, the chart component, which we can add to our application. But then inside of the chart, we have all these bars, and I will actually create a separate component for those, the chart bar component. So we'll have these two components, and we're also going to have some styles. So I'll already add a chart CSS and a chart bar.css file, and you find these two files attached. So as always, you can copy and paste the styles you find in there, or simply use these attached CSS files right away. And then let's start with the chart.js file, with the chart itself. There, I will import React from React, even though that's technically not required in this setup, but still. And then I'll create my chart functional component here, like this. So this component function, I should say, and export this like that. And now with that, in the chart, we of course want to render all these chart bars. And the question is now, how we want to do that, how we want to structure the JSX code in this component, and how that all should work. Well, eventually we're going to import the chart bar component. At the moment, it's of course empty, but we're soon going to add something there, and hence I can already add this import. And I then want to, in the end, return some JSX code where we have all these chart bars. So maybe we first of all set up a div with a class name of chart to apply that styling. And for that, we then also import chart CSS like this. Oops, not chart bar, but chart CSS to apply the styles. But inside of the div, we now want to have the bars. And we could simply render 12 individual chart bars for the 12 months which we have. But I will actually create a bit of a more flexible chart, which is actually not necessarily restricted to months and to 12 data points. Instead, we could say that when the chart component is being used somewhere in our application, we want to receive the data points that should be plotted as props, so that the chart component is fairly configurable and the components that use the chart component can decide how many data points with which values should be rendered. And therefore, I actually will output the chart bars dynamically by going through an array of data points and mapping every data point to a chart bar. And that's of course basically what we already learned in this module, how we output lists of content dynamically, and that's also why I'm doing it here, so that we again practice this. So on props, we could expect a data points prop. Of course, that name is up to you since it's your component, but I expect a data points prop, and I expect that to hold a value which is an array. Hence, we can call map on that, and then we map every single data point into a chart bar component, so that we create as many chart bar components as we have data points. And then, of course, we want to pass some data into the chart bar to control how it will be rendered, so which value will be rendered there. And for that, we of course want to extract some data from the incoming data points. Now, up to this point, we're never using the chart component, so we as the creator of this component can define which kind of data we expect to extract there in the future. And for example, we could say that the chart bar component should receive a value prop, and there we want to pass data point.value. Of course, that will require that in the chart bar, we then read this prop, and that when we define the data points later, that every data point has a value property. So that a data point is an object which has a value property. That's what we're basically defining now, since that is how we want to use that chart component and the chart bar component in there. Now, I also want to make sure that every chart bar plots the value in relation to the maximum value in the entire chart. And therefore, I also want to pass in a max value property, and that is currently null, let's say. That's not data which we extract from the data point, because that is a unique value which is the same for all chart bars in a given chart. So we will need to derive this max value, and we'll do this in a second. For the moment, I'll set this to null, but that's just a temporary value. We probably also want to have a label, though. For example, in this case, to have a label of January, February, March, April, and so on. And therefore, I'll add a label prop and pass in data point.label, like that. And since we're mapping this, since we're outputting a list here, we also should add a key, because you learned that this special key prop helps React render these list items efficiently. And therefore, I do expect that every data point also has a unique ID. Or maybe we actually use the label, so that we say that the label should be unique every chart bar has its own unique label, and therefore we can also use the label as a unique identifier for this special key prop here. That looks good to me. Now, of course, we want to continue working on the chart bar to bring that to life. Now, to build the chart bar component, we again want to import React from React in there, and then import the CSS file, of course, so that we have these styles available. And then we can define our component function, chart bar, and set this equal to props, and then simply return our JSX code here. And we will definitely need props because we are already defining some props here in the chart component. Of course, we also want to export chart bar as a default here. Now for this JSX code in the chart bar, which we return, I want to have a div here with a class name of chart-bar, since that's one of the CSS styles defined in the CSS file. And in there, then another nested div with a class name of chart__inner. And these divs and CSS classes are simply required to make the provided styles work. Now in there, I will add yet another div with a class name of chart-bar__fill. And then next to that div, so not nested, but next to it, I'll add another div with a class name of chart-bar__label. And actually, that should not be in the inner div, but side by side to the inner div. So that this is the structure we have here. A bunch of divs which will then be responsible for rendering this chart correctly. However, like this, we wouldn't see much. For one, I of course want to output the label which we receive on the label prop. And that's why I added this div. There we can dynamically output props.label so that the label is visible. But we also will need to change this chart bar fill div here. This div is required to basically remember by how much this chart bar will be filled. And this chart bar fill CSS class will, for example, define the background color for that. But one important piece of information is missing in the CSS class, and that will be the height of this filled chart bar. The overall chart bar has a predefined height, 100% of the parent container, which is the chart, which has a height of 10 rem. But of course, by how much we fill that bar depends on the data we're receiving. So it depends on the value, because we want to basically fill our chart bar by putting the value in relation with the max value. So that if the max value for the entire chart is 100, and the value for a given chart bar is 50, we fill that chart bar by 50%. And therefore, in the chart bar component, we now need to calculate by how much this specific chart bar instance should be filled. For this, we can add a variable, which we could name bar fill height, but the name is up to you. And initially, I'll set this to 0% as a text, because this will be assigned as a CSS style in a second. So it's 0% like this. But then I want to check if we got a max value greater than 0, so that for the given data points, we do have a max value greater than 0. We could have 0 later if we filter for a month that has no expenses. So we want to check if we do have a max value greater than 0. And if that's the case, I want to set bar fill height equal to math round, and then in nested brackets, props value divided by props max value times 100. This will basically give us the percentage between 0 and 100 by which this bar should be filled. And I'm rounding to the nearest integer here. And we also want to convert this to a string with the percentage sign at the end, so I will add plus percentage here, like this. And now we want to set this as the height, as the CSS style height for this div with the chart bar fill class name. And to achieve this, we're going to do something which we haven't done thus far in this course. We're going to set the style of an element dynamically. And that can be done by adding the style prop here, which is of course a default HTML attribute as well. But actually that style prop, that style attribute, works a little bit differently when building a React application. The value we set here should be dynamic because it should be our derived fill height here. And indeed, you then don't generate a dynamic string where you set something like height 10%, but instead style, and that's the special thing, wants an object. So here we don't have a special double curly brace syntax, but instead we have the single curly braces for outputting something dynamically, but then the dynamic value is a JavaScript object, which is also created with curly braces. That's why we overall have the double curly braces, but it's no special style syntax. The only special thing here is that style wants a JavaScript object as a value. And in this object, you should then use the CSS property names as key names, as properties, and the values as, well, values. So for example here, we can then set background color to a given value, or in our case, we can set height to bar fill height. Now, as a side note, if you have something like background color with a dash, you need the quotes around the property name, because otherwise it would be an invalid property name. Or better, you use the camel case version of that name, background color like this. We don't need the background color here, but I want to show this to you. I will come back to this later as well in the course, but that is how you would target such CSS property names which have a dash inside of them if you are setting the style prop on an element. But here we don't even need that, so I will get rid of it. We only need to set the height. And with that, we also finished the chart bar component. Now we just need to use the chart and pass in the data points. So now to use the chart and pass in the data points, I will add a new component in the expenses components folder, and I'll name it expenses chart.js. And here we don't even need a CSS file, but I will import React from React to be in line with my other files, and create the component function expenses chart. There I expect to get some props, and we export this. So basically what we always do. Now in here, the goal is to overall return the chart. So here we want to return the chart, and therefore you should make sure that you also add the import to this chart component in the chart folder like this. But now we need to define the data points which are passed into the chart, because there we are referring to this data points prop. And to set up the data points here in expenses chart, I will actually create a new constant here and name it chart data points. And this will be an array. And in this array, I want to have a bunch of objects, because we expect every data point to be an object. In the chart.js file, when we map through data points, we then access values like label and value on the given data point. So therefore, we want to have objects, and these objects should have a label and a value key. Now the value is simply 0 initially for every data point, and the label is something like Jan for January. But then I'm going to duplicate this and set up the fab data point, which also initially is 0. And I'll repeat this for the entire year and have a March, April, May, June, July, and so on. Also have August and September and October, and then have November and December, so that we have all these data points, which in their initial state all have a value of 0. Now, of course, we're not done here. We don't want to have 0 for every data point. Instead, now we want to have a look at our filtered expenses and make sure that we basically go through all the expenses for a selected year, and that we then sum up the expenses for all the different months and we assign them here to our data points. So therefore, I expect to get the filtered expenses as a prop on my expenses chart component, because we will use expenses chart in the expenses.js file later, and there we have the filtered expenses. So here in expenses chart, I just expect to get that list of expenses. And then we can add a for loop where we loop through all our expenses, which we get via props. And then we want to have a look at every expense, get the month of that expense, and update the value of the appropriate data point by the expense amount. So here we can get our expense month inside of that loop by having a look at expense.date get month. Date is a date object, and there we have the built-in get month method, which returns us that month. Starting at 0 though, so January is 0. But we can then use this month later to pick the right data point, since January has the index 0 in this array as well. So we can basically use the month as an index in that array later. And later is actually now. I will reach out to my chart data points for the given month. Again, this starts at 0 and ends at 11, which is exactly the case for the index of these data points. So we can use that as an index. And I want to update the value of the selected data point by adding something to it with that += shortcut operator. And I want to add the expense amount, so that we increase the value of a given month by that expense amount. And we go through all expenses to sum up all the expenses for the different months and assign the values to the appropriate months, to the appropriate data points here. So that after this for loop, we still have this array, but now the values will not be 0 anymore, but instead they will have the summed up values for the given month expenses. And now we can pass these data points to the chart. There we set the data points prop, since that's the prop we're expecting there, data points. And we set this equal to our updated chart data points. And this should do the trick. Now we're still not done. We now also want to go back to the chart, and there you might remember that we also need to calculate the total max value. So we want to have a look at all the months and find the biggest value across all months, because that's the maximum value which should be represented in the chart. And to do this, we can add a new constant, total maximum. The name is up to you. And here we can use math_max to find the maximum value. But actually, max wants a number of arguments like this. So comma-separated arguments, comma-separated numbers, for which it then returns the biggest number. Here we have an array though, and also not an array of numbers, but an array of objects. And we're just interested in a specific property of that object. Nonetheless, we can work around that. We can get our value array, if we want to call it like this, or our data point values. And here we can simply call props data points dot map to call the map method. But now we won't map the data points into JSX elements, but instead simply transform them from objects to numbers. So that for every data point, we in the end just return data point.value. So that means that we transform a data point object to just a number, the number stored in data point value. And therefore map here on data points will return a brand new array, which is just an array of numbers, an array of all these values for all these data points we're getting. So in our case, for the 12 months, we'll have an array of 12 values. And now it's the data point values where we want to find the maximum, but since max wants a list of arguments instead of an array, and since this still is an array, data point values still is an array, we can use the spread operator here to pull out all the array elements and add them as standalone arguments to this max method. So now this max method will receive 12 arguments, which are these 12 values from our array, pulled out by this spread operator. And now it's this total maximum, which I pass in here as a max value. And with that, that's also updated. And now we just want to make sure that we use our expenses chart component. And I want to do that in the expenses.js file. There we can import expenses chart from expenses chart like this. And we now simply add that here between the filter and the list. We render our expenses chart. And of course, very important now, we need to pass in the expenses prop because that is expected in the expenses chart component. So here I'll set expenses equal to my filtered expenses because of course I only want to chart the currently filtered expenses. And with all of that, we should be done, except that I'm getting an error here. Cannot read property get month of undefined. And that's simply happening because here in the expenses chart component, I'm using a for in loop. Of course, it should be a for of loop since expenses, props expenses, is an array, not an object. So for of is correct to loop for all the items. And now this is looking better. Now, what we see though, or what we don't see is somehow we don't have any fill values. No matter how I switch, we never see any of the bars being filled. But the reason for that is that in the chart bar component, I'm checking props max for being greater than 0. Well, I actually named the prop max value though. So we should also check props max value here. And now this looks better. Now we see that this looks good, and now we got certain bars which are filled, others which are not filled, simply depending on what we're filtering for. And this is now the finished expenses tracker. Of course, feel free to play around with it, to tweak it, to add more features and experiment with it. But we're also going to have more projects in this course, and we're also going to dive deeper into React. For example, we are also going to take a closer look at styling React components and how we can scope styles to components. Because actually, right now I can tell you all the styles we set up, even though the CSS files have component-specific file names, all CSS styles actually up to this point are global. If a class is defined here in the chartbar CSS file, we could add this CSS class to any element in any component and the styles would be applied. Currently, these styles are not scoped, and therefore that's one topic we're also going to take a closer look at throughout the next modules, but of course also plenty of other core React features. Building web apps with React is not just about composing components together and making sure that the logic works correctly. That arguably is the most important part, or at least it's the biggest reason for using React. But building React apps is also about styling those apps. You want to make sure that your applications look good. And styling is also an important part of building components. And there are different techniques for setting styles dynamically and for styling components such that other components are not affected by a specific component's styles. Therefore, in this module, we will dive into how you can set up styles in a conditional or dynamic way. So how you, for example, can switch certain styles based on some conditions. For example, if a user enters an invalid input and you want to color the input field red, something like that. And then we'll dive into two popular approaches for scoping styles to components. So for setting up styles such that they only affect a component and are not added as global styles. We'll have a look at styled components, which is a third-party library, a very popular one, which allows us to set up pre-styled components with their own scoped styles. And we'll have a look at a concept called CSS modules. And you will learn what these different approaches are all about, how you do work with them, and how you could add them to your next project. Now, to dive into styling, we need a demo project, and to mix things up, I got a brand new project here. Now, I already prepared this one for you. It's a very simple project, as you can tell. You can basically add course goals, like learn React, and that will be added to this list. You can also delete items from there by clicking on them, and that's basically it. This project uses only things which I covered over the last course sections. And of course, you find that project attached. You can simply download it. You find the entire project folder there. And then, once you downloaded it, simply open the terminal, navigate it into this project folder, and run npm install. This will install all the third-party packages which are required, since the attached folder does not come with a node modules folder, because that would unnecessarily load the attachment. npm install simply installs all packages and recreates the node modules folder. And thereafter, you have this project here, which you can start with npm start to start the development server and play around with the project. Of course, also feel free to dive into the source files to see how this project is structured. As I already said, this project only uses features which you already know, like use state and functions which are bound to events. And we're then, for example, also outputting lists of data dynamically by calling map. So that's all something you already saw, and there is nothing new there. This, however, will be our starting project for this section, where we are now going to dive into styling. So definitely explore the source code files so that you understand this project, and thereafter we're going to have a look at the different styling options React gives us. So as mentioned, we are going to work on this project, and therefore make sure that you have the project set up as instructed in the last course lecture. We actually already have some styling in this project, certainly not the worst one. I think it looks quite decent, but there are things we can do about this project nonetheless. For one, we might want to change the way styles are applied, because at the moment we are using regular CSS with regular CSS selectors, like this class selector. And as I mentioned, this style, even though we're importing it into the course goal list component, is not scoped to that component. It would affect any element on the entire page which has a goal list CSS class. So that's one thing we'll tackle. But we'll start with something different, with setting styles dynamically. And a great example can be found in the course input component. There we are collecting some input by the user, and then we have the add goal button to, well, add a goal. In the moment, we can press that add goal button even if we didn't enter anything, and the result is that we add an empty element here. Now, in most applications, we probably want to avoid this. And we don't just want to avoid this, we also want to give the user some feedback about the incorrect input. And that's something we'll build now, and that's something for which we'll need to set styles dynamically. So in course input component, it's the form submit handler where I in the end want to check whether something valid was entered before we trigger that onAddGoal function. So that function we get on this onAddGoal prop, to be precise. For this, we can add a simple if statement here in the form submit handler and check if the entered value, if we trim it, trim is a built-in method that removes excess white space at the beginning or the end, and I use it here to rule out that the user just entered a bunch of blanks. So if we trim this and we check the length, if the length is now equal to 0, we know that the input is essentially empty. In that case, I want to return here. Hence, this line of code will not be executed because function execution stops when you return. And we're done. But the problem now is, now we made sure that we can't add empty goals. I'm hammering this button and it doesn't do anything. This works, however. But even though we added this, we don't give the user any feedback. And that's exactly where we now need our styling. I want to add a red border and a slightly red background color to that input, and also a red color to that label if the user entered something invalid here. Now, how can we achieve this? Well, we can manage an extra piece of state here, and that state could be an indicator for whether the user submitted and entered something valid or not. So it's a true or false choice, and therefore we'll be working with a Boolean. And initially, let's say, we trust the user, so initially we set this to true, and I'll name this state is valid, and the updating function set is valid. Now, as long as this is true, I consider the input as valid. If we make it into this if block, though, I know it's invalid, and therefore we can call set is valid and set this to false. Because what the user entered and submitted definitely is not valid. Now, if this is false, I want to apply the styles I just said. And the easiest way of doing that is to add the inline style here to the label, for example. And as you learned, you need to set an object there. The inline style prop here wants an object as a value. And in that object, you target the different CSS style props in JavaScript that you can set for this element, for this component. So for example, here, the color property is available, and we could set this to red. But of course, we don't always want to set this to red, but only if the input is invalid. So I check if not is valid, and if that's the case, I set this to red. Otherwise, I set this to black, for example, which is the default color. And that should allow us to dynamically set this to a red color. We use the style prop, we pass an object to it as demanded, but we dynamically change the value that's fed into the color property in that style object. And therefore now if we save this and we go back, if I submit this without entering anything, you see that label becomes red. Currently we then never reset it, but that's a first important step. Now we need to also change the border and background color of this input, and that's definitely something you can try on your own. Here's a short break which you can take to pause the video. Thereafter we'll implement it together. Were you successful? Well, adding it shouldn't be too hard. We add the style prop again, pass in an object because that's what it wants. And now we can set the border color. And that's the only tricky thing. It's border color written like this, because we're in JavaScript here, not in a CSS file, and therefore we need to use the JavaScript property name for that CSS property, and that happens to be the camel case version of the CSS property name, hence border color written like this. And I also want to set this to red if this is invalid. So the value is exactly the same as up here. And therefore, of course, we could also refactor this into a separate variable. For the moment, since I only need it in these two places, I'll keep it like this. And we also need a background. And here again, I check if this is invalid, in which case I colored it red, otherwise black. Now this red might actually be a bit too much. And therefore, maybe here we want to use something else. I think salmon should be good. And that should not be black, but transparent, because of course I don't want a black background in the input. I want a transparent one. With that, if we save this, now if I click Add Goal, it's colored like this. Now it's also never reset at the moment, but at least we got the conditional styling. And of course you can play around with the exact color values to, well, get a different styling. Now, 2 notes. For one, of course, we want to reset this eventually. And second, I'm not 100% happy with that, because with this approach we currently have here, we always set inline styles, which of course have the highest priority in CSS. So you override all other styles with that. Now actually I'm happy with the default styles we set up in course input. For example, for the input, I have a border color of this light grayish color here. Now, needless to say, we could set this up here as well. I could reset this to this grayish color, for example, instead of black, so that when we reset it, we go back to this predefined color we have in the CSS file. But still, we have some duplication here. We got a base color scheme here in the CSS file, and then we override this with inline styles just because we want to conditionally set some specific styles if the input is invalid. And that's why I'm not 100% happy with those inline styles. So let's now quickly work on the reset functionality before I then show you an alternative to setting dynamic styles with inline styles. Now, to work on that reset functionality though, all we need to do is go to the place where we react to every keystroke. And in the end, we just need to check if event target value, which is the entered text, if that is now basically valid. So if we trim it and get the length, if the length is greater than 0, if it is, we know the input is valid, and then we could call set is valid and set this to true again. And here, of course, we need a dot. And with that, if we go back, if I submit this, this is red, but if I start typing, you see it's no longer invalid. But if I submit it in an invalid form, it of course still becomes red. So that's working, but as I mentioned, for the reasons I mentioned, I'm not 100% happy with the inline styles because they take a very high priority, and you can certainly always find ways of making it work, but I personally would prefer to not set inline styles. So let's have a look at an alternative. Which alternative could we have to setting inline styles? Well, how about the following alternative? What if we could add a new CSS class to this div, which holds both the label and the input, and we would add this class dynamically only if the value entered is invalid. That could be something like a invalid class here. The name is totally up to you. So this invalid class should sometimes be added here on this div. And then in CSS, we could prepare the fitting styles. For example, here we could say, if the form control also has the invalid class, and therefore make sure there is no space between form control and this dot, which means they both have to be on the same element, then we could target our input and set the border color to red. And we could set the background to red, or actually now pick a much lighter version, like this very light rose color here. And if the form control, the div with the class form control, has a class of invalid, we can also target the label and set its color to red. So these here would be 2 CSS rules that should lead to the desired output. And all we need to do for these rules to have an effect is we need to add that invalid class dynamically. And here's how you can add classes dynamically. Let's get rid of these inline styles. We don't need them anymore. And instead, let's see how we can change this class dynamically. It's very, very easy. Since we need a dynamic value, we need curly braces. Because a string is always a string. It's a hard-coded string. So we need curly braces. And now what we feed in, of course, still can be a string of form control. but a string where we dynamically add more text in it, where we dynamically expand it or concatenate a value to have this string, whoops, invalid, instead of this string. So what we pass to class name on this div sometimes is a string that looks like this, and sometimes will be a string that looks like this, depending on what the user entered and depending on our isValid state. And for that, we can use a nice construct. We can use backticks here. Now, in case you're not familiar with this is a default JavaScript feature. It's called a template literal. This constructs a string, but we have backticks here, not single quotes, but backticks. It's a special character on your keyboard. And whatever you type between there will be treated as a regular string. So we can add form control here. But, and that's now the tricky thing, you can also inject a dynamic value into that string with a special syntax which looks like this: $, and then again a pair of curly braces opening and closing. This adds content into the string, and what you pass between these curly braces can be any JavaScript expression. So a lot like our curly braces inside of JSX, here now inside of the template literal. So here we could now check if isValid is not true, hence the exclamation mark at the beginning. And if that's the case, we insert invalid here into this long string. Otherwise, we enter nothing or simply an empty string in this case. So that simply will make sure that class name is either set to a string which has only form control blank nothing, or to a string which is form control blank invalid. So therefore now if we save this, if I submit this in an empty state, I get my error look here, my error style. But other than that, if I start typing, I go back to the non-error style because we dynamically add this invalid class. And of course you can inject multiple things into that string, so you could repeat the same technique to add more dynamically added classes. And that's very powerful because now you're back to working with CSS files and with classes only. And you can dynamically add or remove classes with this simple syntax. And it will be React's job to actually add or remove the classes in the DOM. You do what you can do best in React. You specify a goal, you specify some alternative states, for example, that the goal sometimes is to have just form control, and sometimes form control and invalid. And React will make sure that the DOM, the real DOM, is updated accordingly. This is React in action, and this is how you can add styles dynamically. Being able to set styles and classes dynamically is super important, and you now learned how you can achieve this in React code. Now let's move to something else, and that would be the styling itself. Currently, we're using just CSS for that. Regular CSS files with regular selectors, mostly class selectors, but also sometimes combined with tag selectors, for example. We're importing these files into our component files, but as I emphasized multiple times, this does not result in those styles being scoped to this component only. So that means that if we had any other element anywhere else in the DOM that had a form control CSS class on it, this style, for example, would target it and would affect it. So it's not like we only care about form control elements in this component. No, every element on the entire page is affected because by default, those styles are not scoped. Now, that is not necessarily a problem. You can, of course, be careful about your selectors. You can use class selectors or ID selectors here. It is regular CSS after all. You can use any selector. And you can ensure that the IDs and the classes you are selecting are only used in the places where you want to apply the styling. But of course, especially in larger projects, potentially with a lot of developers working on the code, it could happen that a name is used twice. that form control, for example, is used in different parts of the application, and therefore, unfortunately, styles spill over to other components, and you might want to avoid this. And there are various ways of avoiding this, and I will show you the two most popular approaches therefore. Approach number one is to use a package called styled components. And you can just search for styled components to find their official web page. Now on this page you can learn all about styled components. Here I will only introduce you to the package. If you want to use it, you can dive way deeper into it with those docs, but I will give you a thorough introduction, no worries. Styled components is a package that helps you build, guess what, components which have certain styles attached to them, where the styles really only affect the components to which they were attached and not any other components. Now, to get started, we need to install that package. And here you see the command you need to run for that. Now, if you've never installed packages before, keep in mind that our project here already has a couple of packages on which it depends. For example, React. And we're just adding one more package here. For that, you should quit your development server with Ctrl-C and run npm install --save styled-components inside of this project folder. Now this will download this package and store it in the node modules folder, and thereafter you'll be able to use it in this project. So let's wait for this to finish. Yep, here it is. And with this finished, you can restart the server with npm start. Now, if you're following along on Code Sandbox, you won't have such a terminal to add a dependency and to run npm install. And instead there, you have this dependencies area on the left here to add dependencies. There in this add dependency box, you would simply type the name of the dependency you want to add, like for example, styled components, and you'll get a bunch of suggestions here. And you would then simply pick the suggestion for the package you do want to add. So in this case, indeed, styled components. And boom, there you go. That's how this package gets installed there. You can then theoretically tweak the version that's being used, but the default version it installs for you should be fine. And with that, this package was now added and is now available for usage in your code. So now how do we use this package? Of course, you can learn all about it on the official page, but I will simply introduce you to it step by step. Now let's pick a place where we do want to use it. And let's say we want to style our button. We actually already have a button component, but we really only created this button component, if we're honest, because we wanted to have some default styling for a button. Nothing wrong with this approach, but here we could also use the styled components package to achieve this in a bit of an easier way. Now, how would we do this? We could rebuild our button here by creating a new constant button. And now what we store in there is not a functional component, but instead we now import styled from styled-components. This import is now available since you installed the package. We can get rid of that button CSS import, and instead now we use styled.button, and then we add two backticks like this. Now that certainly is a super weird syntax, and chances are you haven't seen that before. This is called a tagged template literal. It's a default JavaScript feature. It's not specific to this package, not specific to React. You could use it in any JavaScript project. And now what does this do? Well, button is simply a method on this styled object. Styled is an object we're importing from styled components, and there we can access the button method. It's just a special kind of method, you could say. Instead of being a method which you call like this with parentheses, you add these strange backticks after it. And again, that's just a default JavaScript syntax which is supported by JavaScript. In the end, this will be executed as a method behind the scenes, and what you pass in here will be passed into this method just in a special way. If you want to learn more about this tagged template literal syntax, you find a link attached where you can learn more. Here, I don't want to waste your time since we won't need to know the internals here to proceed. For the moment, we just need to know that what we pass between these two backticks
will kind of end up in that button method. And this button method, and that's the interesting part, will return a new button component. Actually, that styled package has methods for all HTML elements. It has a P method for a paragraph, H1, H2, and so on for the H1, H2 tags, div to create a div, and so on. It's all there, and here we need the button. So this overall expression will return a button, but a button with the styles we provide between these two backticks. The cool thing about the backtick syntax is that you can write a multi-line string like this, so you can split this across multiple lines without any extra syntax. And now we can just copy all the button styles here and add them in here. We'll need to tweak them, but that is something we can do. Now, what do we need to do to make this work in the end? This will return a button, and this button won't have a class of button because we have no place where we would set up this class name. So instead, the styles we pass between the opening and closing backtick will directly affect this button. You therefore get rid of any selectors like this, and instead just paste in your styles just like that. And they will be added to the button element, which is returned by this method call, which is then stored in this button constant. Now for pseudo selectors, you can use the ampersand symbol. That's supported by that styled component package. This tells the package that you want to have a special case, a special pseudo selector in this case here, for this component which is created here. So in this case, we're saying, hey, when this button here has focus, please apply this style. We can do the same here for hover. So and:hover and:active. And this should now give us a button which has these styles. Now the button which is returned also by default applies all the props you might be passing to your own button component, which we're exporting here in the end. So we can still add an on-click prop, we can still set the type. That will all be forwarded by the styled components package to that core built-in button, which we previously wrapped or used ourselves, which is now used internally by this button method. We can now get rid of the React import up there because we're not dealing with JSX in this file anymore. And if we now save this, we should see that our application looks and works exactly as it did before. So this still works, but this is now our styled button. Now we can tell that there is something different if we inspect it in the developer tools. Of course, it's a regular button. That's what this button method here in the end returns. But you see on that, there is a very strange class, two strange classes to be precise. And these are class names we certainly didn't set up. These are class names dynamically generated by the styled components package. Because what this package does in the end is it looks at the styles we set up here, and then it wraps these styles into generated class names, where it guarantees that every class name is unique so that it can't spill over to other components of the app. And it will then add these classes as global CSS. But now, since we have unique class names for every styled component, the styled setup here will never be able to affect another component in the app, because these unique class names are really, well, unique per styled component. So that's how the styling is applied here, and that's how styled components work. Now, of course, we can also use styled components when we want to set up something dynamic. Styled components can be very useful, but can we also use them for our div here, for example? The answer is absolutely. If we want a styled component which we really only use in this file, we can also create it in that file. We can also create a brand new file as we did it for the button. But even though we're only using the button here in this app, you could argue that a button is a component you might be using in a lot of other places of the app as well. Now for the div, that might also be the case. Maybe you have other form inputs in other parts of the app as well. But to also show you that you can have multiple components per file, and that this might make sense if a component is really only getting used in that file, I will now create a brand new component in that course input file. Thus far, we always had one component per file, and that generally is a good rule to keep,
But if you have a component that is really only getting used by that other component in that file, having both components in the same file can make sense too. So here I want to have my form control, for example. That name is ultimately up to you, but since I'll use it as a component in JSX, it should start with a capital character. And here, again, I'll use the styled components package. So we can import styled from styled-components. And then here we can use styled, and in this case, styled div, because I want to replace this div later. So I want to render a div. So if I go up, I have my styled div and now the backticks. And now in here, I want to have those styles. So we can grab all those form control styles here, copy them, and add them here between the backticks. Now, just as before, get rid of the selectors. Just have your styles in here. And if you have something like this, where you have the class that is on that div which you're creating here, and then you want to target a nested element, you do the same as we did in the button with the pseudo selectors. You simply use and this tells styled components, I'm now talking about labels inside of this div. So that and always refers back to that component which is being created. And if you then want to have nested selectors you want to target, that is how you do it. So we can do this here, also for the input, of course. And also here, if we have an input that is focused. And also here, if we want to check whether we have invalid on this div. And also here. With that, we have our styled component, our form control, which is this styled div. And now we can go back here and now replace this div here with our form control. If we save that, it generally works. And you will see here on that div, we also have these strange unique classes. You will also see that these are, of course, different classes than we have on the button, because as I said, you have unique classes per component to ensure that styles never spill over. But you'll also see that if I submit this in an empty state, we don't get the error state here. Now, of course, this can't work because we're no longer setting the invalid class here. And we need that invalid class here in our rules though, here and here. Now the good thing is that these styled components, so the components returned by these styled components functions, forward all props you set on them to the underlying component, so to the underlying div here. So we can still add a class name here, and here the value we want to pass in is either an empty string or invalid. We no longer need to set form control because the styles that were attached by form control are now already getting attached with the setup we have up there. So instead we just need to set this to invalid or nothing. So what we can do here is we can simply check if not is valid, and if that's the case, I add invalid as a string here. And with this syntax, I otherwise add nothing, which is perfectly fine because I need no other class if it is valid. But if it is invalid, the invalid class is getting added. And now with that, we have the same behavior as before here if we add goals. That, however, is only one way of doing this. We can do this, and it's perfectly fine, but you can also utilize another feature provided by styled components. You can also add props to your styled components and utilize those props inside of these backticks, so inside of your styles, to easily change styles dynamically. How does this work? Let's say here on our form control, when we use it down there, we want to add an invalid prop. Name is up to you because it's your component, and this should be true or false. The value we feed in, therefore, is not is valid. So if is valid is true, we feed in false because it's not invalid if is valid is true. If is valid is false, we feed in true because invalid is true if is valid is not true. So we set invalid to true if what the user entered was invalid. And this invalid prop can now be used between those backticks here. Now, how do we use it? Well, we wanted to change the border color of the input, for example, right? So we go to the place where we set up the border color, and now here, since you're between backticks, you can use this $ curly brace syntax you already know. And here you pass in an arrow function, which receives props as a parameter, and then should return the text that should be returned in this exact position. This function will be called by the styled components package, and for props, it will feed in all the props your component gets. So in this case, the invalid prop. So here we can now check if invalid is true, and if this is the case, we return red as a text, otherwise we stick to this grayish color. And this should of course be props.invalid. So with that, we're having this dynamic way of changing parts of the styles based on some props that are passed to our styled component. So this is this. Now we also want to set the background color. So I'll set background here to a dynamic value. And just as before, I check props invalid. And if it is invalid, I set this background to this light reddish color here we picked earlier. And otherwise, I'll set it to transparent. And with that, we can remove this style here. Now we can also already remove the label style, which was based on the existence of the invalid class, which we no longer add, and instead go up to that label styling here and add a color definition. And just as before, the value we set for color is dynamic. We provide this function which will be called by the styled components package. And we check if the invalid prop is true. If it is, we set a color of red, otherwise a color of black. And with this approach, if I save this, we got the exact same behavior as before, as you see. But now, by utilizing styled components only and by utilizing this feature of dynamically changing parts of the styles based on the props that are set on your styled component. This sometimes can be hard to get into, this way of thinking, but it's also a pretty nice way of working with components and styles. Therefore, I wanted to show this to you. Now there's one last brief use case which I want to cover before I show you a more CSS-ish alternative. Now there's one last thing I want to cover when we talk about styling, and that would be media queries. Media queries, of course, often are important to get the right look. At the moment, if we preview this in a mobile device here, let's say the Pixel 2, doesn't matter which one you use, this is how it looks like. Let me zoom in a bit. This is how it looks like, and that's definitely all right. Right? Of course, you might want to add more to make this look good on mobile, but from a pure styling perspective, that looks good. Nothing is going beyond the edges, so that looks okay. But maybe we want to make sure that this button actually spans the entire width if we're on a small device and only takes the space it needs if we're not on a mobile device. And that would be a scenario where we might want to use a media query. So let's go back to the button, and how can we now add a media query here when we're using styled components? It's actually super simple. You just add your media query here, add media, and define your criteria, for example, min width 768 pixels. And now you just put the styles into that media query that should affect this element when that condition here is met. That's all. You need no selector in there, nothing else, just the styles that should be applied to this component if this condition here for this media query is met. So here, that is actually now the media query for big devices, non-mobile devices. And there I want to set the width to auto. The default width, so if the media query is not met, can be set to 100% then up there. And as a result, if we save this, we have that big button here on mobile. But if I go to a bigger screen here, By zooming out a bit, you see now the button only takes as much space as it needs. And keep in mind, I'm zoomed in here so that you can see things a bit better, which is why for me I have to drag quite a bit to go to this big screen mode. But this is now a media query in action, and it's in action with the help of styled components. So styled components, definitely a nice package for, well, styling components and ensuring that components really only affect the styles on which you set them up. Now, whether you like styled components or not is an absolutely personal thing. There is no wrong or right here. Now, when it comes to me, personally, I prefer CSS in CSS files. I like the separation of CSS and JavaScript. I like having clean JavaScript files, and I simply like default CSS. Now, of course, you can absolutely stick to the CSS approach we used at the beginning, where you had global, non-scoped styles, and you as a developer had to make sure you're not accidentally reusing names, class names, you're not accidentally affecting the styles of other components. That is definitely one route you can take. You can also, however, take CSS to the next level with a feature called CSS modules. CSS modules is a feature which is only available in projects that are configured to support it because it needs a code transformation that needs to be done before your code runs in the browser. Now, the good thing is the React projects created with Create React App, which we used, are already configured to support CSS modules. This is actually an excerpt from the official Create React App docs, where you learn how you can utilize CSS modules. And it's super simple to utilize CSS modules. So let me show you how it works. And let's start with the good old button again. Now, of course, you can stick to the styled component there, but I will comment this out and comment out this import, and instead add the import of React from React again, because I will comment in my own component again, this one, which uses JSX and which therefore needs the React import. Now we have the button CSS file, and in there we got the different styles, and we can leave that as it is. There's one thing we now need to change though. Of course, we need to add the import to the CSS file again, but instead of importing it like this, you now import it slightly different. You import classes or styles, totally up to you, from the CSS file. That's a syntax we haven't used before, but that is actually how you have to import from a CSS file if you want to use CSS modules. Actually, for that code transformation, which is needed behind the scenes, to happen, you also need to rename your file a little bit, your CSS file. You need to add .module in there so that it's named button.module.css. And then, of course, here you import from button.module.css. This is basically a signal to the underlying compilation process to transform the code so that CSS modules work. And I'll show you how they work behind the scenes in a second. So now we have this import, and now we need to do something with this imported styles thing here. We use it down there where we apply our class name. Instead of applying a string class name like this, you apply something dynamic. You refer to that styles thing, which you're importing from the CSS file, and that thing turns out to be an object. And in that object, you'll have every class you defined in your file as a property. So if I added a button class here in the CSS file, I now have the button property here. And that's all we need to do. This will apply this button class in a special way to this button element here. Let's see it in action. Let's save this and go back to our application. And we see the button looks the way it looked before. Now we see something interesting if we inspect this here in the dev tools. On the button, you see a very strange class. This is not the same class as added by styled components. Those classes looked like this here on the div. Instead, this looks a bit like the class we defined, button, but with more information added to it. It's basically component name underscore our class name in the CSS file, double underscore some unique hash. What CSS modules does, or what this concept of CSS modules does, what the build process does under the hood, is it takes those CSS classes in the CSS file and basically changes those class names to be unique. That's the core thing it does. For every component, it changes the class names of the classes you're importing here, so of the CSS file you're importing, to be unique. So if you import from the CSS file here in the button component, it will create unique classes, unique versions of all those styles and classes here for this component. And for that, it generates brand new class names that look like this. Inside of these class names, your styles will be. So it will just keep your styles. It will not touch those, but wrapped into this new class name. You can see this if you expand the head section here in the rendered DOM. There you will see a bunch of style tags. And if we now search for the one here it is for the button, we see that's this newly generated class name. Here we have our button styles, and that newly generated class name is also used on the focus style, on the hover, and on the active style. And with that, this CSS modules concept ensures that the CSS styles we set up in a CSS file are scoped to the component we import this file into. For that, we need to work with CSS classes here, because we then access those classes as properties on the imported styles object. This is how we basically make the connection between these dynamically generated class names, which we as a developer don't know in advance, and our components here. And that's also what you see here in the official docs. That's in the end all that's to it. This is how you can use CSS modules. And for me, that's actually the best of both worlds. We have our styles set up in CSS files, but they're still scoped to the components where we use them. So in the next module, let's also port the course input back to use the CSS file. And then I will also show you how to use media queries with CSS modules. So now that we use CSS modules, let's also use the concept here in the course input component. We got the course input CSS file, and as you learned, you need to change the name to .module.css. With that, I mean the file name. So course input.module.css. In the course input component, you then import from course input.module, and as you learned, you import something from there. Again, the name is totally up to you. Typically, you name it styles or classes or anything like that. We can remove the styled import from styled components because I'm going to comment out this form control. Like this. I'm not going to use it anymore. Instead, down there, I'll go back to my good old div. And on that div, I will add class name to styles.form control. And now we have a problem. This is an invalid property name, but I named my class form control in here. Well, it's not a problem. We just have to use a different syntax for accessing the property. We use the square brackets and wrap this name into single quotes. This is how we can also access properties in JavaScript, and with that we can also access properties with such a name. Because strings are valid keys in JavaScript objects. Alternatively, of course, you pick different CSS class names without dashes in them. Here, however, I'll stick to that, and there for now we got our styling back. Now, of course, the invalid style is not getting applied. And the reason for that is simple. For that invalid style to be applied, we need to make sure that the invalid CSS class is added on the element. And currently, that's never happening. We're only adding form control, only adding this class, or the transformed CSS modules version of that class to be precise. We're never adding the transformed invalid class version. It is something we can also do easily though. We can go back to that backtick syntax to create a string where we inject values. And the first value I want to inject is that resolved class name here. So I inject this converted class name, which we're in the end extracting from that styles object, here into this string. With that, if we save this, nothing should change. And now, of course, just as before, we can add an additional class here. We can check if not is valid, and if that's the case, I add styles.invalid here, referring to that converted version of that invalid class. Converted because that's what the CSS module process will do behind the scenes. And invalid because the CSS class name is invalid in here. So with that, we're adding this converted version of our own class, this scoped version of this CSS styling, so to say, to this div if is valid is false. If we now save this and we go back, if I click add goal, it's red. If I type, it's no longer red. It gets red again, and so on. So this now works again, but now we're adding dynamic classes here with CSS modules. It's not really that different from normal classes, because these are normal classes. We just extract the converted class names as they were generated by CSS modules. That's all. And then we combine them as needed. Last but not least, let's see how media queries are set up in CSS modules. And for that, let's go back to the button. There, I had a media query in my styled components. So we can copy that and go to the CSS file which we're using now. And here, you just add a media query as you would always add it. Maybe here at the bottom. Let me get rid of these slashes. The important difference to styled components, of course, is that now you need your selector again. You always need that in CSS. The non-selector syntax here in styled components is really just a styled components feature because it processes your CSS code. This is not CSS code that would work like this in a browser because CSS always needs a selector, and that's why we need to add a selector here. With that, however, we got everything we need. We set the width here to 100% on small devices, and then on bigger screens, we reset it to auto. And that should be all that's needed. No other changes are required because I'm working on the same CSS class, which I'm already adding to the component here. So with that, you see I have the big button there, and on bigger screens, it's the smaller one. So that also works, and it also works with CSS modules. Now, ultimately, it's absolutely up to you which approach you prefer. I showed you the CSS only, the styled components, and the CSS modules approach. And I mentioned the different pros and cons. And you can simply use the approach you like. For the rest of this course, I will use CSS modules because I like that scoping and I like having my CSS code and my JavaScript code separated. But if you prefer a different approach, that's of course also perfectly fine. We learned a lot about some of the most important features of React, also about its core pillars and how you style React apps. Now, when you're building apps with React, or in general, if you're working as a developer, you will encounter errors. That will always happen. You'll never write code that is error-free. During your development process, you will always face errors. And in this module, you will learn how to debug React apps. So how you can find and fix errors. Because that's one of the most important things you need to be able to do as a developer. It's often overlooked, and I see way too many developers or also students in my courses that simply ask immediately that they get an error. They immediately look for others to help them. And that's the wrong approach. You need to be able to find and solve errors on your own because errors will always be a part of development. Therefore, in this module, we will explore how you can make sense of the error messages React throws at you in certain circumstances. We will learn how we can debug and analyze React apps in general, how we can understand our code whilst it's executing, and we'll explore the React Dev Tools, an extra extension we can install in the browser to get a better React developer experience. Let's start with error messages. Attached, you find a project, this project here, which is a slightly altered version of the project we worked on over the last modules. Now, in this attached project, I added a couple of errors, a couple of problems. And therefore, if you run npm install and thereafter npm start, you will immediately get an error here in your terminal. If you visit the application in the browser, you will also basically get the same error output there instead of the application. And that is a common thing. Sometimes when you're writing code, you get errors. Errors which React catches, or the React development process catches and throws at you. And as I mentioned before, often in the Q&A section of my courses, for example, I see students who immediately panic when they see an error message and they don't read it themselves, they don't try to solve it themselves. Instead, they immediately create a new thread and ask for help. This will not help you as a developer. This will not make you a better developer. It will actually make you a worse developer. You need to be able to understand and solve errors on your own. So let's, for example, have a look at this error message. It failed to compile, and that's why we can't see the application. And the problem we have is that we have a parsing error. Adjacent JSX elements must be wrapped in an enclosing tag. Did you want a JSX fragment? Okay, we haven't heard about JSX fragments yet. This is something I'll cover later in the course. But we also have that first part, and we can make sense of that. Adjacent, which means side by side, JSX elements must be wrapped in an enclosing tag. And we also get a hint at the file and the line of code this error is stemming from. We even see the code snippet here below the message. We see that it comes from app.js, and there, line 43, column 7. That column part is not that important, but line 43. And if I go to my app.js file, we see here, line 43, even my IDE detects this error. Now, as a side note, this is an error my IDE is able to detect. It won't detect all React errors, though. So sometimes you get an error which is not showing up in your IDE. But here, I get an error which is shown in the IDE, which is also shown in this snippet, which is pointed at by this line of code here, and which I also see here in the browser. It also shows me that snippet, that file name, and that line information. I get all of that here as well. So what is wrong here? Well, there seems to be a rule in React that forces us to basically wrap neighboring side-by-side elements in one surrounding element. And here the problem is that we have a section next to a section, and such adjacent JSX element which you return are not allowed. Instead, you need to wrap them in one root element. Now in there you can have side-by-side elements, but whenever you return JSX or you store JSX in a variable, you must only have one root element in there, which then can wrap adjacent elements. That is a hard rule you have in React, and as a side note, and I will dive in that in more detail later, but as a side note, we have that rule because behind the scenes, this is this React create element code I showed you earlier, and you can't have two statements side by side being returned by one return statement either, for example. And that is what two adjacent sections would be translated to. And that's the reason, but we'll have a look at that in more detail later. But this is an error we are able to fix
even without fully understanding where it's coming from, because the error message clearly tells us that we need an enclosing, so a wrapping tag. And as soon as I do add such a tag, for example a div, I'm able to save this, and it now compiled successfully and my app is back up and running. So that is an example of a React error message which we just had to read and we were able to solve it. Now, other common mistakes that are often made are, for example, incorrect names of functions you're pointing at. Let's say here we're pointing at the addGoals handler function when it's actually named addGoalHandler. A simple typo. Again, my IDE detects it, it gives me a clear indicator that something's wrong here, and therefore we should check this and check it for typos, for example. But if I would save it nonetheless, again we get a compilation error also here, and we see that addGoalsHandler is not defined. Again, this is a pretty clear error message. We clearly are trying to use something, some variable, which isn't found by React. And then again, you should go to that place and check why it's not found. Maybe you have a typo. Maybe you forgot to define such a function or variable altogether. So here it's a typo. If we fix it, it compiles again. So don't panic, read error messages, have a look at the line and the file it's coming from, have a look at the code snippet it might be showing you, and then look at the problematic code part, at the problematic code snippet, look at the error message, connect the error message to the snippet it's pointing at, and you will be able to solve most errors. So with that error solved, the application is running again. Now I can start adding goals again. For example, master React, and also let's say check out our courses on React. Now I added these goals, and now I actually also have another error in this application. Another error which won't lead to a compilation error here and which won't show up here on the main screen though. If I delete my newly added check out our courses on React goal, you see it's there. Actually, the other goal I added was deleted, even though I clearly clicked on the check out our courses on React goal. So, since that worked before in the other course modules, there has to be something in my code that is causing this error. So what could be the problem here? I'm not getting an error message here on the screen, not here in the terminal either. So how can we now solve such an error? Well, there are a couple of things you can do, a couple of steps that are worth a try. Let's first of all go to the place where we have that deletion logic. We got our course goal list, and there we have on delete where we trigger props on delete item. If we go into a course goal item, we see on delete is in the end triggered when we click on that. I don't really see an error here. We are forwarding that ID. In course goal list, we just pass on that event in the end to on delete item on the course goal list component. So if we go to the app component, where this ultimately is being rendered, we see that the delete item handler is executed. And there we get the goal ID and we delete a goal. Now a goal was deleted, as we saw, just the wrong one, so the deletion logic in general seems to work, but maybe the ID is wrong. So maybe we should go to the place where the IDs are generated and assigned. And that's here in the addGoal handler. And here indeed I changed something. I set my ID to a hard-coded string. Previously here I used math random to derive a pseudo-unique ID. Now with the hard-coded string, I introduced a logical error here. The error is that I assign the same ID to all goals. So therefore, they're no longer distinguishable by ID, and hence if we click on a goal, the first goal that has the ID, which is found in the goals array, is deleted. And that's always the first goal I ever added. That's why not this goal was deleted, but the goal which I added before. So that's a logical mistake. And I was able to narrow it down by going through that complete chain of events. We click on a goal, we trigger the deletion handler, and I had a look at all those steps to narrow down the problem to finally find this problem here. And this is a perfectly fine way of trying to solve this. Now here's another thing that could help you. If I add goals again, check out other courses on React, and master React. If I do that, and I again click on the first goal and the second one is deleted, let's now open up the developer tools here. And there, let's have a look at the console, the JavaScript development and debugging console. Here, the browser gives us any logging messages we added to our code, and also some warnings and errors that are thrown by the library, which don't crash the whole application necessarily. And here we see that we got a warning actually. And we get that warning already when we add a goal. The warning that I get here is in the end that React encountered two children with the same key. So two children with the same key were found here, with the key goal1. And this is implicitly related to our deletion problem. Now again, we're not getting that warning when I delete something, we already get that warning when I add a new goal. But this already tells us that we have some error in our code, because if we got two children with the same ID, with the same key in the end, then we seem to have an error in our code where we assign the same ID multiple times, which indeed is the problem we have. And React, of course, also tells you where that problem occurs. This here is an error related to our list, because that key concept, as you learned in the lists and conditional module, is related to lists. But it is related to the list here in that unordered list in the course goal list component, line 8. So again, you get a pretty clear idea of where this warning in this case is coming from, and you can then have a look at the code there and find out why that problem occurs. And if you then work your way back to the place where goals are added, which is the place where the IDs are added, which in turn are the things that are used as keys here, we do use the goal ID as a key, well, then you would be able to come back to that place where the hard-coded goal1 ID is. Because we even see that goal1 is the problem here in the warning. So that's another way how you might have solved this problem. But you can also use another approach. You can use the debugger built into the browser. You can use breakpoints. So we have a pretty much logical error here in our code. We have the problem that we have the hard-coded ID, and we already learned how we can find and fix this error. Now let's say we didn't use any of the other two approaches, we overlooked that warning, and we don't know why it's behaving incorrectly. In such cases, if you can't find the error otherwise, or if you just prefer this approach maybe, you can go to the Sources tab here in the browser developer tools. And there you find in the end the source files that are being used on this web page right now. And that includes your JavaScript code. And the cool thing is that this React development process, this npm start script here, which runs in the end, is set up such that it, of course, pushes code to the browser that is executable by the browser, but it also gives the browser extra information which the browser developer tools are able to pick up to allow us to actually debug our code in the raw form we wrote it in. So that we are able to debug with that code we're writing in these files, even though that technically isn't the code that's executed by the browser. So this React development process gives the browser a bridge between the code that runs in the browser and the code we wrote. And we can access this code here in the Sources tab by going to that users folder, which you should see. Users, your username, and then a source folder, and in there you find your React files, the files we actually also have here in our IDE. Now, if you don't find it here, you can also check out that Webpack folder, and there you might also find a source folder with your source files.
You can look around because sometimes it's located in a different node, in a different subfolder, but somewhere here in the sources tab, in this tree of files and folders, you should find your original source code. And then you could always dive into the different parts that you want to analyze. You could go into the course goal item and there, for example, the delete handler, and simply add a breakpoint by clicking onto the line number where you want to add it. In this case, that delete handler function, which is triggered when we click on a list item, because that's where the deletion process starts. So maybe that is where we want to pause the code and then step through the code step by step so that we can find the problem. Once you add such a breakpoint, if you then execute that action that triggers that code part where the breakpoint is placed, code execution stops once it reaches that breakpoint line. So you see that here it's paused in the debugger, and that line is now highlighted in blue here, and you got surrounding information in those boxes at the bottom. For example, you see variables which are currently available, you see the call stack, and so on. And now you can do something cool. You can step through your code step by step. And for example, here we call the onDelete method on the props object, for example. So to have a look at what's going on there, we can use this step into next function call button. If we click that, we're in the delete item handler, which is the function that was triggered because of that props concept. And here we see that set course goals function which is being called. And you can also hover over variables here to see the values that are currently stored in them. And for example, if I hover over goal ID here, I see that it is goal 1. Now, this might or might not help me here, but I can see that I have goal 1 here when I clicked on this goal, which was actually the second goal I added. Now we can use the step over next function call button here to finish that set course goals function call. So now with that, the delete item handler basically finished, and the information we got is that we had the goal ID goal 1 for the goal we deleted, which, as we of course know, is the wrong goal to delete. So now we could resume script execution because we're done with this debugging cycle, and simply try this again and click on the next goal and dive into the next function call here and see that here we have the same goal ID as before. So now this should be a point where we see, wait a second, if we have the same ID on two different goals on which I clicked here, that seems to be the problem why the wrong goal was deleted. So that's maybe the point where we resume script execution and then dive back into the code where we actually add goals, because that is where we set our IDs. And just by looking at that code, we of course should be able to see why we have goal 1 for every goal. So that's how we can use the breakpoints to step through our code step by step, and even inspect values which are stored in variables and so on to find out why something behaves the way it does behave. So breakpoints, and you can always clear them by clicking on them again. Breakpoints are another useful tool for analyzing your code, for understanding it, and for finding and fixing errors like that. And with that, I'll revert this to moth random toString, which of course then is an ID we can use without getting that warning. Now if I try this again, you see I don't get that warning. If I now add multiple goals, you see if I click on the first goal, I delete the first goal. So this now works, and that's another important set of tools. The debugging tools you got natively in your browser. Here I showed it in the Chrome browser, but you also have similar tools in Firefox or Safari. So we had a look at error messages, that we shouldn't panic when we read them. We had a look at other approaches we can take to find and fix errors. And we had a look at the browser developer tools. Now, let's have a look at a dedicated tool which is available for React development, which can help us with React-specific problems and which can help us with understanding our React application better. And that would be the React DevTools. You can simply search for React DevTools and you should find an entry here on chrome.google.com. They are also available for Firefox, but I would strongly recommend that you use Google Chrome if you want to work with them, because they're a browser extension which you can add to the browser. Now, I already did add them, but you can add them here with a simple add button in case you didn't add them to your browser yet. So you simply visit that page here in the Chrome extensions store, though these tools, this extension is totally free. You don't need to pay, no worries. And you simply add it to your browser. You might be prompted to restart your browser thereafter, but once you added them, here in your browser DevTools, you'll have two new tabs: Components and Profiler. Now we'll have a look at the Profiler later in the course. For now, let's focus on components. If we click on it, we see a little component tree here on the right. And that is what we're building with React, right? We're building a tree of components. So it makes sense that we see that here. And what's interesting here is that here we only see React components. Now in the browser, we got the Elements tab, and there we see the entire DOM as it was rendered by the browser. And in the end, that's just the DOM that is implied by our components. So that can also be useful for debugging our DOM and our UI. But the difference to the Components tab here is that in the Components tab, we see the actual React components and the components structure that is responsible for this UI output. And we see, for example, that we have that root app component, and it's even getting highlighted on the left, with the course input component, which has the button component, with the course goal list component with the different course goal items. We can also click on those components to get more information about them. Here, for example, we already see that a key is set, but then if we scroll down for the course goal item, we actually see a list of all props that it's getting. That includes the children prop, so the content passed between the opening and closing tag, the ID prop, the onTheLead prop, and this new prop, which we can ignore. For the onTheLead prop, we, for example, see that the delete item handler function is passed as a value. For children, we see that it's the text of the task. And if we scroll down further, we see which components were responsible for rendering this. And these components are ordered depending on how close they are. The topmost component here is the component which directly rendered course goal item. And the further down we go here, the further away that component is in the main component tree. Indeed, course goal list component did render the two course goal items, but of course course goal list then was rendered by app, which is why we see that here as well. We also see the source code where we can find information about the course goal item. And if we click on course goal list here, for example, we're taken to that component. Of course, we could have also clicked on it here. You can also search for a component here, like for item, to highlight them and find them quicker. And you can also configure what you see here. The general theme, light mode, dark mode, how it should be displayed, and in general you can play around with the settings here to, for example, display more information, less information, or simply in a different style. I prefer that style and therefore I'll keep it this way. Now what you'll also see is that if you, for example, go to the course input, you don't just see the props there, but you also see the hooks that are being used here. And you see that in there we're using two state hooks. Remember that I mentioned that useState, which we use to manage state, is a so-called React hook. And later we'll learn about other hooks as well. So this is a so-called React hook, and that's why it's showing up under this hooks section here. It's a state hook which is responsible for managing the state of course input, and here we can see and actually also change the current state. For example here, if I enter master React, you see that's reflected down there. And if I add an exclamation mark here, it's not reflected in the input, because in our code we're actually not feeding the current value back into the input. We could do that by setting the value prop, but we're not doing that here. But nonetheless, if I now add the goal, you see that the exclamation mark is part of the text that was added here. Here it is. Or here it was, since I clicked on it. So we can change the state here, and it really will have an effect on the UI. On the app component, we, for example, see our array of goals. And if I change one of the goals here, if I change the text here by adding multiple exclamation marks, that is reflected here on the left as well. So that's another great tool for playing around with your interface, with your state, with your props, and for understanding how everything is connected, and also for trying out different use cases in different scenarios. So that's the last tool I want to show you in this module, because the React Dev tools can also be really useful when it comes to debugging and analyzing your React application.
At this point in the course, you already learned a lot about some crucial core React concepts. And of course, you're going to learn even more throughout the rest of this course. But before you go there, before you dive deeper into React, I strongly recommend that you first practice what you learned, and that's exactly what this course section will be there for. In this course section, we're going to build two demo projects, two basic yet non-trivial demo projects, which allow you to apply your knowledge and to practice what you learned. Because in both projects, you'll need to work with components, state, some styling, and all these crucial core concepts we explored throughout the previous sections. Therefore, in this section here, you'll practice how to split an existing component and an existing application into multiple components, and you'll also practice how to build an application from scratch. You will practice how to work with state, how to manage and use state, and you'll practice outputting list and conditional content. Now, for both practice projects, which I prepared for you for this section here, I will give you an introduction to those projects. I'll provide you with some starting code, and I'll give you some tasks or show you how the finished project should look like. But I then absolutely would recommend that you first try solving these tasks and building those projects on your own before you then take a look at my example solution, which I, of course, will also provide as part of this section. Because by trying these things on your own first, you'll of course learn more about React, and you'll be able to confirm that you really understood all these core concepts up to this point. That being said, after every demo project introduction, I will provide you with detailed solution steps, allowing you to compare your solution to mine. And of course, whilst building that solution together with you, I'll also explain why I chose a certain approach and why I solved the tasks as I did solve them. So definitely take a look at my solution as well, but also definitely try those projects on your own first. Now, as mentioned, in this section here, we'll build two demo projects. And here's the first demo project which we'll build. An investment calculator where you can enter some data about your planned investment. For example, your current savings, the amount you're going to add every year, the expected return on investment, your time horizon, so the time frame of this investment. And then once you click calculate, you'll get a table with the results for this calculation, where you can see year by year how much interest you're going to gain and so on. This is the first example application we're going to build here, and for this application, I created a starting project, which you find attached. Of course, you also find a code sandbox link attached, in case you want to follow along there. And in this starting project, you'll find an image in the assets folder, and then some styles in the index.css file, and then most importantly, you'll find an app.js file, which includes some JavaScript code, and also some JSX code, but which doesn't work yet. This doesn't do anything. Instead, in there, I added some to-dos and some hints or comments regarding your tasks and what you might want to do with that code. And I'll provide you with more detailed tasks in just a second. But you can and should use this code as a starting point because it also, for example, contains some code you could use for calculating these investment results, the interest gained per year, and so on. I already created this code for you so that you don't have to write it on your own and you don't have to come up with it on your own. And I also essentially created all or almost all the JSX code you're going to need, though of course the data is missing in that code. It's not dynamic code, instead it has some hard-coded placeholders, and it's of course not outputting any results. We're also not managing any state yet in this component, because that will all be things you should do. And therefore, here are your tasks for this first demo project. The first task is to take this one single app component that you find in the starting code and you split it up into multiple smaller components. It's up to you how granular you want to be, and it's up to you to identify suitable components, but you should at least be able to identify a few components you can split this one single component up into. So that will be the first task. Split the JSX code and the overall app component code into multiple components. As a next step thereafter, I want you to handle some events. To be precise, I want you to handle the submit event when this form here is being submitted, and I want you to handle the click event on that reset button. You don't need to do anything yet, but you should add event handler functions and make sure that some code gets triggered as the form is submitted or this reset button is being pressed. But of course, handling events without doing anything isn't too much fun. Therefore, thereafter, as a next step, you should start managing some state. And it's of course also your task to identify the different pieces of state you might want to manage. Keep in mind that there are different ways of managing state, multiple state slices versus bigger objects, and it's totally up to you which approach you prefer and with which solution you come up, but you should identify the state that needs to be managed and you should add the code for managing that state. You should, for example, make sure that all the user input is picked up and used and available when the form is submitted. And you should, of course, make sure that all this investment data that's being derived here is also managed as state somehow. Because it's that data that then later needs to be output when the form is submitted. Now, last but not least, you should, of course, then also use that state to output some data on the screen, to output the results of this investment calculation, to be precise. For that, you should make sure that this table, which you have at the bottom here, is output conditionally, only if data is available. If no data is available yet, because no calculation has been performed yet, you should output some fallback text instead. And you also should make sure that, of course, you output all these rows of that table dynamically, one row per year, because, of course, we are deriving investment data for multiple years here. Last but not least, there is a little bonus task, because you can definitely also dive into styling and either use styled components or anything like that, or maybe at least split up this index CSS file into multiple module CSS files that belong to the individual components that are being used in the application. That is something you also might want to consider doing, and of course also feel free to adjust and tweak these stylings so that they meet your personal preferences. But that being said, this is your starting project. These are your tasks. In the next lecture, so the lecture after this one, you'll get some additional hints that can help you solve these tasks. And thereafter, you'll find my solution where I will solve these tasks step by step. But as mentioned, before you go through my solution, definitely try solving these tasks on your own and try building this application on your own first. So let's now start diving into these different tasks. And of course, I'm going to start with the first task, which is to split this app into some components. because I did provide this starting project to you. And this starting project at the moment consists of basically only one component, this app component, in this app component file. And whilst this would work and could be used here for this still a relatively basic application, it is a better practice to split your React apps into multiple components where every component has its own clearly defined task and use. And therefore here I'll start by adding a new components folder. And I would say that we could, for example, put this header code here into its own component. Of course, I also then want to put this form into a separate component. And there we could actually also be more granular and, for example, also put every input into its own component. But I'm not going to do that, but I will put my form into a separate component. And last but not least, I also want to put this table into a separate component because I would say that the table, the form, and the header in the end are the three big logical building blocks of this website here, of this web app. Therefore, in the components folder, I'll add a header folder in which I'll add a new header.js file. Then I'll add my user input folder. And of course, these names are up to you, but in there I'll add my user input.js file. And there I'll store that component that will manage this form. And then I'll add one last folder in this components folder, and I'll name it results table. And well, you might guess that in there I'll create a results table.js file. So now with these files created, I'll start in the header.js file. And there we can create a new header component function, either with the function keyword or alternatively with this arrow function syntax, about which you also learned in this course. And that's the syntax I'll use here. And then in this header component function, the goal in the end is to return this header. So this code here should be copied and should be returned here as a result. Now in this code, I'm using this logo, and this logo here is simply this app logo, which I'm importing like this, because that is how you can import images in React projects. And therefore it's now time to copy or to cut this import and move it to this header file. Now the path also must be adjusted, since this header file is nested in the header folder, which itself is nested in the components folder. And therefore from inside this header.js file to reach this assets folder, we first have to go up 2 levels like this, so that then we can dive into the assets folder and reselect this PNG image. With that, we got this header component, and in the app component, we can now replace this div here with header. And for this custom header component to be available here, you of course then also must add an import to it, where you import this header component from the components folder, there the header subfolder, and then the header file, as you learned, without a file extension. Now to see whether this worked, I need to start the development server. And for that, I first need to run npm install in this local project. This is only required once initially to install all these dependencies that are used by the project. And then thereafter, we can start the development server with npm start. And if you now visit localhost 3000, you should see a site that looks something like this. And here we also see the header again. So that worked. Now, of course, the header was only the first component. The next component I want to outsource, or the next code I want to outsource, is this form code. So all that JSX code between the form tags, I'll grab it, cut it from app.js, and move it to the user input.js file. In there, we can now create a new user input component function. And of course, as always, export it as well, and then there return this form, so that this form.js Xcode is returned by this user input component. That's the next component added. Of course, it should also be added here then, to the app component like this. And of course, again, for it to be available here, you should also add the respective import to the top of your file. Now, as a last step here, I'll get rid of these comments and then cut this table to also put this into a separate component. So here in results table.js, we can create the results table component function like this, export it as we always do, and then here return this JSX code, this table JSX code. With that back in app.js, we can use results table like this, and of course make sure that it's getting imported in order to be available here. So with that, if we save this, we should see the same web page as before, which of course doesn't work yet, but we also see that all the components are still there, that all the JSX code is still leading to some output being shown on the screen. And therefore, we already completed the first task here, which was to split the app into components. Now, as mentioned, you could of course be more granular. You could, for example, create a separate table head and table body component. You could create a separate component that maybe includes this paragraph that wraps the label and the input. You can do all these things and definitely feel free to do that. For this exercise application here, I am happy with the current split, and we can therefore now move on to the next task. Now the next task is to handle the submit and reset button click events. And for that, of course, we'll need to make sure that whenever these events occur, some code of our choice is getting executed. So therefore, I'm back in the user input.js file, because that's where I got this form. And of course, I wanna, for example, listen to the submission of that form. We can do that, as you learned, by adding the onSubmit prop to this built-in form element, to this built-in form component, which it is in the end. And then we can define a function inside of a function, which you can do in JavaScript, as you learned. And for example, add our submit handler function like this. That's one way of writing it. And we can now set this as a value for onSubmit, like this. So submit handler is passed as a value to onSubmit, and what's important here is that we don't add parentheses, because we don't want to execute this function when this line of code is being parsed. Instead, we want to pass it as a value to onSubmit, so that in the end, React internally can trigger this function here whenever this form here is submitted. Now, when it comes to handling form submissions in React, it is quite common that we want to prevent the default, which we can do by accepting the event argument here, which will be passed in automatically by React when that event occurs. And on that event object, we can call prevent default to make sure that the browser's default behavior is prevented and blocked. Because that default behavior would be to reload the page, which we don't want, because that would reload and therefore in the end restart the React application, which we don't want. So therefore, we're preventing that default so that the page does not get reloaded, and instead our JavaScript code continues to execute and takes over. And here we'll then have to do something once the form was submitted. Now I'll get back to that do something here soon, but before we do something here, I want to add another function, which would be the reset handler. Because we also want to handle the scenario that this reset button here was clicked. That's why I'm adding this reset handler function, because it's now this reset handler function that can be assigned as a value to the onClick prop on this reset button. We don't set the onClick prop on this calculate button because this button is of type submit and therefore will submit the form and therefore will lead to this event being triggered. But we do set reset handler as a value on this reset button so that when this button is clicked, we don't submit the form, but instead we reset it, and we reset all input values to their defaults. Now, of course, we're also going to add some logic for this soon. For the moment, we just added the function though and connected it to the handler. And we can simply console log reset here to see whether this works, and console log submit here in the submit handler. With that, if you go back to your website and you open the browser developer tools, you should see that if you click reset, it says reset here in the console. And if you instead click calculate, it says submit. So those event handlers are working. But these aren't the only event handlers you need to add. Instead, we also got all these input elements here, and even though we're not managing state yet, we'll soon have to manage the values entered by the user as state, and we'll have to listen to changes to those inputs to update the managed state, so to save the values entered by the user. And therefore, we can also add the onChange event to all these inputs and then define a function that should be triggered when that change event occurs. So when the user changes the value in an input. For that, I'll add a new function here, which I'll name change handler. And what I'm doing here is I'm defining one function which I then plan to use for all my inputs. So I'll set up a generic event handler function, which I want to reuse for multiple events of the same kind from different sources. For this here, in this change handler, or this input change handler, the name of course is up to you, I'll expect to get two parameters. The first identifier should identify the event source, so in this case the input for which this event occurred. The second value should then be the value that was entered. And with that, we can now use input change handler in conjunction with the onChange prop. Though we can't set it as a value like this, or to be precise, we could, but we would then not get this information. Instead, I'll create an anonymous arrow function down here as a value for onChange. And in this arrow function, I'll execute input change handler. So here we now need these parentheses to call this input change handler function. But this function will now not be executed when this line of code here is being parsed, but instead only when this arrow function will be executed. And this arrow function, since it's passed as a value to onChange, will only be executed by React whenever the value in this input changes. So therefore, indirectly, input change handler will only be executed when the input value changes. But since we now control the execution of input change handler, or to be precise, we control how it will be executed, we can now also pass some data here to input change handler. And the first piece of data, the first argument, should be this identifier of this input. So that value should be provided. And here for this first input, we could simply use current savings. So this ID here as an identifier. The second value then should be the currently entered value. And for this, of course, we can use the default event object, which will be dispatched by React and which will be passed by React to this arrow function here automatically, because that event object allows us to get access to the event target, which will be this input element, and then its currently entered value. So after reformatting the code, this is how my onChange prop and its value looks like. And this event target value is simply the value that will be provided for this parameter. On the other hand, current savings, this hard-coded string, will be provided as a value for input here. And with that, we now got this generic event handler function, and we can therefore now copy and paste onChange to the next input in line, and just update the identifier here, in this case yearly contribution, for example, and then copy and paste it again to the next input and update the identifier, which now is expected return. And then copy and paste this again one last time to this input, where the ID should be duration. And with that, we're now making sure that for change events on all these inputs, it's always the same change handler function that will be executed, but it will be executed with different identifiers and values. Therefore here, if I console log input and value like this, and I save this, you will see that if you open the developer tools again, if I type 500 to current savings, I'm getting the identifier here and then the value. And of course, the same is the case if I type 10 here into investment duration, identifier and value. So that's working. So now that we're handling events, it's time to start managing state, because that's the next task we have. Now for that, of course, we first of all have to identify the state that should be managed. And of course, as you learned, there typically isn't just a single right or wrong way of building such an application, but I would argue that we probably have some state to manage in the user input component. All these values entered by the user should be managed as state. We need them as state so that we can submit them when that form is submitted. And we also need them as state so that we can reset them if the reset button is clicked. Therefore, in this user input.js file, in this user input component, I'll use state, this use state hook, which is imported from React, to start managing some state. And now the question just is, which state values do we want to manage? And the answer is, well, one for every input, most likely. Because we need to store and use all these input values. And it now in the end comes down to your personal preference, whether you want to manage one state object with multiple keys inside of it, one key per input element, or if you want to have multiple state slices by calling useState multiple times, once for every input element. It's totally up to you, and here I'll go for the one bigger state object, which is being managed here, where I'll have one key per input element. So for example, we could add a key named current savings here to this object. Not like this though, since the dash is not an allowed character like this in a property name. Instead, you have to wrap it in quotes. This is valid JavaScript code and allows you to use property names which otherwise couldn't be used. For example, names that include such a dash. Alternatively, you could of course use camel case notation here. That is totally up to you, but I'll go for the identifier I'm also using on my input. And then we need a value for that key. And for the current savings, so in the end our starting amount of savings we have, we could start with a value of 1,000 or 10,000 or anything like this. Here I'll go for 10,000. Now that's of course not the only key. Instead, we also have this yearly contribution input, which in the end is about getting that amount that will be added every year. And we could set this to 1,200 so that we save $100 per month. The next key value pair in this state object will be the key value pair for the third input, which is the expected return rate. So therefore, I'll use this identifier, and here we could set this to 7%, for example. And then the last key I want to manage here is for the last input, which is the duration over which we want to save. Hence, I'll use duration as a key here and maybe set this to 10 years as a default. With that, we're creating this state object, and as you learned, useState now returns an array with exactly 2 elements. And we can use array destructuring to get elements out of this array. And here we'll get the user input and then a set user input state updating function, though as you learned, these names of these elements are up to you. Now the idea now is to call set user input whenever the input change handler is triggered. Because there we want to update this state object here, and store the latest entered values in that state object. Therefore, in input change handler, we want to set our state to a new object, which of course should be based on the old object, because we don't want to discard the values that were not changing. And therefore, as you learned, you should use this function form for updating the state by passing a function to this state updating function. And this function will automatically receive the latest values, so the previously stored user input here, and should then yield a new object representing the new state. So here I'm returning a new state object where I copy my previous input state with the spread operator, so with these 3 dots here, and where I then want to overwrite the value for this one input for which this change handler was triggered. Now here we can use a special JavaScript syntax where we can set a property dynamically, so where we can dynamically access a property name by wrapping the identifier that contains the property name we want to access into square brackets, so that we don't set the property named input, but we instead set the property which's name is stored in input. So either current savings or yearly contribution or expected return or duration. So we're setting one of these 4 properties, depending on what's stored in input, to our value. That's how we can dynamically update this state object whenever the input change handler is executed. And with that, we took an important first step. Now at this point, we're not done regarding managing the user input state, though. It's good that we update it whenever an input changes, but of course we, for example, also want to update it when the reset handler is triggered, so when the reset button is executed. Therefore here we should also call set user input, and now in the end reset our state to this initial state. So we can copy this initial state and also use this here in the reset handler. Now copy and pasting is always bad or not ideal, and therefore I'll instead add a new constant outside of my component function, because it doesn't need to be recreated every time the component function executes. And I'll name this initial user input and set this to this object. And now we can use this initial user input constant here to initialize the state here, and to then reset it here in the reset handler, like this. Now in order to reflect those updated values, in our UI, we also must go to those inputs though and set up two-way binding, so that we don't just listen to changes and update our internally managed state, but so that we also pass this updated state back into the input. For that, we can set the value prop to user input, that's the name of our state. And now we need to access the current savings property here, because here we need the value for the current savings input. So with that here, with this code, we access the property named current savings, and we use its value as a value for this input. And this step can and should now be repeated for all inputs, so that here on the second input, we access yearly contribution and set this value as a value for the input. And we do the same for the third input, here for the expected return property. And then last but not least, also here for this last input, where we access the duration property. Here, since this property name doesn't contain a dash, we could also use the dot notation. But to be consistent, I'll use this square bracket access notation. And with that, all these different values are being accessed and fed back to the inputs. And hence, if we reload here, we see our initial values, and we can also update these values. And if I do update them, and I then click reset, you see that we jump back to the initial values. So now that we're gathering all that user input, we now need to find a way of deriving the results that should ultimately be output here in the results table. So we need to get this user input in the end from this user input component to the results table component. Though technically the results table component of course won't care about the user input, but instead on the calculation results. So we'll need to perform the calculation that's set up here in app.js. So in the end, put in other words, we have some state in user input, the user input values, that's the state I mean, which is received in this component, but which in the end, in transformed form, is needed in the results table component. And what do you do if you have a situation like this? Well, you lift state up. That's what you learned in this course. And actually here the app component is already configured to perform this calculation and to receive this user input state. So here lifting the state up is quite straightforward and you don't have to do a lot for it. One thing you need to do though is that in user input, in this component, you'll need to accept props. Because you'll need to accept a function as a prop, a function which you can call instead of user input, but which will be defined in app.js, in the app component. And it's this calculate handler function I mean. This should be triggered in the end when the form is submitted, though as I already mentioned here, we don't want to directly bind it to the submit event, but instead we want to call it indirectly. So for that, here in user input.js, in the submit handler, we could expect that we have a on calculate prop on this component. And of course, since it's your component, this name is totally up to you, but I'm naming it on calculate to make it clear that I want a function as a value for this prop. Because in the end, we want to trigger this function when a certain event occurs, in this case, when the calculate button was clicked. But then I call this function, which I receive on the onCalculate prop, and I'll pass my user input state to it. So that's what we have to do in the user input component. In the app.js component, we now have to set calculate handler, which does want a user input object as a value for this onCalculate prop. So in app.js, on this user input, we should now add the onCalculate prop. And if you chose a different name here, you also need to use a different name here, as you learned. And then we set onCalculate equal to calculate handler. Now calculate handler already expects to get a user input object, as it turns out, since I'm accessing a bunch of properties here. And therefore, of course, we must make sure that an object of that expected shape here is passed to onCalculate, so to the calculate handler in the end. Now, if you're using different property names in your state here, different names than I am using, you want to use those same names in this code in the app component, in this calculate handler. Because here I am trying to access the current savings property and the yearly contribution property and so on that user input object. So if you're using different property names here, you have to use those different names in your calculate handler as well. With that, though, we get all that data, and I'm just going to clean up those comments, and we'll perform this calculation here with that input data to derive the yearly results, and now we need to do something with that yearly data. So what is it that we want to do here? Well, we can now store it as state, because that would then allow us to pass that updated data to the results table. So here in the app component, we can also call the use state hook to store our yearly data, and we could set it to null initially, and then here get our results and a set results function like this. And now we could call set results here at the end of calculate handler to pass the yearly data, which in the end is derived in this for loop, as a value to set results. Yearly data. And with that, it would be that yearly data that's managed as state here in the end. Now I said could all the time, because here we can now actually also deviate and change this code, though if that's the solution you used, it absolutely is fine. There's nothing wrong with it and you can stick to it. But here we could also switch to some derived state instead. And instead of storing the final results as state, we could instead get our user input here as well and have a set user input state updating function. And in calculate handler, we can then call set user input and pass the received user input object as a value to this state in the end. And now we can grab all this data here, where we create the yearly data and go through that for loop, and cut it and delete this code here, so that we have a very lean calculate handler function, and instead add it here right inside of the app component function, like this. With that, we would be rerunning this code whenever the state of this app component changes. And that of course means that whenever we receive new user input, so whenever we set this user input state, this component function will re-execute and this code will therefore re-execute. And with that, we would have the yearly data as derived state based on that user input state, which is a slightly more elegant way of handling that, though as mentioned, if instead you went for the explicitly managed state, that would also be fine. But you should be aware of this alternative. That's why I'm showing it to you here. Now, one problem we'll have with this derived state approach here is that I'm accessing all these properties here which potentially don't exist yet, if we have no user input yet, so if this is null. Therefore, we should actually wrap this code here with a if check, where we check if user input is truthy. And if that's the case, we want to continue here. So all that code should go into this if check, so that we only try to access these properties on user input if it's not null. That's something you should do, because otherwise you'll get an error when trying to run this app. So now with that, we got the state data we need, we're performing all these calculations, and we're getting some yearly data with the details that should be output in the results table. And that's therefore now the next step, that we want to output our results conditionally, and that we also want to show a fallback message if we have no results yet. So let's now make sure that we output the results data and that we do output it conditionally, which means only if we have results. Now for that, back here in the code, I only want to show results table if we have results. Now, of course, here in this code, we could say that we have results if user input is not null. Because if it is null, which is the initial state, all this code where the results are derived will not execute. Which therefore also means that if user input is not null, this code will run and we will have some calculation results. Therefore, here we could dynamically output a fallback text if not user input. So if user input is falsy, if it's null, for example, then we could output a paragraph where we say no investment calculated yet, or something like this. On the other hand, we want to output results table if user input is truthy. Because if we have a user input, if it's not null, we'll have performed the calculations here and will therefore have a result. And with that, if we save this, I initially got this text, and the styling of this text is a bit off, but I'll get back to this later. But as soon as I press calculate, we instead get this table. At the moment, this table only outputs some dummy data, but nonetheless, it's a good starting point. So now it's really time to pass our calculation results to the results table and to output the data in the table there. So therefore, the goal in the end is to pass this yearly data here, this array of data, to results table. Because it's this array of data that will in the end contain all the data that should be output in the rows of that table. Because this yearly data will contain one entry per year, and that's exactly what we want to output in results table. Therefore, I'll add a new prop to results table, and I'll simply name it data, though the name of course is up to you. And the value I pass to this prop are my yearly data. So the yearly results data I'm deriving here. That's passed under that data key to results table. In results table, we now want to output that data. So here we should accept props, like this. And then here we want to dynamically loop through these rows. So for that, here we can use curly braces, as we always do. And then access props.data and map our data to these table rows. So here we'll get the data per year, because again, as mentioned, yearly data here will in the end contain one entry, one object of this shape per year, since we're calculating our returns for all these years. And therefore here we'll get the data for a year, and we want to return an updated table row. So that's what we return in map here. And in that row, we now, for example, want to output the number of that year. And for that here, we can access yearData.year. Why yearData.year? Because in these objects that are passed to yearly data, we'll have a year key which is the current loop iteration index plus 1, so that we don't start at 0 but 1 for this year identifier here. In addition to the year identifier, we'll have the interest gained in a year, the savings at the end of that year, and the yearly contribution that was added in that year. So the amount of money that was added to our investment in that year. In the results table, we therefore can output the number of the year by accessing year_data.year. For the total savings at the end of the year, we can output year_data.savings end of year. That's this key we have here. For the interest gained in that year, we can output year_data.yearly interest. Yearly interest is another key we have here. Now for the total interest gained, it will be a bit more difficult because here we'll need the year data and there the savings at the end of the year minus our initial investment, which we don't have here yet, we'll add it soon, minus our yearly contribution times the number of years we've been contributing yet. Now for that, at least we have the yearly contribution here. So we have year_data.yearly contribution times year_data.year, because we're making this contribution every year. And since here we want to get the total interest we gained, we have to deduct our initial investment and the ongoing investments we had every year. So therefore it's now the initial investment that's missing, and that data is not part of this yearly data array, but it is part of this user input. Because that user input, which is coming from that form, has the current savings key. And the current savings in the end are our initial investment, the amount we initially invest. Therefore in app.js, we have the current savings in that user input object, and we can pass that as a prop to results table. There we can add the initial investment prop and set this equal to user input, and then there the current savings. That's our initial investment. And we're now making it available through the initial investment prop in that results table component. So in results table, we now can deduct props.initial investment here from the savings at the end of the year, and also deduct all our yearly contributions to get the total interest gained. Now the last thing I want to output here is the total invested capital, and that in the end is our initial investment plus all our contributions. So basically everything except for the interest we gained over the years. And with that, we're outputting all that data. And therefore, if we now reload this and we click calculate, we get a table with some data in there. Now we're also getting a warning in the console, a warning you should already know from the earlier course sections. And of course, the formatting is a bit off. Now we'll take care of the formatting soon, but before we do that, I want to get rid of that warning by adding a key prop here to this table row. The key should be a unique identifier, and here I'll simply take year_data.year, since that will be unique for every year and therefore for every row. So with that, if we save this, reload and click calculate, at least this warning is gone. Now we can work on the formatting. Now when it comes to formatting these numbers as currencies, I gave you a little hint in that hints lecture earlier. You can use a built-in JavaScript feature to format those values. You can create a formatter by using the incl number format constructor, which is built into JavaScript, which in the end gives you a formatter utility object that provides a method to format numbers as currency, for example. Now again, this code was provided as part of the hints lecture, and you can therefore, of course, directly copy it from there. This formatter can then be used to format that data. For example, the savings at the end of the year can now be formatted by using formatter.format and passing the savings of the year as a value. And I'll do the same for the yearly interest gained, and also for the total interest gained. So I'll wrap this calculation here with format. And I'll do the same for the total capital invested, like this. And that's how we can format all these numbers, and therefore they now look much nicer. And speaking of that, with that we can tackle the last task, the bonus task I gave you, and we can work on the app's styling, or how those styles are being applied, to be precise. So let's now work on the styling. And of course, in general, the app is already styled and, in my opinion, looks quite decent. So I'm not really talking about changing the styles, also because this, of course, isn't a CSS course, but instead the goal is to change how the styles are applied. And there actually is one place where the style should be changed, and that's here for this fallback text. This doesn't look that great. Now, to change that style here, I'll use an approach which you typically won't use too often when building React apps, but which is absolutely fine for this simple use case. I'll add some inline styling to this paragraph. As you learned, you can do this by adding the style prop, and then you set this to an object. That's why you have double curly braces here, not because it's some special styling syntax, but instead because the value that's passed to the style prop here is a JavaScript object, which is created with a pair of curly braces, opening and closing. Here we can then target all these different CSS properties, for example, text align, which I'll simply set to center here. And with that inline styling added here, this fallback text is now centered. But that's the only new style I want to add. What I want to do instead now is I want to break up my existing styles, which I have in the index CSS file, and use CSS modules to apply them to the different components. Now, of course, that's absolutely not something you have to do, but something you can do to make your CSS code more manageable, and something I will do here as an exercise. And therefore, I'll add a header.module.css file, because as you learned, that's how you can use this CSS modules feature, by adding CSS files with names like this. And I'll add a results table.module.css file and a user input.module.css file. And now we can go back to index CSS and start with the code that belongs to the header. Here I'll simply grab the header related CSS rules, cut them, and add them to the header module CSS file. Now, to make sure that these styles still get applied, we have to go to header.js and there import those classes from /header module.css. And then here, instead of adding the class name like this as a string, we now have to add it as classes.header. With that, if you save this and reload, you should get the same look as before, but now we put the header related styles into this CSS module file. And of course, I'll do the same for the rest of this app as well. For that, I'll continue with the user input related styles by grabbing this form rule here, the input group rule, and all these other rules that are related to the form, including the button rules, like this. cut them and add them here to userinput.module.css. And here this should actually be dot button hover. And with that, in userinput.js, we of course also have to import classes from userinput.module.css. And now here on the form, we apply classes.form like this. Here for the input group, we apply classes input group like this. Since it contains a dash, we have to access this property like this. The dot notation won't work for a property name with a dash. And then further down in this form, or actually for all divs here that wrap multiple inputs, so also for this div, we have to use the same class name, input group. And then further down in this JSX code, here we have to use classes.actions. And then for the button alt, we have to use classes button alt. And for this button, it's classes.button. With that, if we save this, again, it's the same look as before, but now we're using CSS modules. And therefore, last but not least, I'll also cut all the result-related styles and remove them from index.css so that in there, only my basic page styles remain. And I'll go to results-table.module.css and paste in those result-related styles. And then in results table, we can import, and we should import classes from /results-table.module.css and replace this string class name here with classes.result. That's the only class in here. And therefore, with that, if we save that and we reload, we get the same look as before, but now we're using CSS modules. So at this point, we completed the first practice project. We built the first demo application in this section. But as mentioned, there will be 2 projects in this section so that you have more opportunities to practice what you learned. Now, the next demo project we're going to build doesn't look too fancy, but will actually come with a couple of nice features, which again allow you to practice building components, managing state, outputting conditional content, and so on. Because in this demo application, users will be able to enter some data about them, to be precise, their username and age. And then once the data is confirmed, the user list is updated and output below the form. But, for example, if you enter invalid data by submitting an empty form, an error modal is shown instead. So this overlay with an error message is shown instead. And this overlay can then also be closed by clicking the OK button or on the backdrop. This overlay should also not just open up if no data was entered, but for example also if an invalid age was entered. To be precise, if a number smaller than 0 was entered. If valid data is entered, another user is added to the list though. So this is the next demo project, and for this project here, you therefore essentially have the following tasks. You should start by building some core components. For example, add user component, which contains this form. You should then, of course, also again start managing some state, like that list of users, for example. And you should, of course, also output that list of users and also, if needed, this error modal, which should be shown conditionally if invalid data was entered, to give the user who's using this website some feedback. Now, attached to the next lecture, you'll find a new starting project, which you can use as a starting point. But this will then be a pretty empty project, because in this upcoming exercise here, unlike in the previous exercise in this section, I want you to try to really build everything from the ground up. And therefore, of course, chances are high that you're going to come up with a pretty different solution than I'll do, but that's absolutely fine. This section here is about practicing what you learned after all. Nonetheless, starting in the next lecture, I will show you my possible solution step by step, and I will show you how I solved these tasks and built this demo project. Attached, you find a simple starting project, basically a pretty empty React application with an empty app component. And once you downloaded and extracted the attached file, you just need to run npm install to install all dependencies, like the React library. And thereafter, once you ran npm install, which I already did here, you run npm start to start this application. And you'll be greeted by such an empty screen because currently there's nothing inside of app.js, nothing inside of our app component. Now, in the application which you saw in the last lecture, I want to have a couple of different areas, a couple of different components. We had that component where we could enter our name and our age. We had that error modal, that error overlay component. We had a button to submit this and to confirm that we saw the error in that error modal. And we, of course, also had that list of users. Therefore, I'll start by roughly planning out the components we'll have. And for that, I'll add a new components folder in which I want to store those components. And I'll add a UI folder for general UI components, which we'll have, like the button. And in components, I'll also add a second folder, and that will be my users folder for all the user-related components. And now in there, we can start adding component files, and I'll start with that component that allows us to add a new user. Hence, here in the users folder, I'll add a new add user.js file, which should hold the logic for us to add a new user. Now, in there, I want to have a React component. So, of course, we have to import React from React, as you learned, because we're going to use some JSX code here. I'll then add my add user component using this function syntax, which we can use in JavaScript, an arrow function stored in a constant. Of course, as I mentioned before, you can also add a function like this. Nothing wrong with that, but I'll go for this approach. And I'll export this as my default so that we can import that component, that function, into another file and use it there. Now, inside of add user, I, in the end, want to render something on the screen which allows the user to enter a name and an age and have a button to confirm all of that. Therefore, in here, I will add a form, let's say, and inside of that form, I want to have a label where I say username, and of course, that should all be returned, so let's wrap it into brackets and then put a return statement in front of it. So there, I want to have a label, and I want to have an input, where the user then is actually able to type that username. And that input will be of type text because I, well, expect some text there. Now for accessibility, we can also add an ID here, username. And then on the label, we would add the for attribute normally. Now for, just like class, is not a name that is available in JSX because these would be reserved JavaScript names. And therefore, it's HTML4, actually. That's the prop name for assigning that for attribute to a label. And with that, we connect it to that input. And that's important for screen readers and so on, so that they understand which label belongs to which input. So we got that. Now, I also need another pair of label and input for the age in years, let's say. And here the type will be number because I expect to get a number here. Something like 31, 18, 25, and so on. Now I'll name this age, I'll give it an ID of age, and therefore the HTML4 prop here also has a value of age. And with that I got these two inputs. Now below those I want to have a button of type submit, which will basically submit that form. And here I have add user as my text. So that's a straightforward form. Now on the form here, I'll add the onSubmit prop
to specify a function that should be executed when that form is submitted. And therefore here I will actually add a new function inside of the add user component function, and that's the, let's say, add user handler function. Now here I expect to get my event object, and I will call event prevent default to prevent that default, which for the submission event is that a request is sent. I don't want that default, hence I prevent it here. And now we can connect onSubmit here to add user handler by passing add user handler like this to onSubmit. Important, as I explained before, don't add parentheses here. This would immediately execute add user handler when this line is parsed. Instead, I just want to pass a pointer to that function to the onSubmit prop so that the form component internally can use that function when it needs to use it, i.e. when that form is getting submitted. So with that, we got this add user handler here. Now let's go over to app.js and let's import it here. So I import add user from ./components/users/add user. And here in the div, we can then add user like that. That's how we can add this component here. And if we now save that and go back, we should see this relatively ugly but working component. I can click add user and the page is not reloading, which proves that this form submission is effectively handled and the default is prevented. So that's the start. Now, some styling would be nice because that doesn't really look the way I want it to look. Now I'll start in index.css. There you got some basic styling. I'll go to the HTML element here and add a background styling of 1f, 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 like this, and this will give us a nice dark grayish background. Now I also want to wrap this username and age into a card, you could say, into a container with rounded corners and with a white background. And that's therefore something we'll build in the next lecture. Of course, feel free to try this on your own, build such a wrapping container, maybe already with the right styles on your own, and in the next lecture, we'll build it together. So let's build this card component, which I want to have around my form together. So here in add user, I want to be able to wrap this in a card component, which doesn't exist yet, like this. And that should apply a nice styling here to this form. For that, I'll go to the UI folder and in there add a card.js file. Now in there, I'll create a pretty much standard React component. So we import React from React. We then have card here, which gets props, and we export this as our component. Now, the card component can be fairly trivial. I want to return a div, let's say, and inside of that div, I want to output the content which this card component is wrapped around. So when I wrap card around my form here, this form should of course be output inside of the card. So the card component here should output what's passed between the opening and closing tags of card. And you learned that you can access this content on the special children prop, like this. You put that between curly braces because it's not JSX code, it's a JavaScript expression that should be evaluated inside of the JSX code. And props children will give us that content which is passed between the opening and closing tag of the card component. Now, I will also assign a class here so that we can style it. And now I want to use CSS modules here. You don't need to use that. You could use styled components. You could use regular CSS classes and make sure that you don't repeat class names. But I will use CSS modules. And therefore, I'll add a card.module.css file here where I can specify my card styles. I will add a card class in there, just like this, a normal CSS class. And give it a background of white. Whoops, that should be background. Give it a box shadow of 0, 2 pixels, 8 pixels, RGBA 0000.26, which will add a little bit of a drop shadow to the card, and a border radius of 10 pixels here for rounded corners. Now in card.js, we can import this. Here we can import ./card.module.css. And you learn that for CSS modules, you now have to alter this import a little bit. This import would be right if you have a non-module file, if you used regular CSS. But if you want to use that CSS modules feature, you have to import something, for example, classes, from that file. And now here on class name, we can assign one of the classes we have inside of the CSS file. In this case, we of course have only one class, that's the card class. So we can just access classes.card here. And this will assign this generated unique class name to that div. And with that, the only step that is left to have that finished card and to use it is to go to the add user component where I want to use that card and import it here, because you always need to import what you want to use. If you have a component in a different file and you want to use it in this file, you have to import it from that other file. Otherwise, JavaScript and this React build process here can't make a connection between this file and the file in which your component is defined. So here we can therefore import card from ... to go up one level, so to go out of that users folder into the components folder, and then into UI, and then to card. And you omit the file extension here for JavaScript files. With that, we're importing card, and if we now saved it, it should compile fine. And this looks a little bit nicer, but of course it's still not the final look I want. Now, to get that nicer look, attached you find a CSS file. To be precise, you find the adduser.module.css file. And you can simply drag and drop that. So download it and then drag and drop it into your users folder next to the add user component. This file includes a couple of styles which will help us make this look nicer. Now to use this file, we have to go to add users, to the add user component. And besides importing the card here, we can now also import classes from that newly added CSS file. So from the adduser.module.css file. For non-JavaScript files, you need to add that file extension here. And now to apply that, I want to go to my card and actually add the class name property here and add classes.input. The input class is defined here in the CSS file, and with that we can add it. But now there's one important thing to note. Of course here card is our custom component. It's not one of those built-in HTML components. And therefore, since it's our own component, it only has the props, or it only is able to work with the props we use inside of that component. Now, these default HTML components like form, label, input, divs, and so on, they are all pre-configured by React to, for example, work with the class name prop and to then apply a fitting CSS class to the underlying rendered HTML node. Now, for our own component, it of course does not know what to do with the class name prop because it's just our own component, not a built-in HTML component. So we have to go to our own component and make sure that we accept an incoming class name prop and that we do something with it. Now, what do we want to do? In the end, I want to make sure that the CSS class we're applying to the div with the help of class name on that div, that the classes applied to the div reflect both the card class, which we already are applying, as well as any potentially incoming classes on the class name prop of this card component. So that any class I add here on the card component when I use it is in the end applied together with the card class to the div which is rendered by the card. So I want to apply two CSS classes, one coming from the card module CSS file and one coming from outside, from the props, potentially coming via props. And we can easily make this work. We can add a template literal here as a value for class name on the div, and then inject something dynamically with this $ curly brace syntax, and add classes.card. That is what we added before as well. But now I'll inject a second value, and that's props.className. Now it's your component, so you could use any property name here. It doesn't have to be class name here on your own props object. I'm just using class name here as well, so that we're able to use our own component just as we work with regular HTML components. I can now set class name on my own component as well, because I'm accepting and using the class name prop here inside of the component. If we would have chosen a different name here, like CSS class, for example, we would need to use that CSS class name here as well when we use the card component. But again, I want to have one API, one way of assigning CSS classes, and therefore I will use class name because that's also what React uses for its built-in HTML components. And with that, we're merging an external class with our internally defined class here. And if I now save this now looks much nicer thanks to the styles set up in the add user component. And with that, this looks not too bad. Now let's make sure we also have a nice looking button. And for that, you actually find a file attached to the next lecture, the button.module.css file, and you can use this to try and build your own button. Otherwise, we'll build and use that button together in the next lecture. So, time for a button. Just like a card, a button is a default UI element which we're going to use in different parts of the application. Therefore here I'll add a button.js file, and I already mentioned it, attached you find a button.module.css file, which I'll again download and drag and drop into that UI folder next to the button.js file. Now inside of the button.js file, we can import React from React because we're going to write some JSX code. We can import classes from button.module.css already. And we can then define our button constant, which is our functional component, and export this as a default. And now in here, I simply want to return the built-in button component, but of course with my default styling applied and with some configuration options. To start with the styling, I'll add class name and point at classes.button. Because in the button.module.css file you'll find that button class, so we can use it thanks to CSS modules to apply a little styling here. I also want to make sure that the type of the button can be set, and I want to make sure it can be set from outside, so from the place where we use our custom button component. Therefore, the value assigned to the type prop on the built-in button component will be dynamic, and I will simply access props.type here, but also provide a fallback in case that should not be set with the OR operator. The alternative is button. So if props type is undefined, this button value will be used as a fallback type for the built-in button. Now, in addition, I'll add onClick, and here I expect to get a handler function via props on my own button component, so I'll simply forward this to props onClick. Now that name here is totally up to you. You don't have to name it onClick, but again, I want to make my own button basically usable like the built-in button, and therefore I use the same naming. So I will have an onClick prop on my button component, and any function received there is just passed on to the built-in button component through its onClick prop. And last but not least here, I also want to be able to output some content between the button tags, and I expect to get that content between the tags of my own button, and therefore we use the special children prop here. That should be all. Now we can go to add user, where we have a button, and use our own custom button. And hopefully I can now just replace built-in button, which is lowercase, with my custom button, which starts with a capital B, per the convention that your component should always start with capital characters. And we now just need to import it, because as I mentioned, you need to import all things you want to use from other files. So here I'll import button from, going up one level, UI, button, like this. And if we now save that, we got this nicer looking button which should work just like the built-in button, because in the end it just wraps the built-in button, of course. But that's the idea behind all React components. In the end, you always compose them all from the built-in HTML components, but you structure them in a certain way and maybe attach certain logic so that you have your own components. And with that, that looks quite well. Now let's make sure we actually fetch user input, and we then kind of start rendering a list of users below that input form here. Let's continue with this app, and let's make sure we actually fetch user input so that we can then, in the next step, also render it as part of a list of users. We got our add user component here with the add user handler, which is triggered when the form is submitted. And now the goal is to collect the two entered values, the username and the age, and utilize them here. Now to collect the values, we can use a technique we already learned about in the last modules. We can use state management in React to update the state with every keystroke and hence save what the user enters in such a state variable, which is then managed by React. For that, we need to import the useState hook here inside of the add user component, and then we need to initialize it. For that, we call useState, and we can define the default, the initial starting state. And since I want to manage one piece of state for every input, the starting state will basically be no input, so an empty string. And then I have my entered username here, and my state updating function set entered username. Now, in case you're not sure what this syntax means, make sure you go through the respective lectures in the basics module. This is a JavaScript syntax which is called array destructuring, and we use it because useState always returns an array with exactly two elements. And with this syntax, we're pulling these elements out of that returned array, and we store them in separate constants of the name entered username and set entered username. And I chose those names for those constants because the first element of that returned array is the current state snapshot, and every time this component re-renders, which it, for example, does when the state is updated, this constant will hold the latest state snapshot. And set entered username, on the other hand, holds a function which we can call to change that state and to then trigger such a re-render cycle. So now we need a function which is triggered on every keystroke of that input here. And for that, I'll have my username change handler function, for example, where I get the event object because we'll listen to a default DOM event, and such events will dispatch objects with more information. And we can bind this to input here through the onChange prop, which then will tie this to the change event listener. So here I pass my username change handler, and therefore this function will be triggered for every keystroke in the input element down there. And now here I will call set entered username, and I want to set it to what the user currently entered, and we can get that entered value with the help of that event object. Because there we can access the target of the event, which is the input, and then the value property of that input to get the currently entered value. Now I'll just copy that and repeat that to also have an age change handler where I call set entered age, because that's the second piece of state I now want to manage. Hence I'll duplicate this as well. And here I have my entered age and set entered age. And with that, we're updating the entered age on every keystroke. We of course also need to make the connection down there. So age change handler. And now we got both the username and the age stored. Now in add user handler, we can therefore now console log entered username and entered age. And entered age. Like this. And if we now save everything, we can go back, open up the developer tools here and go to the JavaScript console and maybe enter max here and 31. And if I click add user, you see that output here. Now at the moment, we can also submit an empty form, like an empty age field, but that's something we'll fix later. Generally, fetching that data works. Now as a next step, let's make sure that when we click add user, we actually reset these inputs so that both input fields are empty again. And let's make sure we also have some basic validation, which simply makes sure that nothing happens, that we don't print this information here if one of the two input fields is empty or if the age is smaller than 1, if it's equal to 0 or smaller than 0. So that's something you can try on your own next. We'll do it together in the next lecture, of course. Let's implement that resetting and validation logic together. And let's start with resetting. Resetting generally is easy. Here in add user handler, I just want to call set entered username and set this again to an empty string, and do the same also for set entered age. Now with that, I reset my states to an empty string once I logged the state snapshot here. Now, what you'll see, however, is that if I save this and I enter max and 31, we get the output here, but the inputs are actually not cleared. So setting our state snapshots to empty strings doesn't seem to work here, right? Well, it actually does work, but one problem we have is that we don't reflect our current state in the input. That's not a problem as long as we don't want to change it from anywhere else than user keystrokes, but here I want to change it when the form is submitted. So I want to feed the current state for entered username and entered age back into those inputs. And we can easily do that. These input elements have value props, and we can set them to values which will then be reflected in the inputs. And I can set my value of that first input to entered username, and the value of the second input here to entered age. And now I'll reformat that, and with that we'll have inputs which actually reflect the current state snapshot, even if it's not changed through a keystroke, but like here, upon a form submission. So if we now save that and try again, you'll see that now it's cleared. So that's step 1. Now for the validation. For the validation here in add user handler, I want to make sure that all this code here only executes if we have valid inputs. So if neither the name nor the age is empty, and the age is also not smaller than 1. For that we can add a if check here, and check if entered username trimmed is actually empty, which we can check by checking its length. Trim will remove any excess white space, and if it then has a length of 0, we know there is no character in that string, it's an empty string. And if that's the case, or if entered age is empty, so if we have the same check here, then I want to return. For now, I'll not do anything else. If I return here, then this code is not going to execute because return statements finish the function execution. Now I also want to check for my age input value, not just if it's empty, but also if it's not empty, if it's maybe smaller than 1. So I'll have another condition here, another if check, where I check if entered age is smaller than 1. And if that's the case, I also want to return. Now here's one important thing to keep in mind. Entered age is actually a string, not a number. We initialize it to a string here, and anything that's entered into an input is always retrieved as a string. That's just how JavaScript and the DOM and so on works. So we have a string here. Entered age is a string, not a number. Now I'm comparing it to a number here, and generally that should work in JavaScript, but to be super safe, we can force a conversion of entered age to a number by adding a plus here. And with that we ensure that, well, it is a number. With that, if I now save this, you will see that if I click add user, we now got no log here on the right. If I enter max 31 on the other hand, we do get a log. If I enter max and the age is empty, I get no log. And if I enter a negative age, let's say, I also get no log. So our validation, our basic validation here seems to work. Now we'll take care about the error modal later. For now, let's make sure that for the cases where we do get valid inputs, we actually take those inputs and we store the different users in a list, which we then render below the input field. Now again, you can try this on your own. Otherwise, we'll build this together over the next lectures. So let's tackle our list of users next. Now, the first important question is where do we want to output it? And the second question that depends on the first one is where we then actually want to manage our list of users. So where do we want to output that list? We get the user data here in the add user component, and technically we could simply add more HTML code in that component to also render a list. Maybe here, unordered list below the form. We could then manage our list of users with use state in here in add user and output it down there. That is something we could do, and technically that would absolutely work. But by the way I'm saying this, you already hear that this is probably not how we're going to do it. The idea in React really is that you work with a bunch of components, that you have small, isolated pieces of HTML code and logic where every component really has its own task, its own responsibility, you could say. And therefore, you want to keep your components small and focused. You could certainly argue that a component that fetches user input and then outputs this as a list is focused enough, but I would argue that it's better to have one component that fetches user input. That's this add user component, which we already have. And then we have another component that is responsible for outputting the list of users, so that we split the outputting and the fetching logic into two different components. And therefore, I'll add a brand new component, the users list component, like this. And here, the users list component should be responsible for, well, outputting my user data. Therefore, in there, of course, we're going to write a React component. So let's import React from React so that we can use JSX code. And then here we have users list. We get our props here. And we, of course, export our component here so that we can use it in other files. And then here, I want to, in the end, return an unordered list where I want to go through a list of users, which I, well, need to get in some way, and output a couple of list items for every user. So one list item for every user. How should this work? Well, I think it makes sense to assume that in the users list component, we rely on props to get our actual array of users as data. So here between the unordered list, we could actually use props, let's say users. It's your component, so it's up to you which prop name you expect here. I expect to have a prop property which is named users, and that should hold an array of user data. So we can use the map method, which you learned about in the lists and conditionals module, to map that array of users to an array of JSX elements. So to transform our user data to JSX elements, which then are rendered onto the DOM. So map executes a function on every item in the user's array, and we'll get that item as an input. Since it's an array of users, I'll name that single item user and write an anonymous arrow function here. And then in this anonymous arrow function, we return a JSX element for every user of that user's array we expect to get on this prop. So the element, the JSX element which I want to render, is simply a list item here. And inside of that list item, I want to output the user name. Let's say we expect user to be an object with a name property. Then we could do it like this. And then thereafter, maybe in parentheses, and that's just text here, not a special React syntax. So between this parentheses text, I want to output, let's say, user.age years old. So my expectation here is that users is an array of user objects where every object has a name property and an age property. Why can I expect this? Because we're the ones creating this app. It's up to us to decide how we want to manage our data, and I want to manage an array of user objects where every object has a name property and an age property. So with that, we have the logic in place to output our users. Some styling would be nice, and for that, I first of all will wrap this list in a card. So I want to have that card component look here as well. So I'll import card again from UI card. And we need to import it here, even though we already imported it in add user, because you need to import what you want to use in a certain component into every component where you want to use it. So it's not enough to just import card once in another component. You need to import it in every component where you want to use the card. With that, we can use card here to wrap the unordered list. And now I also want to have some styling. And for that, you find a users list.module.css file attached, which you can just drag and drop into your users folder. And from there, you know the game, we can import classes from users list.module.css to use that CSS modules feature. And then here on the card, I'll add the class name prop, which I can because a few lectures ago we made sure that we utilize our incoming class name prop here inside of the card. So we can set it here, we can set that prop, and I set it to classes.user to have not just the default card class on that card component, but also my special user class. Excuse me, users, not user. With that, we got a users list component. Now we need to use it. And that leads us to the next question. Where do we want to use this brand new component? We could use it here in add user. We could use it here below the form, users list like this. We just have to add an import, and we could use it there. That would be fine, but I don't think it makes sense. It's the add user component. If some other developer would have written this component and you would need to use it in your application, would you expect that this component does not just fetch the data and add it, but that it also outputs the user data? By the name add user, it doesn't sound to me like it's going to output anything. It's just about adding something, about getting some data to add something like that. So whilst you again could technically render it here, I think it logically makes more sense to include it somewhere else. And in case you're now wondering how you should decide where to render it, it's your app in the end. You can render things where you want. You can structure your app in the way you want. And the more you work with React, the more you will get a feeling for common patterns and practices. In this course, you will also learn a lot about that and of course see a lot of examples. Here, I want to render the users list in the app component because that's also where I use add user. So to me, it makes sense that we then have users list here as a component next to add user. So we build our app here. We first have the block for getting that user data. Then we have the block for outputting the user. And below that, we might have other parts in the app, like a footer or something like that. Now to use that users list component here, we need to import users list from /components users list like this. And now we can use it, though it won't work. And actually, whilst we don't get an error here, we do see an error here. Cannot read property map of undefined. Now I told you not to panic when you see an error message, so let's see what's the problem here. It points us at the users list component, line 9, and it shows us the code snippet that's the problem. Here, it's in the end where we call map on the user's prop. This fails because map does not exist on undefined. What does this tell us? It tells us that in the users list component, here, users doesn't seem to be an array, it seems to be undefined. And undefined, of course, is a value type in JavaScript. And indeed, undefined, this value type doesn't have a map method. That is correct. You can't map undefined. Now, why is users undefined? Because in the place where we use users list, so in the app component, we're not setting that user's prop. Keep in mind, I'm extracting users from props. So I expect to get that user's data, that array in the end, on a user's prop on my users list component. So when I use this component in JSX, when I use it as a regular HTML tag in the end, I need to set that user's prop. Or I need to include a check here where I check whether it's undefined and I don't even try to map it. That would be an alternative. But here I, of course, always want to set it. So in app.js, we need to set the users prop. And this has to be users because that's the name we are retrieving here. If you picked a different name here, you need to pick a different name here too. But I'm working with users, and we need to set this to an array. And for now, an empty array, of course, does the trick. With that, we don't see a list, but we also don't see an error, and we at least see the card where the list will eventually be rendered. That was a huge step forward. Now let's make sure we actually manage a list of users. We got a list of users which we feed to users list, but it's always an empty array, and that of course is pretty static and doesn't lead to any users being output. Now I want to make sure that when we click that add user button in the add user component, we don't just log that user data here, but instead we really create a new user object with that data, and we add that to an array of users object, which we then output in the users list. And how do we do that? Well, for that we need this concept which was called lifting the state up. We need to manage our list of users in a place where we can get both access to the add user component and, well, get notified when the add user button was clicked, as well as where we got access to the users list component to feed our users array into it. And we don't have access to users list inside of add user, for example. So managing our users list state here would be wrong, our users array. Users list component sounds like the right place because there we need that list, but there we don't get access to the added user data. That add user form is out of reach here. And actually we already configured this users list component to work differently and to get the users data from outside via props. Because that's the place where we want to manage our state. We want to manage it in the app.js component because that's the one component above both add user and users list. It's the nearest component above those two components which has access to both components. And therefore we lift the state management up to this app component. So we want to manage our users array here, and we do this with the use state hook, of course, because it's state of this app, and when that state data changes, the app should re-render. And that's exactly what use state and the state managed by it does. And therefore here we call use state instead of app, and we initialize this with an empty array. Now, as you learned, use state always returns two elements, so we can use array destructuring, and we got our, let's say, users list and a set users list function. And it's now the users list which I want to forward to the users list component. With that, it's still an empty array, but we have a function that allows us to change that array, and then that change would trigger that app component to be re-rendered, and hence the users list component would be updated as well, because it would also be re-rendered since it's part of the app component. So now the missing piece is that when we click the add user button, and hence the add user handler in the add user component runs, we forward the entered username and the entered age to the app component. And we do this with props as well. You learned this as well. We can add a prop here on add user, and we can name it however you want. For example, on add user. And I just use this on something convention because in the end it will kind of work like an event. Now we'll handle it fully ourselves, but in the end it is like an event. When that add user button is clicked, which ultimately happens upon a click on the button, surprise, surprise, then a function which we pass to on add user should be triggered. It's a function we have yet to define, and we can define it here, the add user handler here in the app component. And that's a function where I actually expect two arguments, the username and the user age. And you can name these parameters however you want, of course. I expect to get that data, and with that data, we can create a new user and add it to our list here by calling set users list and then updating the state. Now here, I want to update the state by taking the old list and appending a new element to it, And as you also learned earlier, when your state update relies on the previous state, you want to use an alternative form of setUsersList. You want to use that function form where you pass a function to setUsersList. And that function will automatically get the previous latest state snapshot when React performs that state update here. And therefore, I'll name that privUsersList. The name is up to you. And you then should return your new state snapshot in the body of this function you passed to setUsersList. So here I'll return an array, a new array, where I first of all copy all elements from privUsersList. And that's the spread operator, which simply pulls all elements out of that array and adds them as new elements to this new array. And then I add one new element at the end. I add a new JavaScript object here, which should have a name field. Uname is the value we store there, and a age field, which stores UH as a value. So the two values we get as parameters here. And with that, we create a new JavaScript object for every user, and we add that to our users list array. And now we just need to wire this up. Add user handler is what I pass to the onAddUser prop here on my addUser component. And now inside of the addUser component, we need to utilize this onAddUser prop. So here in addUser, in the addUser handler there, so inside of the addUser component now, instead of console logging, I will call props.onAddUser. And I'll execute it as a function here because I know that what I get as a value on that prop will be a function. Because we're passing a pointer at addUserHandler to onAddUser, and addUserHandler is a function. So we can execute it as a function inside of the addUser component. And now we just have to forward our two pieces of data, the entered username and the entered age, which we got stored in this addUser component. And with that, we're forwarding that entered data to the app component upon every click on the addUser button here inside of the addUser component. And I know that's a lot of addUser and user, but that's what this app is about in the end. And I want to use names you would realistically also use in real apps. So with that, this function is triggered, and if we now save everything, we should be able to enter max and add a user. Now we're getting a warning here. We'll fix this in a second, but you can tell that this generally seems to work. Now what about this warning? You should know what's causing this, and you should know how to fix it. So here's a quick second for you to pause the video and fix it on your own, and then we'll fix it together. So, do you remember what's causing this? It's a warning thrown by React, and in the end it tells us that every child in a list should have a key prop which has a unique value. React needs this to efficiently update list items and re-render them efficiently. Now we got only one list which we render in this whole application, and that's inside of the users list here, this part. We create a bunch of list items here, and that's exactly the thing that should have a key prop, because it's the item you repeat. So here we should add a key prop, and that in turn should hold a unique value. So something like G1 here is not valid because that's hard-coded, and the same for every list item that's being created. Instead, I think it makes sense that in the place where we create a user, we don't just create a user with name and age, but we also give it an ID. We give it an ID, and that could be math random toString, some pseudo-unique ID. Now every user has an ID that is roughly unique, and inside of our list, we can now utilize this ID field so that the key is set dynamically to user.id. And that ID is now unique for every user. So if we now save this and we retry this, we no longer get any warnings here because now this works as it should. And with that, we're almost done. The missing piece is that modal. Now it's something we haven't built before, but even though it might seem totally different because it's an overlay on the entire page, it's actually not too far away from what we built thus far. So definitely give it a try on your own first, and thereafter we will learn how we can build such a modal together. So we want such an error modal. Now a modal is simply this overlay box, and for me that's a UI element we could be using in different parts of the app. This of course is a trivial app that has only one part, but we're always thinking from the perspective of potentially bigger apps. Therefore, I'll add it in the UI folder because such an error modal could be a reusable UI element. So I'll add my error modal.js file in there. And in that file, we of course import React from React. We got our error modal here, which gets props, and we export this like that. Now that's the first step. Now, the second step is, of course, to fill that with some life. And generally, it's totally up to you how you want to structure your modal. I actually want to reuse that card. So I'll import card from card like this and use this as a wrapper for the entire modal. Because I like that rounded corners look and so on, I want to use that therefore. Now, inside of that card, my modal should have different sections. I want to have a header with the h2 tag where we actually can output some title. Now below that, I want to have a div which holds my main content, and in there a paragraph with the error message I want to display eventually. And below that, a footer. Now in that footer, I want to have a button which we can click to close the modal. So for that, I'll import button from ./button to also reuse this component. And this shows this reusability of components. We're using the card in various places of the app. We're using the button in different places of the app. And we only defined these components and their styles once, and we can build our entire UI with these reusable building blocks. That's really the heart and the core idea, or one of the core ideas of React. So we got the button here, and hence in the footer, we can add such a button and say OK or something like that on it, so that this is our close the modal button in the end. Now, between the h2 tags here, I want to have some title, and of course that modal should be configurable from outside. I don't want to hard code the title and the message into this component. It should also be reusable, so that we can use it in different places of the app to show different error messages. Hence here I output something dynamic between curly braces and use, let's say, props.title. Again, it's your component. You can use any prop name you want here, but I expect to get a title prop which holds the text which should be output here. Now between the paragraphs, I want to output props.message, so that we also expect a message prop which, well, holds the message that should be output here. And I also want some styling. For that attached, you find the error modal.module.css file, and you can again just drag that into your UI folder next to the error modal.js file, and then import it here. Import classes from /error modal.module.css. Because I'm also using CSS modules here to have unique class names, and there are a couple of classes that should be attached. For example, here on the card itself, I want to add the classes.modal class, which is one of the classes defined here in the CSS file. In addition, on the header, I want to have the classes.header class, and on that div that surrounds the paragraph, I will add the classes.content class. On the footer, we'll also add a class, and that's the classes.actions class. And these are all CSS classes predefined in that CSS file. With that, we'll have a basic modal, and we can already see that in action. The question is, where do we want to render it? As part of which component? And you can actually argue about that. You can argue that it should be rendered inside of add user, because ultimately it will be this component that will trigger the modal. You could also argue that it's a general overlay over the entire UI, and therefore logically it should be rendered as high as possible in the component tree. Something like inside of the app component or anything like that. Now, I will go for the place where it actually is being caused, and that would be the add user component, but you can definitely also pick a different place. You then, of course, will need to update your state management appropriately. I will write state management code that ensures that it works here inside of the add user component. So here I want to output my error modal, and therefore we have to import it, of course. So we go here and import error modal from UI error modal. Now we also need to configure it. We need to set a title, and we'll soon set this dynamically, but now I'll set it to an error occurred and a message, which we can set to something went wrong. But this will not work. And do you know why? I briefly touched on it in the debugging section. Well, if we try to save this, we'll get an error. We'll get the error that we got adjacent JSX elements and that this is not allowed, basically. Indeed, React doesn't allow two side-by-side components being rendered directly as a root element of your return statement, and you therefore need to wrap this, for example, in an extra div. We'll later see a different solution for this. For now, we'll just take an extra div and put our error modal and our card into that div, so that the div is returned by the return statement, and then inside of the div, we can have adjacent elements. And with that, it compiles, and if you reload, hey, this doesn't look too bad. We got our modal here. Now, of course, it's not dynamic. Of course, we can't close it right now. And of course, one crucial thing is missing, and that's a backdrop for the modal. So an overlay between this modal overlay and the actual main page, so that we can't interact with the rest of the main page, which currently is possible. So, to make sure we can't interact with the rest of the page, back in the error modal, I'll add an extra div next to the card, not inside of it, but next to it. And therefore, as you just learned, we need a general div that wraps both that extra div and the card. And on that extra div, I'll add a class, and that's the classes.backdrop class. The div itself is empty, but this backdrop CSS class makes sure that we have this grayish, black, transparentish background behind the modal. If we now save everything, you can see the background here, and now I can't interact with the form anymore, for example. So with that, we got the modal in place. Now, of course, the goal is to show it only sometimes, only if we do try to submit invalid data, and of course, we want to make sure that we can also dismiss it. So let's make sure we only show the error modal if we entered something invalid. So in the add user component, currently, if we have an empty input or an invalid age, we just return. We cancel this function execution. I want to continue doing that, but in addition, I also want to show an error message in the future. And therefore, we need a way of dynamically showing and hiding this error modal. Put in other words, we need to update our UI conditionally based on the question if we have an error or not. And what does this scream for? State management. We need to manage some error state. And that could be a string, like the error message. That could be an object which bundles error, title, and message, whatever you want. But we need to manage such an error state so that we can set it to we have an error, in which case we want to render the modal, and so that we can set it to we got no error, in which case we render nothing. I mean, we still render the form, but we wouldn't render the modal in that case. So we need an extra piece of state here, use state, and the initial value is actually undefined, so I don't need to pass any other initial value here between the parentheses. Now I'll name that error and set error, because in the end I'm going to manage some error information here. And now again, it's your app, it's up to you how an error should look like for you, if it's just a string or if it's an object. I will manage an error as an object here. So here, in that first validation part, I will call setError and set this to an object.
In this module, it's time for fragments, portals, and refs. Okay, what's that? That will be more tools in our React toolbox that help us solve more problems. And in this module, we'll simply go through these different features and you will learn which problems they solve and why we need them and how you can use them, of course. We'll have a look at limitations we're actually facing with JSX code and how fragments can help us overcome those limitations. We'll learn how we can derive a cleaner DOM, a better code structure with the help of portals. And we'll work with refs and learn what refs actually are and why we need them. In React, we're working with JSX. We worked with JSX all the time here in this course already. In this course project, which we worked on in the last course module, which you find attached to this lecture, by the way, in case you didn't follow along, you can simply download it, extract it, run npm install and npm start, and you're good to go. In that project, we of course used JSX. JSX is that code you return in your components, which in the end will be rendered to the real DOM by React. That's what JSX is, and we use it all the time. But JSX has certain limitations. Specifically, there is one limitation which we also already faced in this course. If we have adjacent root level JSX elements, like in this example, we'll get an error. And with root level, I mean that we have two JSX elements next to each other, not wrapped by another JSX element, and we then return these side-by-side JSX elements, or we try to store them in variables. This will not work, because in React, in JSX in general, you can't have more than one root JSX element. So if you return a value, or if you store a value in a variable, or in a constant, or in a property, that value must only be exactly one JSX element, not 2 or 3 or 4 side-by-side adjacent elements. Now, that one element which you are allowed to have may of course have more children, which then also can be adjacent to each other. But that topmost element, which you're storing or returning, must only be one element. And the reason for that is actually not that difficult to understand, because this also isn't valid JavaScript. You can't return more than one thing in JavaScript either. You can return one number, not two. You can return one string, not two. Of course, you could return an array, and there you could have multiple numbers, but an array is already a new value. An array is just an object, so you still only return one array, one object, not two arrays at the same time, right? So that is really important to understand here. Your JSX code translates into React create element, like you see it here at the bottom of the slide. And you must only have one React create element call which you return. Now, any nested JSX elements, so inside of that one root element, could be side by side, because in the React create element world, those children of that root element would be the third and fourth and fifth and so on argument. And that's something I had a closer look at in the basics module, where we explored how JSX translates into React create element calls. But because of that natural limitation of JavaScript, we must only have one root JSX element. Now, how can we work around that? There is one solution, and actually we can already use that solution here in that add user component in that provided project which you find attached. Here I do have a wrapping div, and that is a workaround. You can solve this problem by simply wrapping the adjacent elements with a div. If you do that, if you wrap them with a div, then you only have one thing that you return, only one value. It's a bit like returning 3 numbers by putting them into an array. Here we're returning 2 nested JSX elements by putting them into one div, which we return.
Now, this also doesn't have to be a div. You could be using any element here. You could also be using a custom component here. The main thing that matters is that you only have one value which you return or which you store in a constant. And that's also what we're doing here. Now, there actually is also an alternative to that. Instead of using a div, we could use a native JavaScript array. I could remove my opening and closing div tags and put my card component here and that dynamic expression here into an array separated by commas. I just would need to remove these curly braces here because we're no longer inside of JSX here, we're inside of an array. That would be valid, but this has a little gotcha. We can return an array because React is able to work with arrays of JSX elements. We did utilize that when we output our list of users here, or also earlier in the course, you learned about mapping arrays of data to JSX elements in the lists and conditionals module. So React knows how to work with arrays of JSX elements, and hence, of course, here we could also return such an array of JSX elements. If we do that, and we preview this application, we do get a warning though. Because whenever you're working with an array of JSX elements, React wants a key on every element. And that's no exception here. It wants that key if you map dynamically through a list of data and map that data to JSX elements. But it also wants such a key if you have a hard-coded array of JSX elements as we have it here. Now, of course, we can simply add a key. And since this is not generated dynamically, we can hard code keys here, error modal, for example, and add user card. We could add the key prop with our own invented values, and we would be fine. And that would be perfectly fine. But typically, you don't use this solution because adding those keys, wrapping it in an array, is a little bit cumbersome. It's way easier to simply add a wrapping div here, like we had it before. So I can just go back to that, add my div here, and now wrap this here back into curly braces, and remove the comma here, because now we have a dynamic expression inside of JSX again, so we need the curly braces to evaluate this expression. So that's simply more convenient, and therefore typically we use the wrapping div. However, with the wrapping div, or generally any wrapping element, a new problem arises. Now we can end up with div soup. So we can end up with a real DOM that's being rendered where you have many nested React components, and all those components for various reasons need wrapping divs or other wrapping components. And you have all these unnecessary divs being rendered in the real DOM, even though they're only there because of this requirement or this limitation of JSX. And this is not an unrealistic scenario. In bigger applications, it's very possible that in your final HTML page, which is being served to your end users, you have a lot of unnecessary divs or other elements which are only there because you needed them as wrappers, even though they don't add any semantic or structural meaning to your page. Now, of course, you don't have to care about that. You might be fine with that, but it could break your styling. If you have a wrapping div somewhere and you use nested CSS selectors, that div could break stylings. And even if it doesn't break your styling, it's still not a good practice. You're rendering too many HTML elements, and ultimately that also makes your application slower because the browser needs to render all those elements and React needs to check all those elements, or at least some of those elements, if content needs to change. So rendering unnecessary content is generally never a good idea in programming. Hence, this wrapping div or this wrapping element approach is okay, but not ideal. So let me introduce the solution to you. What if we would use a dirty little trick? Here in my components folder, I'll add a new subfolder, helpers. I'll name it helpers because that best describes which kind of component I'm going to add. I'm going to add a wrapper component. I'll name the file wrapper.js. And in there, I won't even import React because I'm not going to write any JSX code in there. Instead, I'll just create my wrapper component, get props, and have my function body, and export this wrapper. And now you might be wondering what I'm going to do here if I'm not writing any JSX code. Well, I'll just return props.children. Remember, the children prop holds all the content you're passing between the opening and closing tag of your custom component. Now, it is valid in a component to just return that content which you got between the opening and closing tags. And now I can import my wrapper. For example, here in add user, I can import wrapper from helpers wrapper, and I can use it as a regular React component. So I can go down there and replace my div, which has no other meaning than fulfilling this JSX requirement, with my wrapper. So I'm using my wrapper component here. And just to make this really clear again, this is basically an empty component. Everything it does is that it returns props children. But this is enough to fulfill this requirement JSX has. If I save this, my application still works just fine. And it works just fine because in add user, we have a wrapping element. Sure, it's an element which won't render anything to the DOM, but the requirement is not that there must be one root component being rendered to the DOM. The requirement just is that there must be one root element that you return or that you store in a constant or variable. And that's what we're doing here. We have one root element, the wrapper, and what we pass into that wrapper may be adjacent. That is okay, as I explained. Now, of course, all that content is taken and just returned here, but that's also okay because in this return statement, I technically still only returned one thing. I returned the value in props children. And this can be tough to wrap your head around, but this is just a technical requirement of JavaScript around which we're working here. I just work around that requirement by returning one thing here and one thing here. And of course, what we get here in props children will be that adjacent content, but that will not be a problem because I never directly return that in my code. And this will therefore work just fine. This will not cause any errors, as you can clearly tell. Now that's a nice little trick for solving this problem, because if we now have a look at the Elements tab, and therefore at the DOM, which is actually being rendered, we see that if I inspect my add form component, here's my form, we see there is a div around it, but that's just this card div. But what we also see is if I click add user, that this modal div is being added, but around that, we do have a wrapping div, but this is actually the div coming from the app component, where I also have the wrapping div. This is not coming from inside the add user component. Instead, from inside there, nothing is being rendered in the real DOM. We got the card, and above that, nothing. Because again, this div, which is above it, is coming from the app component. And that is, of course, pretty sweet. So with that custom wrapper component, we could use a little trick to fulfill this requirement and not end up with div soup. Now, because it's so convenient and also so obvious in the end, at least once you saw it, this wrapper component is actually not a component we need to build on our own. Instead, it comes with React. There, it's the fragment component, which you can access on react.fragment, or you just import fragment from React. I will show you how to use it in a second. Or in some projects, you can also use this shortcut on the right, but this depends on your project setup because your build workflow needs to support this. The left syntax will always work. And that's the same as our wrapper. These two syntaxes here render empty wrappers, which don't render any actual HTML element to the DOM. It's just built into React, but I showed you our custom wrapper so that you understand what these built-in wrappers do. So if we want to use the built-in wrappers, let's say in the app component, where I said that we also had the problem, we can remove the div and just use these empty tags. Now that's not valid HTML, and it's also not necessarily valid JSX in all projects. Your project setup needs to support it. Now this project setup does support it, and if you downloaded this attached project, which was attached earlier, you therefore shouldn't get any problems. And hence now if you save, you see it also still works. Everything works. And if I get that modal again, you see now that one div which we had before, don't mistake it for the root div, there was another div before, is now also gone because I'm now also using this wrapper, this fragment, as it's officially called, in the app component. Now, if this syntax doesn't work or if you don't like it, you can always use react.fragment like this, and this will then work. So React fragment opening and closing, this will always work. You just need to make sure you're importing React. Or you directly add fragment as a named import here in these curly braces from React. Then you can also use it just by that name. So that's an alternative. So that, of course, is what we'll typically use, fragment or React fragment or this shortcut. We're not typically writing our own wrappers, but of course it is important that you understand how it works under the hood, which is why I showed it to you. Fragments allow us to write cleaner code to end up with less unnecessary HTML elements on the final page, and that's great. React portals are another useful feature which do something similar, which also help us write cleaner code. Consider this made-up example here. We got two elements, two components, side by side, my modal and my input form, wrapped by a fragment, but the fragment won't matter here. We already learned about that. And the actual content that ends up in the real DOM might look something like this. We might have a section and a h2 tag coming from some other components, because the code on the left is just one of many components in our application, let's say. And then we have that brown content, which is actually the modal, which is being rendered to the DOM in the end by React, and the orange part is our form. Now, what's wrong with that? Technically, nothing. Technically, this is fine. But there is something in this code which is not ideal, and that would be that modal. This modal code, which is being rendered here in the DOM, will technically work as long as you applied the correct styling. It will look like a modal, as you also saw in that demo project we worked on. But semantically, and from a have a clean HTML structure perspective, this is not ideal. Why? Because you have to keep in mind that a modal basically is an overlay on your page. It is an overlay to the entire page. So logically, it's above everything else. And if it's then nested in some other HTML code, it might technically work because of styling, but it's not good code. It's not a good structure. And it can even lead to real problems, again, with styling or with accessibility if you have such nested overlay content, because if, for example, a screen reader has to interpret your HTML code which is being rendered, it might not see this as a general overlay, because your CSS styling won't matter too much there, and from a semantical perspective, from the structure it has, it's deeply structured in other HTML code. So it's not obvious that this modal should be an overlay to all the other content. And that's not just the case for modals. You would have similar problems for side drawers, for dialogues, so typically for all kinds of overlays or any related components. It's a little bit as if you would create a button by simply styling a div like a button and adding an event listener. It will work technically, but it's not a good practice. It's bad for accessibility, it's bad if a fellow developer has to work with that, it's simply not a good idea. In web development in general, with HTML and CSS and JavaScript, because it's so forgiving, You can make a lot of things work, but that doesn't mean that just because it works, it's also a good implementation. It's also a good idea to use it like this. And that's where we can use another React concept to get rid of this problem with this modal, with this overlay content, which shouldn't be deeply nested. We can use a portal to keep the structure we have on the left, so to keep writing our components the way we want to write them, so that we have no friction when we want to pass data around and so on, but to still render this differently in the real DOM, and to, for example, render the modal HTML content somewhere else than it would normally go to. So that on the left, the JSX code we write hasn't changed, but the rendered HTML code is a bit different from our JSX code. So the modal there is not next to the form. And you can achieve this with React portals. So let's see how portals work. Back in this project, we of course have an error modal. This is a nice little modal where I actually already see an opportunity to use a fragment. So let's quickly do that. But that's of course not the focus here. Instead here, we can now use a portal, because this entire modal actually shouldn't be rendered in the place where it is being rendered. Again, let me show you what I mean. If we inspect the real DOM that is being rendered, and I trigger that modal by submitting an invalid form, you see the modal divs for the backdrop and for the card, for the modal overlay, are being rendered here next to that card that holds my form, inside of the root div. Now in this application, because it's so tiny, that's actually not too bad. But of course, it's easy to imagine that you have an application where your add user component is not that close to the top of the whole application, but where it's deeply nested in some other components. And therefore, your backdrop and your modal divs would also be deeply nested in some other content in your DOM. And I actually would want to have them, let's say, here. I can drag and drop them here in the dev tools. I might want to have that structure, the backdrop div right below the body, so as a direct child of the body, and the same for the modal, a direct child of the body next to that root div, which holds the rest of our application. And this is something you can achieve with, well, portals. So now that I told you that portals are that great, how do we actually use them? Portals need two things. You need a place you want to port the component to, and then you need to let the component know that it should have a portal to that place. Now, to mark that place, we go into the public folder and there into the HTML file which is being rendered in the end. And here it's common that you add a div with an ID which you will then use to identify this place later. And here I could have my backdrop root and then also maybe my modal root. And you could create multiple such roots for different kinds of components that should be portaled there. Or you simplify this a bit and you have your backdrop root and simply your overlay root, which will then hold all kinds of overlays, modals, side drawers, and so on. And that's what I'll go with. So I added these two divs here, and then I save that file and go back to my components. Now let's work on the error modal, and let's tell React that this actually should be portaled somewhere. For that, to make this very easy, I will actually add a constant here, which I'll name backdrop, and this will be a new component, and I'll add it in this same file because in this app, I only use this backdrop component in conjunction with my modal. So I'll store all those components in one big file, but you could also split it into multiple component files, especially if you would use the backdrop in conjunction with other components as well. Here I'll only use it there though, so then I have my props, and now here I will return that div which gets my backdrop class. Now I'll also add my modal overlay component here, which gets props. And there, I will return this card. And I'll actually cut this, like this. So I basically split my modal into two separate components now, backdrop and modal overlay, because that will make working with portals much easier. We can also remove the backdrop div down there in the error modal now. So what do we now do here? In the end here, in that fragment, we can add an expression because we're still inside of JSX code here. And we now want to call a method which is actually not defined on React, but on another library that comes together with React, the React DOM library. You can imagine React being the library that has all the React features, state management, and so on baked in. And React DOM uses React to bring that logic and these features into the web browser. So to make them compatible to working with the DOM. Put in other words, the React library itself doesn't care whether you run it in an environment that has a DOM or if you would use it to build a native app. And for example, you can use React Native in conjunction with React to build native mobile apps. I do have a separate course on that though, so let's not worry about that here. So React DOM is kind of the adapter for React to the browser. And therefore, since now we're going to portal something into a different place in the real DOM, we need to import from React DOM. So import something from React-DOM. And that something here can just be React DOM. So you can give this any name you want, but since I named my React import React, I'll name this React DOM. And on React DOM, you can now call a createPortal method. Now the createPortal method takes two arguments. The first one is your React node that should be rendered. And here I can render my backdrop, let's say, like this. Important here, it wants JSX. So you don't pass just backdrop like this. Instead, you really render it like this. This is also very convenient because this allows me, of course, to forward my onClick prop here and get access to props on confirm, which I need to pass here to ensure that everything still works. So I can now set onClick here in my error modal and forward the function I get on the onConfirm prop to the onClick prop inside of that new backdrop component. Now, the second argument of createPortal is a pointer to that container in the real DOM where this element should be rendered in. And in my case, I of course want to render my backdrop here in that backdrop root component. So back in error modal, here we need to select this, and we don't just pass backdrop root or anything like that. Instead, we really select the element where it should be rendered to. And for this, we use a DOM API. We use document get element by ID, for example, and get access to the backdrop root. So we really get access to a real HTML DOM element, a DOM node here. And we do this with an API that is provided by the browser. Document get element by ID has nothing to do with React. We really get access to a real DOM element with this API. Normally, we don't use that in React because we let React do everything, but here we explicitly need to use this. By the way, just as we needed an element selected like this in Next.js. There, we also rendered the root component with the render method into a place selected with get element by ID. We're using the same logic now, but now we're not rendering an element there, but instead inside of an existing application, which is already being rendered by React, we move the HTML content that is about to be rendered into a different place. With that, let me reformat this and save it. And if we now go back and I click on add user, you see the backdrop appears. The modal does not, because I haven't added the logic for this yet, but the backdrop does. And in the Elements tab, we see that in the backdrop root, we now got the modal backdrop. And now it will always be there, no matter where you would use your error modal in your JSX code, no matter how deeply nested it is in other elements. It will always be here, which is of course very close to the body. We need this marker here though, but we could have also selected the body itself if we really wanted it as a direct child of body. But I think this is a bit easier to understand, which is why I use these extra hook divs, if you want to call them like this. Now let's repeat this for the actual overlay. For that, I'll add a new expression here, React DOM, create portal. And here I want to render my modal overlay component. And my modal overlay component needs a bunch of props, which I now, of course, want to forward. It needs a title, it needs a content, and it needs onConfirm. So I'll just forward this. I'll forward the title, which I get on props title, the message, which I get on props message. I'll get my onConfirm was the last one, I think. Props onConfirm. Because actions, of course, is not a prop. So props onConfirm is the last one. Now I'm forwarding all of this. And now, of course, we also, just as with the backdrop, need to let React DOM know where it should render this HTML content that needs to be rendered. For that, I'll use document get element by ID and select my overlay root, which was that other div I created in the index.html file. And with that saved, if I reload and click add user, we see the modal, and interaction with the backdrop doesn't work, as I can tell. I will need to fix this, but with the modal it works, and we see everything is rendered in the divs where it should be rendered and no longer nested in our other HTML code. So let's quickly fix that backdrop. Yeah, I should of course forward this on onConfirm here, because I use onConfirm here inside of that backdrop. So I should set an onConfirm prop, but with that, it now works and I can close it by clicking on the backdrop again. So that's the portal. And the idea really just is that the rendered HTML content is moved somewhere else. In your JSX code, you now use that error modal just as you did before. Nothing changed there. In add user, I still have my error modal here. But it's now rendered. Its HTML code is now rendered in a different place. We use that error modal just as we used it before. And that's the cool thing about the portal. Nothing changes there. We can communicate with it as we did before. We can use it as if it would be rendered here. It just isn't. Also worth the note, React DOM create portal can be used anywhere where you would otherwise use JSX code. Of course, wrapped in curly braces because we're calling JavaScript code here, but we could have just rendered the backdrop here otherwise, right? That would have been our alternative. So wherever you would normally just use the component, you can use create portal to move that component's HTML content somewhere else. Only in the actual DOM that is being rendered. In JSX, in your components, you continue working with those components as you did before. Now with fragments and portals, we had two cool features that help us write cleaner HTML code. The app worked in exactly the same way before we added those features too. But with those features, we end up with semantically more correct HTML code. And that's never a bad thing. Makes your app more accessible, makes sure you don't render unnecessarily many divs, and in general shows that you are a developer who knows what he's doing. Now let me move on to one last key feature, which I also want to show you, which does something different than fragments and portals though. And that would be refs. References, but the name in React is just ref, so the short form of reference. What do refs do? Refs are actually quite powerful, as we will see throughout the course, but in their most basic form, they allow us to get access to other DOM elements and work with them. Now what do I mean with that? Let's go to the add user component again. There we have our inputs, and we manage what the user enters by simply keeping track of it. We simply have our state, and with every keystroke, we update our state. So with every keystroke, we update the value we get by the user, and we store it in our state, and we feed that state back into the input, and we then use that state later on to reset the inputs, but also to send it to the place where we need the data. So that is a perfectly fine way of managing this. But updating the state with every keystroke, when we only need it when we submit the form, sounds a bit redundant to me. And that's a scenario where refs could help us, though they're not limited to that. I will already say that. How do refs work? With refs, we can set up a connection between a HTML element, which is being rendered in the end, and our other JavaScript code. And for that, we first of all need to create a ref, which we do with the help of another React hook. We use the useRef hook here, and we then simply call useRef here in our code, in our functional component. And like all React hooks, useRef is only usable inside of functional components. Now, what does useRef return and which value does it take? It takes a default value you want to initialize it to, but we don't need this here. But I'm very interested in what it returns, because it returns a value which allows us to work with that ref later. So which allows us to work with that element to which we're going to connect it. And therefore here I'll name this name input ref, because I plan on connecting this ref with that first input which allows us to enter a username. So here we have the name input ref. Now I'll duplicate this and create another ref by calling useRef again, and that will be my age input ref. So now I got two refs, and they're just sitting there doing nothing. They're initialized to be undefined, because that's the default, and they're useless. Now we can let React know that we want to connect a ref to a HTML element by going to that element to which we want to connect the ref and adding a special prop there, the ref prop. Just like the key prop, that's a built-in prop which you can add to any HTML element. Because, and that's important, you can connect any HTML element to one of your references. You will very often do that for inputs because you want to fetch input data, for example, but you can do it with any element. So here I got my ref, and now I will pass name input ref as a value here. And name input ref is just that constant which stores this first ref. So with that, I'm connecting this ref, which I created in this component, with that JSX code that is rendered by that same component. And now a connection will be established. The first time React reaches this code and renders this code, it will actually set the value stored in name input ref to the native DOM element that is rendered based on this input. And that's important. What will end up inside of name input ref in the end will really be a real DOM element later. So let's do the same for the age. And here I'll connect this to age input ref. And that's now connected as well. So now the refs are connected. What's the benefit? Let's go to our add user handler function, and after event prevent default, I want to console log my refs. Let's start with the name input ref. If I log this here, and I go back, and I go to the console so that I can see the log, if I submit this, you see there's an object being output here. There is an object being output here, and that object has a current property. Now, that's important. This ref value, which is being generated here, always is an object which always has a current prop, and the current prop holds the actual value that ref is connected with. Now, by default, it's undefined, but as soon as this code ran, because of this ref prop, the name input ref is connected to that input, and hence, it's actually the input which is being stored as a value in the current prop. And what's being stored here really is the actual DOM node. So not some theoretical value or anything like that, but the real DOM node, which you could now manipulate and do all kinds of things with. Now, it is recommended that you don't manipulate it.
Your DOM should really only be manipulated by React. You're using React to let it do all the heavy lifting. But reading data from the input doesn't sound too bad, because you're not changing anything with that. You're just reading data. So here, instead of logging this here, we can, of course, read current value. Now, current refers to the value stored, and the value stored is the input element, and every input element has a value property in JavaScript. We can actually see this here. There's the value property. So if I now save this and I log this value, if I enter max here, you see max being logged here. And that's pretty cool, because that means we can get access to the value stored in the element without having to log every keystroke. We don't need state for this. We can just read it when the submit button is pressed. So that means we could now replace console log maybe with a helper constant, which we use inside of add user handler. I'll name that constant entered name and simply store my current value in that. And I do the same for the age. I add my entered age and store age input ref.current.value. Now, entered age clashes with my state here, so therefore I'll pick a slightly different name. I'll use entered user age here. Now we can check entered name here and entered user age here, and also entered user age here in this condition. So always the values we retrieved from the refs. And I also use entered name here and entered user age to submit it to onAddUser. Now with that, of course, we should no longer reset these inputs by resetting the state here though, because we're not using the state to get our values anymore. We currently still have those listeners, but we actually now don't really need those values anymore. We're using refs to get the values. So what we could do is we could get rid of these states here. So of these states where we listen to every keystroke. Therefore, get rid of these state updating functions and get rid of these two handlers. And also get rid of the value property and the onChange property on the inputs. With that, we shortened that code quite a bit, and we're relying on refs to read the values. Hence, if I add max 31, you see we still can add that user. However, during the process, we lost our resetting logic. Now, to bring it back, we got two options. We can switch back to the state-based solution, which is not bad, but I want to show refs here. Or we do something which you should rarely do, but which actually is okay here in the context of an input field value which you want to reset. You can manipulate the DOM without React. And yes, I said you shouldn't do that. You typically shouldn't do that. But if you just want to reset the value entered by a user, it is something you can consider doing. So we could use the name input ref.current.value and now set it to an empty string and repeat this for the age input ref. And with these two lines added here, if we now check this again, you see now it's cleared. Again, rarely do that. Rarely use refs to manipulate the DOM. Here, we're not really manipulating the DOM. We're not adding a new element or changing a CSS class. I'm just changing what the user entered. You could argue that you don't even want to do that. And in that case, you can always return back to the state-based solution, but I think it's fine. Now, in general, the question is not whether refs or state is better. You can use either of the two. You will sometimes have use cases where you just want to quickly read a value, for example. And if you only want to read a value and you never plan on changing anything, well, then you don't really need state, because just to use state as a keylogger is not that great. It's a lot of unnecessary code and work. So if you just want to read a value, refs are probably better. In scenarios like this, it's up to you what you prefer. Refs, which are a little bit less code, but you have this edge case of manipulating the DOM,
or state, which is definitely cleaner, but is a bit more code. It's up to you, but we will see refs throughout this course, and you will see them in a lot of projects, in a lot of React projects, because getting access to elements is quite convenient, and as I said, they can even do a bit more than that, but we'll see them again throughout the course. This is just an introduction, and this is all you need to know about refs right now. Now, in the last lecture, we learned about refs, and I showed you that with refs, you have an alternative way of getting that user input, of accessing those input fields. And I also showed you this a little bit hacky approach of then still manipulating the input fields and resetting them if you want to do that. Now, this approach of using refs to interact with DOM elements, specifically with input elements, also has a special name. We're talking about uncontrolled components if we access values with a ref. So these input components here would now be uncontrolled components. Why uncontrolled? Because their internal state, so the value which is reflected in them, is not controlled by React. We rely on the default behavior of the input, where a user, of course, is able to enter something and that entered value is reflected. And we then just fetch it, yes, with a React feature, but we don't feed data back into the input. When I set a new value to those inputs here with this workaround, we're absolutely not using React here. Sure, we're using the ref, but in the end, we get access to the native DOM element with that, and I then just use the regular DOM API for setting the value of a DOM node, of an input DOM node. So that's why this is uncontrolled, because we're not controlling the state of the input element with React. Now, you can talk about uncontrolled and controlled components also in the context of other components. But most commonly, we have this scenario when we talk about input components, about form components in general. Because those components tend to have some internal state natively by the browser. An input element is configured to take user input and save and reflect it. And when we then work with those components in a React app, we want to connect our React state to that. That's why we typically have this controlled, uncontrolled thing when we work with input components in React. And when we use refs, like we're doing it here, we have uncontrolled input components. The approach we had before, where we manage our state and we update that state on every keystroke and we feed that state back into the input with the value prop. So that approach we had before we added refs, that would be the controlled approach. Then we would say that those input fields are controlled components because their internal state is controlled by React. These are simply important terms which you should keep in mind for potential interviews or discussions with other React developers because they are typical terms you hear in the React world.